Okay. Oh, yes, I'm on. Excellent. Right, let's do it. Okay, start my timer. Great. All right, good morning. Hello, everybody. Welcome. Morning, Niall, and everyone else. Nice to see you all. I'm very happy that you made it out of bed and into this session this morning for another session about AI. There's been quite a few sessions about AI at this conference, right? It's almost as if there's something going on in our industry to do with AI at the moment. Don't know if you get that impression. Well, obviously there is. I'm kind of curious, actually. How many of you put something that you would consider AI into production in your applications today? That's not very many. Okay, so that's like 5% of you. So there's probably a huge amount of growth potential in this area at the moment. And so this is what we're going to focus on in this talk today. So my name's Steve. Good morning. Nice to meet you. I work at Microsoft, and I work on the .NET team. I do a lot of web-related stuff. So at the moment, one of the things I'm looking at is how can we make this really practical and sensible for .NET developers who are coming to AI development? How can we make it as straightforward as possible to make genuinely useful AI? So not just the sort of AI that sort of checks a box, but actually does something beneficial for your users. So let's think about what that might mean then, firstly. What does it actually mean to make your app intelligent? Does it mean you are going to add a chatbot to it? Well, I mean, it could be, but that's clearly not the whole story. So let's just consider a few of these statements. Which of them do we actually consider to be true? Well, does throwing a chatbot on something enable you to make a cool demo quickly? I think the answer to that, for sure, is yes. It's brilliant for that. That's one of the best things that you can do with chatbots. You can make a cool demo in one day, probably, quite straightforward. And if you're willing to be evil and cherry-pick your examples, then you can make your demo look really good as well. So it's a good way of impressing your boss, if that's all you're trying to do. But then if you try to put it into production, are people going to actually use it? Well, maybe. It depends. Does this thing actually save people time and enable them to do their job better than they would have otherwise? Maybe. As for accuracy, well, I think my challenge to you is let's talk numbers. Let's not just sort of wave our hands and say, well, we sort of think it might be, we hope, might hallucinate a bit. Let's have actual numbers so that we can measure it, and then we can make sure that it's good enough and that we're improving it in a practical way over time. As for it being the only way, well, it's very often, chat is not even the best user interface for a particular type of task. There are many other ways that you can add intelligence into your applications, different kinds of UI patterns. You can have semantic search. You can automatically summarize large amounts of information. You can do a type ahead so that people don't have to press every key on their keyboard. You can do things like triggering workflows automatically based on categorization, many different things. And we'll look at some of these patterns this morning. And so given all this complexity, you might think, is it really even worth it? Can I just ignore this whole AI thing and see if it goes away? Well, I think actually there are some real genuine benefits that you can bring to your users. And ultimately, I hope that what you think that you're trying to achieve here is benefiting the human users of your actual software. So you're trying to bring more control, freedom, productivity, satisfaction, and other good things to the human beings who are actually using your software. And the way that AI can do that, well, it can do it in a few different ways. One of the main ones is by bringing the right information to people at the right time. So AI can be very good at picking out an individual bit of data that's the most pertinent thing for a person to look at right now. It can also be good at aggregating over lots of data and showing the overall patterns or the overall summary so that people don't have to plow through it all themselves. And the net effect of all this is that you're giving your users a way of skipping the mundane parts of their job and being able to get to the bits that you actually value them for. So the bits where the humans can bring their own decision-making, their own creativity and personality into it, and skip over all the boring and mundane parts. So that's really what we're trying to go for with this. And there are different ways you can approach it. So we're going to get quite deep into this later in the talk, but we're going to start at a surface level with a very straightforward way of getting started if you want to add a bit of AI into your application. So Smart Components is an experiment that we've been running over the last 6 months or so. You can try it out if you go to this URL. It's a set of samples that allow you to add AI at the UI layer in your application. So you've got an existing app. You don't want to rebuild the whole thing. You're not changing the whole back end or anything like that. You're probably not even changing most of the screens, but you can just make them more intelligent. So let's have a look at how that might work. So imagine that you've got a web UI like this. Okay, it's a mailing address form. We've all seen things like this, pretty normal. All right, and imagine there's some user whose job it is to fill it out. And they get some data that comes in, like maybe they receive an email from someone saying, hey, please add me to your system. And you say, okay, Veronica Ortiz, I'm going to add you to the system. So you come along and you start typing Veronica. And you think, oh, hang on, I think there was a special I or O or something in there. How do I type that? I don't know. I know, I'll just copy and paste the name, and then I'll copy and paste the phone. And then at this point, you just go like, no, I can't do it. It's too boring. Like, I'm a human being. I can't do this sort of drudgery. Can we make this better? So they would go to the developer and they'd say, can you somehow make my job not suck? And you would go and think, well, maybe. I've heard about this cool AI thing. Let's see what we can do. So you might come into the source code for your application. So here we've got that form, that mailing address form. It's written in Blazor in this case, but it could be written in other things. Smart Components works with MVC and Razor Pages as well. And you could look through all this and you think, OK, how about down here at the bottom, we're not going to change anything else, but the one thing we'll do is we'll just add this Smart Paste button into the system there. All right, so what is that going to do? Well, we come back over here and reload it, and we see our Smart Paste button. And now our user can copy all of this text to their clipboard like that and hit the Smart Paste button. And then we're going to use AI to fill out the whole form. So we take the contents of the clipboard, we match it all up with the different elements in the form, and it's going to fill it out. And it's not just for mailing address forms. It should work with more or less any form. So here's another one that you'll all be familiar with. So sort of bug tracking type thing with projects and item types, steps to reproduce and stuff. So wouldn't it be nice if when your boss sends you this message over Teams, you could just copy their issue report and then go and Smart Paste. And what's that going to do? Well, obviously, it's going to fill out the whole form for us, pick the right drop-down entries, add in all the steps to reproduce and stuff like that. Okay, so that's just one example of this. Another example of making stuff intelligent just at the UI layer, this smart text area. So in this case, let's imagine that there's an HR administrator who has to answer questions from employees. So maybe they get a question about, like, what's my vacation allowance? So they say something like, your vacation allowance is, and then they're like, I have to go and check the policy now, and then I'll probably have to type out some URL to show you where it is in the policy and stuff. It's too boring. Again, I'm not going to do it. I'm just going to go and complain to the developers who work for the company and say it's their fault. They should have made this better in some way. So you, the developer, get their complaint, and you go, OK, well, fine. I'll make stuff better for you. And you'll come and have a look at the form, and you'll say, aha, I see what the problem is. The problem is that you were typing into a boring old HTML text area that's got no intelligence whatsoever. So let's replace that with a smart text area. And we'll configure it so that it's in this role of HR admin, and it's got these phrases that are configured. And they define different things to do with the policy in this company, like how much vacation you get, where the policy is written, what the HR email address is, things like that. Okay? So now when they type, your vacation allowance is, then at this point it will do nothing at all because I didn't save my changes or something like that. Let's try that again. All right, your vacation allowance is, and then at this point still nothing whatsoever. Such an awesome demo, cool. Why is that happening? I do not know. So I'm going to just redo this one more time. No, for no reason at all, that's not working. And that's really fascinating, but let's just ignore that. Imagine that what happened is it filled out the text area with the stuff that would have made sense for them to type. So it would have said, your vacation allowance is 28 days. And then the user would carry on typing something like, for more info, and then it would fill out the URL of where they would have gone to. And then whatever they type, it fills in the relevant bit that continues from there, except I've obviously done something wrong. OK, final example that we'll look at, smart combo box. So you know a typical combo box, when you start trying to search for stuff in it, it will do a substring match. So if you want to find something, you need to more or less know what the text is that you're looking for. But what if the user doesn't know the text? Well, in this case, let's say that I want to submit an expense report for a plane ticket. I don't know what the expense category for that is, so I'll just start typing plane, and then you'll see it's going to do semantic matching. So the word plane doesn't appear in these options, but it matches up semantically, so it's going to show me that. Or if I search for pets, then I'm going to get pet care, or cats will also match pet care, so it knows about the relationship. Or if I've got an issue tracking thing, maybe I'm trying to report that something is slow, and it'll tell me that the right label for that, in this case, is performance. Okay, so that is doing semantic matching, and we'll look into how that works in a little bit. Okay, but the core point that I want to make with this is that it's a really straightforward way of starting without having to really change what's going on behind the scenes in your application. So that's just doing stuff at the UI layer. All right, but let's spend the rest of our time going a lot deeper than that. So let's imagine now that you're feeling the benefits of this, and you're thinking, well, how good can we make stuff if we were able to add AI at many different layers within our system and really start to make use of that? Is it actually useful in the type of applications that you build? Well, let's think about it. And I'm going to try and make this as relatable as possible. So I'll use a very traditional, typical kind of web application. So e-commerce, right? We all know about e-commerce. And there's kind of a web app where you have forms and data and grids and all that kind of stuff. Like, we all build that kind of stuff. So imagine that there's this e-commerce site called eShop. You may have seen an eShop sample that we've got. This is going to sort of extend the eShop universe into the world of the staff that work for that company now. So we've got customers who file support requests. They bought something from eShop, and then they say, actually, I've got a problem with this, and they come to this UI, and they can fill out details about what their question is or what their problem is, or submit a return request or that sort of thing. And then that goes to the staff that work for the company. All right, so what are the staff going to see? Well, they've probably got some web view that shows them like what tickets are open and closed and gives them the ability to search. And then the main bit of UI here is probably going to be some sort of big grid. All right, so very, very typical kind of thing. Okay, now, is AI going to deliver any meaningful value in an application like this? Well, yeah, I think it can do. So the first point is semantic search. So whenever you have any sort of search field, I would start thinking, is this beneficial to make it a semantic search? So that the user doesn't have to know exactly how things are phrased, and it doesn't matter if they've got typos or whatever, it's just going to find the relevant stuff most likely anyway. All right, that's one. Second example, summarization. So this title column here that we've got, who do you think writes those titles? Well, we don't want to force the users to write titles, because even if we do, they'll just write garbage like help or something like that, which is not going to help you to distinguish this item from the other items. So how about we use a language model to make a nice distinctive title for each thing so that the support staff can quickly find it. Okay, next one, classification. We've got this type column. Again, we don't want to trust the end users to pick the type for their thing, because they'll probably pick the wrong thing. And although we could trust the staff to do it, how about we just save them the trouble of doing it? And in fact, if we can do the classification up front, then maybe we can trigger different workflows on it, like based on whether it's to do with returns or whatever. And finally, sentiment scores. So just a simple thing that we can use to help staff direct their focus to the areas where stuff is most urgent. Okay, and then let's continue. Let's imagine now that the support staff has clicked on one of these items to go and start working on a particular support ticket. What are they going to see? Well, there's probably going to be some part of the URI which is various fields that they can work on. And we've already established that we can do a bit of AI for classifying these things. And we've got a search thing there, so we're probably already starting to think, well, we probably could do some semantic search so that we don't have to worry about typos. And then there's going to be part of the system where you get to actually interact with the customers, where you see their question, you can type out your reply, and so on, and you have the whole train of correspondence. But the problem is, that might be a really, really long amount of text, and it might waste a lot of staff time rereading from the beginning every single time they open this. So why not use a language model to produce a nice short summary of the entire correspondence so that they can get their bearings very quickly as soon as they enter this thing? And then they've got to actually answer the question. Now, maybe every support staff knows about every single product, but more likely they don't, and they have to look up information. So this is the kind of case where, yes, it's really actually useful to have something where you can get something to look up information for you with this kind of Q&A system, or it's often called RAG, Retrieval Augmented Generation. We'll look at how that works. But to make sure that's actually reliable and accurate, we can force it to give citations for all the claims that it makes so that the staff can actually check that this is for real. And then finally, when they come to typing out their replies, what you would have seen if my demo had worked is that we could have a type ahead system so that we can automatically insert content that is relevant based on the context generated by the assistant. So for example, if there's a link to the manual and the user seems to be typing something like that, then we can fill in the rest of it automatically. So I think even in this very traditional web application, there's clearly lots of opportunity for AI to add a lot of genuine value that will help your staff actually be more productive. So let's have a go at building this, shall we? Now, I know that if you're unfamiliar with this, it does feel a bit bewildering, like you've just been dropped on this island, you've got no idea your way around it, no one gave you a map, like where do you even get started creating something like that? What libraries are you supposed to use? What's the development process? So we're going to go on a little journey now around this island, and we'll pick up the different bits that we need to do along the way. And where we're going to start is with data. Here we go, yes. Great, so obviously all applications need data, but AI applications more than anything, really, because that's like the lifeblood of the system. You can't really even get started until you've got some data. So we're going to start with generating some data, and that will allow me to introduce some of the core APIs that we need to use. So we're going to use Semantic Kernel, which is a .NET library for working with AI systems, and we're going to use Ollama, which is a way of running large language models locally on your development machine. All right, so you are going to have to bear with me for the first 5 or 10 minutes because we're not even going to start up the web UI during that time. We're just going to work with data in the abstract. And the way we're going to start is we're generating some product data. We're going to start by generating some categories for products in this system. And the main API we'll use is this thing called iChat Completion Service, which is an API provided by Semantic Kernel, and that's an abstraction over language models like GPT or anything that can be served by Ollama, different things like that. Okay, so what we're going to do initially is we're going to set up this prompt that says, generate me a bunch of product category names, and I want you to reply in JSON in this format with some brands as well. And if you're wondering what is the implementation behind this interface here, well, I've set up initially Ollama as the implementation. Now, this method doesn't exist in Semantic Kernel yet. It's being added, but you can build it yourself in not too much code. It just makes HTTP requests to Ollama. So I want to run Ollama here on my laptop. So let's start that up. And then I'm going to start this data generator going. So that's now making requests against this, which is running locally. It takes a few seconds to start because it's loading a whole language model onto the GPU on this device here. And once it does get started, it's going to start producing some data, and it will start writing that out to disk. So let's see what data it's actually produced just now. If I go over here, we'll see we've generated a bunch of product categories. So we got camping and hiking, we got water sports, and some other stuff. And we could obviously go on generating as much of that stuff as we want. Okay, now, we don't have to use Ollama if we want to. Because we've got this interface provided by Semantic Kernel, we can easily swap it out for a different backend if we want. So in this case, I'm going to swap it out for OpenAI, mainly just because it runs faster on my laptop, and I don't want you to have to wait. And then I'm going to generate a lot more data as well. So instead of just generating categories, I want to generate the entire universe of data for my application. All right, now, here's a little pattern you can use. If you want to produce more data than is possible to emit from a single prompt, you can chain things together in a way to make it all mutually consistent. So what I'm doing here is, first I'm generating some categories, like I just showed you. And then based on that, I'm generating some products that are in those categories. And then based on the categories and products, I'm generating tables of contents for the manuals. And then based on the tables of contents, I generate the entire text for the product manuals. And then Based on that, I convert them to PDF. And based on that, we generate some support tickets that customers might have related to these products. And based on that, we generate an entire thread of conversation with the customer support. And based on that, we generate a summary, and so on all the way through. And if you want to know how each of these works, pretty straightforward. Just like you saw before, they're constructing a prompt, they're injecting some data that we've already generated earlier, and we're getting it to return some JSON that we store. All right, so let's start that running. And just waiting for that to build. OK, so that is now going to run, I expect. Here we go. Right, so it's an incremental system, so it'll use the categories that we've already got, and now it's making calls out to OpenAI, in this case, to generate more stuff. So we've generated a bunch of products, like we've got this GPS navigation system and smartwatch and so on. And then based on that, we're generating the tables of contents for our product, and you can see it's got this nice hierarchical structure. I've picked a few different random descriptions of what the style should be, just so that they all feel a little different from each other. So we'll get different outputs from there. And then it's generating the entire contents of the manual based on that. In this case, it's coming out in Markdown format. So it's just expanding on all those tables of contents there. All right. And so once it's done that, it will hopefully also start producing some PDFs for us. Just waiting for it to do a few more of those. All right, and so PDFs are going to start appearing. There's lots of .NET libraries for generating this sort of thing. It's not too difficult. Let's have a look. So here we go. Here's our first one. All right, so we've got this entire product manual for this GPS navigation system that we just created. Obviously, it's loads of fake data, but it's going to help us to build our system in a useful way. And it can add things like tables and diagrams and stuff like that, because it's all part of the prompt in there as well. All right. So that is enough for us to get started. Let's just shut some of this stuff down. OK. Right, so we've been able to get started by generating some data using semantic kernel and with OLAMA. Okay. Now, the next step is to be able to get that data into our system. Obviously, if the data is in a nice format like JSON, it's very easy to pull it in. But in a lot of real-world cases, you need to pull in unstructured data that comes from the real world in some way. So for example, you might have a set of real PDFs that are actual product manuals, and you need a way of getting them into your system. Or it could be other things like Word documents, SharePoint files, whatever else that comes from some external system, and you want to pull it in. So the example we'll take in this case is the PDFs, because that's what we've just got right now. So let's have a look at how we could do that. There are various off-the-shelf systems for ingesting data, but I was wondering, well, is it really that hard for us to write a bit of C#? And to do it at a basic level, it's really not that hard. So let's look at how we could ingest these manuals. So I'm going to start running this now. And we're just going to treat these PDFs as like a black box external system and see what data we can pull out of them. So we're looping over all the PDFs that we've generated here. And then I'm using a library, a .NET library called PDFpig, which is a pretty good open source library for extracting information from PDFs. So I'm going to move on a few pages, and then we'll see here that we're currently looking at page number 4. Oh, well, it was there. And we can ask PDFpig to pull all the text out of that page, and we do get all of the page. Well, there's very little text on that page, but on other pages, there's going to be more text that's more interesting. So let's see. Here's a page with more interesting text on it. Okay, and then the next thing is we need a way of splitting this up. So we've parsed it. The next step is to chunk it. We need to extract different small fragments of data from our source so that we can find the most relevant ones. It's no use that when you do a search for just return an entire page worth of data. We want to return smaller fragments of data that are most relevant to whatever query is going on. So we need a way of splitting it up. And one way of doing it is this API in semantic kernel called text chunker. And that will split up our text into blocks that are around 200 characters in this case. But it doesn't just do it every 200 characters. It tries to be a bit smarter, and it'll split on natural boundaries like paragraphs or sentences, lines, or whatever, instead of just splitting in the middle of words. There are other ways of doing chunking as well. In this case, it's produced 3 chunks from that one page on natural boundaries. And then finally, we're going to embed them, which means that we want to extract the meaning from them and place them in this semantic space. I know that sounds very abstract. I'm sure many of you already know about what embeddings are, but for anyone who doesn't, an embedding is a way of representing the meaning of some text by turning it into a vector. So imagine the vector was three-dimensional, like three-dimensional space, which it isn't, but imagine it was. Then maybe all the text to do with dogs might be over there, and all the text to do with ice cubes might be up there. And if that was the case, then all the cold things are likely to be more in that direction, and all the things with legs are probably more in that direction. So it gives you a sense of how stuff will be distributed over space according to its meaning. That's what an embedding is. In this particular case, we're using an embedding model that is converting each of these strings to a vector with, let's look for it, 384 dimensions. So it's a 384-dimensional vector, and that's pretty standard for many types of embedding. All right, so we'll just run that through to the end now, and there we go. So it will have generated some chunks from our data, and if we want to have a look at what that actually looks like, we can see it's produced all these different chunks. So for each of the products and each of the pages, it's produced a bunch of chunks, and for each one, we've got an embedding, which means that we can now search through that data set semantically. And to actually see that running for real, I've made a simple console application that does it. You wouldn't actually have a little console app like this in a real project, but just to fully make sure everyone's got a sense of what this looks like, this is how we can do semantic search. So I'm using another semantic kernel abstraction called semantic text memory, and I'm loading that JSON file into it. And then I've got a little loop where on each loop I read some stuff from the console, and then we're going to try and search, and we'll output the most relevant stuff. And the implementation of this search is really, really straightforward. Anybody could write this. Semantic search is very straightforward once you've got the vectors. All we have to do is order things in order of similarity, which in this case is cosine similarity. So we're just dot producting the two vectors together, and we're going to get the ones that are most in the same direction as each other, and that will give stuff that's semantically similar. So only a few lines of code needed to implement that. So if I search now for something like, I don't know, we said ice before, we didn't say ice cubes, then it's going to return a bunch of stuff that's relevant to that. So we got all these coolers and things like that. If I searched for, I don't know, use outdoors, then it will return things to do with can stuff be used outdoors or not, because that's, you know, most in the same direction as the embedding vector of my search query. All right. So I know that was all a bit abstract, but we've got to the point that we've got some data. We can generate it as much as we want, and we can pull it into our system, and we can start doing things like semantic search over it, even though it came from an unstructured format. So I think we're ready to actually start our journey now, so we can follow along and get to the point of actually doing some inference over it. And so I think at this point, let's actually start up our real web application and get a sense of how this is going to look and work. So I'm going to start up now my app host. So this is an Aspire application. Aspire is going to help us out in a lot of ways as we go through this process. So if you don't know Aspire, I know most of you will, but if you don't, it's an orchestration system for .NET. So it's a way of creating software that's not just one executable, but is many, many different projects, many different Docker containers, different executables, and so on, and making them all work together. So here are all the different things I've got running in my application right now. You don't need to know what most of them are. The main characters that we're going to concern ourselves with are this backend project, which is minimal APIs, and that's got a bunch of back-end stuff in it. And then we've got these two web UIs, one for customers and one for staff. They're both built with Blazor, and Aspire deals with allowing them to discover each other and know each other's URLs and so on. So let's start up our our staff web UI, and you can see it looks a lot like our mock-up. So we've got our list of support tickets. We can go into one of those, and we get our entire conversation history with this customer. And like you can see, it's too long to read. Nobody can be bothered to read all that sort of thing, and it would waste too much staff time if they had to. So the first thing that we want to add in here, the first bit of inference, is going to be some summarization. And hopefully, as we go, you'll be able to see how Aspire can help out with doing that. OK, so This is not going to be very difficult. What I want to happen is, every time someone posts a message here, whether it's staff or customer, I want to generate an updated summary for it. So let's say if I reply with a completely stupid and annoying message that's just going to bother the customer a lot, who's frustrated. So I'll just send them that stupid message. What I want to happen at that time is a summary to appear. So I'm going to go into the code and see the bit in the back end where we receive that message. Okay, so this is where we set up receiving a post request for a new message that comes in. This is where we actually write it to the database using EF. And then what I want to do is generate a summary of the entire conversation log at that point. And the implementation for that does what you might be able to predict. So we're using iChat completion service, which is the same semantic kernel API that I showed you before. And we set up this prompt that says, your job is to write summaries. Here's the information about the product and the log of messages so far. And then I want you to reply in this JSON form, giving me a long summary and a short summary. And also, while you're doing it, you might as well estimate the customer's satisfaction level. Okay, so what is the implementation behind the iChat completion service in this case? Well, in this case, it's coming from the app host. So Aspire is able to direct each of the projects that it hosts so that they will use whatever services it tells them to use. So in this case, what I'm doing is I'm telling it to use Ollama by default. So it's going to run locally on my machine. But this time, I don't actually have to start up Ollama manually, because actually, I'm even going to shut down the one that I did start up manually, because Aspire is fully able to start up containers for us. So in this case, I'm saying one of the containers it starts up is Ollama. It can tell that to fetch whatever models that I'm using and cache them locally and so on. So hopefully that will now just start working. So if I just send another stupid message to the customer like this, it's now going to use Ollama to generate the summary of the whole case. It does take a little while because, like I said, Ollama takes a little bit of time to start up when I'm running it locally. In fact, in this case, it's seemingly taking an infinite amount of time. So we're not seeing it at all. No, there we go. It's done it. All right. So it's produced the summary, and now the support agent's able to move a little bit faster with all that. OK, now, I don't want to keep making you wait for Ollama to start up locally, so I'm going to switch this over to use OpenAI locally, which is going to be quite a bit faster for us. So if I restart that now, then hopefully this time we won't be waiting quite as long. But you may well have more powerful hardware and not be giving a presentation at the time, so your system will probably be a little bit more reliable than mine. All right, so let's try this again with a different ticket. So we'll go in here and just send another message. And at this point, it's now going to not use Ollama. It's just going to go straight to OpenAI and produce the same stuff without any other code changes. You can also see that it's generated these short summaries that we're able to use for the titles here, and it's able to generate an estimate of customer satisfaction. In this case, 0, so that's pretty harsh. In this case, it's just 1. But you can set up your own scale for how that works. And I'll just give you a little tip while we're on the way. When it comes to those customer satisfaction scores, I know it's tempting to tell the model to give you a number, like give me a number from 1 to 10 or a percentage or something. But I'd advise don't do that, because language models are models of language, not of numbers. And they're really bad with numbers. They'll just produce really poor quality results. So what I find, and what I think most people find, if you want it to produce numbers, don't ask for the numbers. Just give it a bunch of really emotional terms like furious and unhappy and delighted and things like that, and tell it to pick one of those as a label. And it'll do a much more reliable job of that. And then you can just map it back to a number afterwards. OK, so that is some simple summarization, and we've seen how using Aspire enables us to swap between different things, such as adding an OpenAI. And in fact, there's one other bit of Aspire I want to show you here, which is to do with the tracing. So this is going to show us all the stuff that's been going on with this particular user. You can use this both in development and in production if you want to. And if we look through here, excuse me, one of the things you'll see that we've been able to trace is calls to the chat completion service. So here, it's captured that we made a call to GPT-3.5, and if we look through all the properties on that, it's a little tricky on a small screen, but you can sort of see it, that we've got the number of tokens that came back in the completion, so we can estimate the cost, and if we scroll down here, we can see the entire prompt that went in and the entire completion response that came back. So if you're needing to debug your system or try and make sense of what's going on in production, then this kind of tracing is obviously going to be helpful. Okay. Right, let's move on to the next form of inference that we might want to do. And we are going to do the classic thing now of Q&I or RAG, Retrieval Augmented Generation. So let's make our chatbot actually work here. So, all right, so let's go into a different support ticket here. Let's go into this one. And the first challenge we have here, or it's a challenge for me anyway, is that they've made their request in German, and I don't speak German. I'm sure some of you do, but let's imagine our support agent does not. So they might think that they can ask the chatbot, what are they asking? Like that. But it's not actually going to work just yet because we haven't implemented this part of the RAG system. So we are going to go and see how that code works and put in the relevant bits of code so that it does work. All right, so we've got this bit on the back end here, which takes these requests to chat, and it's going to return a response in a streaming way so that we can update the UI in real time. Okay, and we've got this massive prompt in C#. There's this big string literal. There are other ways of doing it as well, but this is fine for now. The main thing to notice here, don't bother trying to read all this. I'll tell you more about it in a minute. The main thing to notice is that it's just a hard-coded string. Like, there's no context information. So obviously, it can't answer the question. It has literally no information to use to do so. So let's insert a little bit of information into this prompt. We'll supply the product ID, model, customer name, the summary that we actually generated earlier, which is useful for it, and the last message from the customer. Okay, so let's see if that's able to be a little bit more useful to our support agent now. So I'm just restarting that and come back over here and go back into which ticket is this one. Let's close all the others. All right, so now we'll ask them, what are they asking? And at this point, based on the fact that we've actually got some context, we get a sensible response back saying, you know, they're asking about the maximum distance they can be from this speaker. And so then we might try to ask another thing like, let's just click this button. What does the manual say about this? Well, at that point, it's still not going to work because we haven't implemented the ability to do searching. And that is the core thing within RAG, retrievement, augmented generation, is the ability to retrieve stuff. Okay, now, the normal way of doing RAG is to use a feature called function calling. So you can configure the language model with some callbacks, and you can say, okay, if you need to, you can call my function, and I'll give you answers to stuff. So you might have a function like search the product manual, and the RAG system will call you, and then you will provide the details from the manual. That's great. Except that only works with OpenAI and Mistral and Gemini, but not all language models work that way, okay? And I want this to work with all the language models, including all the just random stuff that I'm running on Ollama locally. So we can sort of make this work well enough by doing our own form of function calling. So the way that we can do this is we can say, hey, when you reply, what I need you to do is first decide, do you actually have enough information to answer this question? Give me a true or false on that. And then, if you're saying that you do have enough information, at that point you can give me the answer as a string. But if you don't have enough information, then say that you don't have enough information and give me a search phrase that we can use to look stuff up in the manual. And then we can set up a little loop where we go through a certain number of iterations, we'll set a maximum, and on each iteration, we'll ask it the question, and we'll see what it's responsive. So we'll stream the reply to the UI, so we can see it in real time. And when it's finished, we'll check it, we'll pause it and say, were you giving me a search phrase? If so, then I'm going to perform a search. And I'll insert that into the chat history, and then we'll run another loop of the iteration and see if it can produce a better answer this time. So now I'm going to insert the real search logic, and that's going to do the exact same thing that you saw when I ran it in a console application before, and it will do that semantic search. It will add that into the chat history, and then we'll run the loop again, and we'll see if it's able to produce a useful response this time. All right, so this time when I say, what does the manual say about this, then instead of saying, to do implement searching, it's actually done a search, it's gone to the manual, and it's produced some relevant content. But the most important thing is it also produces a citation. So it's telling us where exactly in the manual it got this information, so the support staff can click on that, and they can go right into the manual, it can highlight the exact bit of text that is the basis for its claims, and they can check that it's actually telling the truth and not just making up some garbage. So then they can come back and they say, okay, fine, write a reply saying that, and it will hopefully produce a reply based on this context, except in this case, obviously, we want it in German, like that. So now it's going to produce our reply in German, okay? And then once it's finished that, we can simply click on this user's reply button because it's classifying its own responses about whether they're suitable to send to the customer or not. If they are, we show this little button, and then we can hit send on that. And of course, it goes to the customer, and it produces a nice little summary, including stating what the support person did. Okay, so that is the core thing of a RAG type system. There's many ways you can go further with this. Much more sophistication is possible, but this gives you the sort of basic core kind of idea of how that might work with any model. And it's even easier still if you're able to use function calling, because then you don't have to implement all this stuff of checking whether you've got enough information manually. Okay, right. So last bit of inference that we're going to look at. We're now going to look at other types of models. So far, everything that we've done has been based around large language models, which is kind of like the generic tool that can solve any problem in theory. But, you know, it's kind of big and expensive to call and time consuming. And for many types of problems, you can solve them with much smaller models that you can just run locally and more cheaply. And in fact, if you go on Hugging Face, you'll find there's literally hundreds of thousands of small models that people have put up there that do things like classification or toxicity detection or all kinds of other small bits of translation and rephrasing and sentiment analysis and things like that, lots of different models, and you can run them all. But one challenge you might face is that all the examples they give are in Python. And this is one of the sort of common objections that people have when we talk about building this sort of thing in .NET, is they say, oh, but you know, doesn't most of the AI world use Python? Like, wouldn't you be better just writing your application in Python? And as for getting started, yeah, you probably are, because you can just copy and paste a whole bunch more stuff. But when it comes to actually managing this thing in production and using the skill set of your whole team, well, you know, you need to make that judgment for yourself. But I think a lot of people are going to prefer to use .NET for the broader system. So that leaves us in a little bit of a quandary. Like, maybe we do want to use Python for some things. Can we do that? Well, the answer is yes. The message I want to try and put out here is you don't need to be limited to .NET, okay? Even if the majority of your application is in that, if you want to use a bit of Python or a bit of Java, a bit of Node, whatever, you can do so very straightforwardly. And an orchestrator like Aspire is designed to make that more straightforward for you. So what we're going to do now is we're going to use a bit of Python and a small model from Hugging Face to do some automatic classification. And it's really quite straightforward. So down here, I've got a Python project. Now, Visual Studio has pretty good support for Python. Obviously, VS Code is just going to show you those files as well. So it's not hard to do it in your development process. And I've got my main.py file. It's really simple. So I'm starting up a Fast API web server. Fast API is a bit like minimal APIs in .NET. It's a way that you can plug in different HTTP endpoints. And I've included a couple of endpoints, one for a classifier, one for an embedder. The only one we're actually going to look at right now is classifier. And the logic for that is just this. So very little code. This is the bit where we actually register the HTTP endpoint. And as for what it's going to do, well, we're going to use this library called Transformers, which comes from Hugging Face. And that is able to fetch models that have been published there. Here we've got a reference to this model that I've found that does zero-shot classification. Now, let me explain what zero-shot classification actually is. And the way I'm going to do so is by running this code so you can see it. So let's go into there. And I'm going to start up my Python application. It can take a little while to start up locally, so I'm just going to chat while that happens. So zero-shot classification is where you take some, oh, it did start, that's nice, where you take some text and a set of possible labels, and it will tell you which label is actually the most relevant one for that text. And we don't need a full language model to do that. So to give you an example of that, let's make a request, which is like, I am trying to score a goal. That's the text that we're trying to classify, and the possible candidate labels are programming, health, or sports. So if I run that, it will immediately classify that as sports, which is a sensible one based on what we're doing here. If I also tried the same thing with, I am trying to score an AI model, that comes back as performance, programming, and if I did trying to score a hospital performance, we get health. So you can see it's doing sensible classifications very quickly, just running locally on my machine. Now, can we really use Python as part of a .NET application? Well, the answer is yes, we can. So I'm just going to shut this down because I actually want this to be orchestrated by Aspire. So in my app host project here, I've got this thing that says add a Python Uvicorn app. Uvicorn is the server, so that's a bit like Kestrel, if you know .NET. And we're going to tell it where that is on disk. Now, this does not exist as an actual method in Aspire, but it's really easy to add because there's a good extensibility model. The entire amount of code needed to host Python in our system is just this few lines of code you can see there. So it's an executable resource. It's got this command name. It takes these parameters. And by doing this thing with environment variables, we get it to participate in the discovery system. Okay, so Aspire will deal with starting that up and shutting it down and stuff like that. And then we can make ourselves a nice little strongly typed client for that in C#. So we've got this Python inference client that can classify text, and it just does it by posting to the endpoint provided by Aspire. And then we can use it. So where I want to use it is whenever a new issue gets posted, because the thing I actually want to use this for is the case type. So remember, we've got these different types, and I want it to automatically populate based on the text of the customer support request. So I'm going to go to the place in my code where new tickets get posted. That's this create ticket here. And you can see we're using that Python client to classify the text, and we're saying you can pick any of the enum values in this ticket type's enum. Okay, so let's see if that actually works. It should do. So I'm going to actually file a new support request now. So I'm going to pretend to be a customer. So, okay, let's get started. Is this about a specific product? No. Let's say I'm just an absolutely crazy customer with ideas. So I think you should sell bees. Okay, so we'll submit that. And our request should go in to the support staff. And if we go over here, that's updated. And we can see that that has been classified as a comment or idea, which makes sense. Or we'll do another support request. This time, yeah, it's about a specific product. It's about my foldy seat. And this is semantic search. So even though foldy seat is not the name of it, we can still find it quite easily. I need to return this. And then we'll submit on that. Okay, back over here, you see that this one has been classified as a returns. And we didn't have to use an entire language model, large language model to do that. We just used this small model, and we've been able to integrate very nicely with a bit of Python. Okay, so that's enough inference for now. You might think at this stage, well, I think I'm done. I'm ready to put that into production. And you kind of could, but I think that would still be a bit of an amateurish level of quality for your system. Because if we really want to reach the sort of summit of enlightenment on our journey here, we need to start thinking about evaluation and test as well. How do we know that this system is any good? Like, how do we know that the quality of what's coming back is what we want it to be? And how can we systematically improve it over time in a reliable way? So let's start by thinking about evaluation. Like, what does it even mean to evaluate something like this? Like, if you're evaluating classification, it's kind of obvious, right? You could make a test set of like, here's a bunch of text, here's the labels I want you to give, and you try it out, and you work out what proportion of the time it gives you the right label. So that's a way of evaluating a classifier. But it's not so obvious how to evaluate this sort of response that comes back from our chat agent. Well, in this case, the chat agent has no opinion about bees, which makes sense because we've got no data about it. But when we've asked it other things before and it's given us a response, how do we know if it's a good response or not? Well, one of the advantages of working from a generated data set is that as well as just generating the data, like the products and the support tickets and stuff, we can also generate a set of evaluation data as well. So in this case, I've generated, actually, let's show a different one. This one. All right. So I've generated hundreds and hundreds and hundreds and hundreds of questions about the products that have got specific objective answers, like, what's the capacity of this teapot? 32 answers. Can it be used outdoors? No. So that's... these are all questions with hopefully objective answers. And the reason why we believe these answers to actually be true, and we count them as the ground truth, is that these don't come from our semantic search. They don't come from our chatbot. These come from the original data that we generated about the products before we built that into product manuals and stuff. So this is like the underlying secret data that our products were constructed from. Okay, so now, hopefully, we can use these to actually evaluate our system. So what I'm going to do is I'm going to start this running in a slightly different way, just so that I can run multiple things at once. So I'm going to start the backend running like this. And now I'm going to run this other project here called Evaluator. Right, so what that's going to do is it's going to loop over all the questions, and for each one, it's going to ask the question, get the answer back, compare that to what we think is the right answer, and score it. And then we're going to work out an average score based on all that stuff. Okay, so that's running now. It's asking these questions. It's getting back answers. We're doing it in parallel as much as possible because this could take a little while. Once we've got enough answers back, we'll send a batch of them to another language model, which is instructed to compare the answers that were given with the real answers and say how much the answer given is a reflective of the truth, okay? And we get a score. In this case, it's looking like it's about 0.5. The number on its own doesn't mean anything. All we care about is that bigger numbers are better, okay? And if we run this for long enough, this happens that it will average out at about 0.6. I've done it before, so that's what it's going to be. And if you want to really see behind the scenes a little bit as to how this actually works and how it's deciding what score to give, we're logging. So we're saying, in this case, like, the query is outdoor suitability, and the true answer is no. The answer that came back is yes. So that is clearly misleading. It's being a bit generous, actually, by giving it a non-zero score in this case. But you can see that better answers will get better scores. So let's find an example of a good one. So what's the magnification of these binoculars? The true answer is 10x. The answer given is 10x. And so, yes, you get a score of 1. That's a perfect answer. All right, and we work out the average of these over time. Any individual question and answer is not going to give you much signal because, the question might not be quite right, the scoring might not be quite right, but over the long run, the average gives you some actual meaningful data. Okay, now, you might think, okay, 0.6, is that good or bad? I don't know. But could we improve it? And this is the whole point of this kind of evaluation, is that it helps us to make sensible changes to our system and then find out whether it actually improves stuff or not. So maybe you've used this for a bit and you think, you know what, it hallucinates a bit. Sometimes, instead of searching the product manual, it just makes up an answer based on nothing, which is a bit annoying. Can we make it do better by forcing it to search the manual a little bit more reliably? Okay, so I'm going to go into the prompt here that we saw before, and I'm going to add another phrase here that says, if this is about the product, I really want you to search the manual, okay? I'm begging you, check that manual. This is your command, all right? So I've made that change to the prompt, and now we'll evaluate whether it actually makes stuff better or worse. So I'm going to shut this application down, and then I'm going to rebuild it like that. So that rebuilds. Okay, going to restart it, and I'm going to rerun the evaluator. So the key thing here is, this is a true end-to-end evaluation system. We're not just evaluating the prompt, we're not just evaluating the model, we're not just evaluating the chunking or the parsing or the embedding or the vector database, we're evaluating the complete end-to-end system. Aspire makes it quite straightforward for us to make calls into the actual backend using our strongly typed clients and get a real result back from our system. In this case, after changing it, the average has been going up. It was about 0.6 before. It's looking like it's about 0.7 now. In fact, if you let it run for long enough, you'll get a nice stable average, and I've done that. So what I found is that by adding that phrase to the product, before we got a score of about 0.61, and afterwards we were getting a score of 0.77. So clearly that is a really good objective improvement to the score of our system, but it does come at a cost. So we can also see that the time has gone up from 2 seconds to 2.6 seconds, which makes sense because it's spending some time doing some extra lookups against the manual database and generating more response. So that hopefully makes sense to you. We can also make other changes to our system. We can change the ingestion process or the chunking or whatever else we want. We could try changing the models. So I tried this out with GPT-4o, and I saw that the score went all the way up to 0.8, which is clearly a lot better. But also that comes at the cost of making the time go up by like 2.5 times. So that means that you as a developer can make sensible judgments about these trade-offs of quality, speed, and cost, and also that you can know when you make changes to your system, does it actually make stuff better or worse? Okay, now this is a pretty simple evaluation metric. We're just getting a single number. There are other better forms of measurement of RAG systems. So there's a thing called RAG triad that measures 3 different things about the relevance of the context that were provided, the degree of groundedness of the answer in the context, and the degree of relevance of the answer to the question. And those 3 things together are a richer score that also gives you a way of measuring to some extent how much hallucination is happening. So there's further you can go with this if you want to. I believe that Tess is doing a talk later on about how LLMs can go wrong, and in that talk talk, she's going to cover some of these more advanced RAG evaluation methods. So if you want to know more about that, you can do so. Okay, so last thing we're going to do now, a little bit of end-to-end testing. I'm sure many of you do write end-to-end tests for your applications, so let's just start running a test and look at some of the code that's in there. So let's say that you want to have a test that looks a bit like this. So we want to use end-to-end testing. I'm using Playwright here to start up our application and go and ask a question of the support agent. So in this case, what product is ticket 1 about? And we expect it to reply with this particular reply. Or does this product have a battery? And we expect it to reply like that. Now, there's a couple of challenges to doing this. The first challenge is to do with having the application run in a known state. So it's no good just to run the application in whatever state it happens to be on the developer's machine, because maybe they've already deleted ticket 1 or something, and then the test would fail. So that's something that Aspire can help us with. When the application is running, we can seed it with different data in different scenarios. So here, I've got a bit of code that picks up an environment variable or config value, so we know whether we're running under test. And if we are running under end-to-end test, then we're going to use a particular seed data that comes from this test directory. So I've got a well-known set of data in here, all these JSON files. These can be stored in source control, so it's shared across everyone on the team, and you know that your end-to-end tests are always going to start in that form. Okay, so that makes sense. But the other challenge is to do with determinism. So language models are not deterministic in general. Even if you tell them to be and give them a seed and tell them to have a low temperature, they still won't actually be deterministic. So you might think that your end-to-end tests are just going to fail at random. There is a good pattern that you can use to deal with this, which I've seen in a few places. I've used it myself when doing the smart component stuff, which is very simple. It's just caching. So when these tests run for the first time, they will call the real language model and behave doing whatever it says, but they will also cache that response from the language model on disk. So I've got this directory here where we've generated these cache entries. So each entry in here is the full request that goes out to the language model backend, all the history of the chat and the parameters and stuff, and then all of the response, like exactly broken down into all the chunks that come back. And we can just store that on disk with a SHA hash so we can identify it later. And then when you run the test for a second time, then it's just going to match these cache entries. It won't go out to the network, and so your tests are going to run fast. They're going to run deterministically. And it also means that when you run these on your CI server, you don't even need to have any API keys, because it's never even going to talk to the external service. So that's a pattern that you can use to make your tests a bit faster and more deterministic. Of course, you can still change the prompts and the parameters later. Once you've done that, it just won't hit the cache entries anymore, so your tests will fail until you regenerate them. So that's a pattern that you can use if you want to make end-to-end tests deterministic. All right. So that's the end of our journey through all this. If you want the code to this, well, you can't have it just yet, sorry. But we're working on it, okay? We've even got a URL. Just need to finish a little bit of approvals and getting a sign-off on that, and then we'll mark this as public. If you go there now, you'll just get a 404. But anyway, I've put the URL so that hopefully you can get it in a week or two. And that's it. So let's finish off with a summary. So what have we been thinking about? Well, I think one of the key points here is that there's many different things you can do. Right? You don't just have to do chatbots. There are different UI patterns like semantic search and summarization and classification and things like that. Many different patterns for that, and also many different ways of running language models. It's not just particular hosted services. You can run stuff locally. You can use different models, small models from Hugging Face, things like that. Lots of options open to you. I really want to encourage you to focus on evaluation from day one. Having some sort of numerical feedback of the quality of what you're doing will give you a lot of confidence to make changes and be sure that you're actually moving stuff in a good direction. Now, in .NET, there's a lot of good tools available to you. So I've hopefully shown you some of the benefits of Aspire for orchestrating these systems that have got many different containers and projects and tests and things like that. So Aspire can help you out. Obviously, you've got semantic kernel as well, which gives you these APIs for working with language models and embeddings and different stuff like that. Okay, but you're not limited to those. You can just use anything you like from any technology ecosystem. And then finally, I will point out that everything I'm showing you here is just emerging stuff. Like the patterns around this have not really settled yet. It might be that a year from now we say, oh, actually, there's a different and better way to do stuff. It's all still being figured out. And I feel like maybe we're still missing some libraries that would make it easier. Like I could easily imagine a library for data generation or ingestion or evaluation or whatever. maybe one of you would like to create an open source library like that, I think there's a space in the market for it. So there we go. That is all we have got time for. I hope that's useful to you. I hope you take this out and enjoy the rest of your conference. Please evaluate as you go out. And I would really love to speak to you, any of you who are doing this sort of thing, because I want to learn from you too about what your real world experience of doing this sort of thing is. So let's leave it at that. Thank you very much. Enjoy your day.
Guys, if you can just scooch in so more people can sit if you have empty spaces next to you. Because if it's looking like this 10 minutes before the talk, it's gonna be tight. The music from outside. Oh, wow, I'm here. Cool. Hello, everybody. I'm Nick, and in this video, no. That's a good intro, though, for a talk, isn't it? Good morning, NDC. How is everybody doing? Wow. Hey, don't be dead. Woo! Okay, I don't know what the fire hazard protocol is. It looks bad. Now, I'm going to suggest something. I don't know, maybe the crew can tell me, shut the fuck up. I don't know if somebody wants to just come here in these sides and just sit down, if that's easier for you. But yeah, this is a new room. Usually it's upstairs. So just scooch in. If you have spaces, just come all together. And let's have some fun with some KC Shop. Now, very quickly, I want to ask, does anyone have a friend who works for YouTube? Nobody? Please, somebody, if you find someone, let them know that I'm not naked in this video. I am Nick, and in this video, AI is not there yet, and it's like my mom is asking questions. So please, to be fair, you can't see. I could be half naked, but anyway, I just wanted to rant for a bit. Now, given that I have you here, and it's so packed, I never do this, but I do want to do this. I want to take a video from the left to the, well, it's my left, it's your right. From the right to the left, I just want to just woo as the camera goes there. So let's do that. 1, 2, 3. Woo! Hell yeah, okay. And you don't want to know how I'm going to use that video. It's for my ego. All right, so let's go into this talk straight away, because it's the second time I'm running it, and I don't know how long it's going to take, because it's mostly live coding and 8 minutes of me waffling about. So, quick introduction, who am I? Hey, my name is Nick Jobsas. The main thing I do is YouTube. How many of you know me from YouTube? Not. I see some hands that are not raised. Take out your phone right now and subscribe. It is free, and the ultimate goal in life is, my mom is complaining I have less subscribers than her favorite travel influencer. I'm like, it's a different thing. She doesn't understand, but please subscribe. Maybe we can beat her. She has like 5 million. We'll get there. And the thing that pays the bills is I'm running a company called DomeTrain, which sells online training. Think Pluralsight, but way, way better, and I am biased. Anyway, so I want to point out what you signed up for, right? Because you're all here. You just saw the title of this talk. And the title of this talk is KC Shop. And the abstract said, and hopefully you all read it, right? Now, will you learn something you should apply to your day-to-day job? Probably not. And you said that's a good idea here. Okay. Will you question your knowledge of the language you've been using for years? Absolutely. Will you return to your job on Monday, or maybe tomorrow, I don't know, trying to apply the practices you're going to see in this session, even though I'm going to make it very clear that you shouldn't. There's no question about it. Join me anyway. It will be fun. So hopefully we're all here to learn basically nothing, which is funny, to me anyway. But I appreciate you for being here. Thank you very much. Now, let's just address the title a bit, because so many people will tell you KC Sharp, or you might have seen this term with other languages like C++ and so on. But I do want to talk about what is KC Sharp, right? You might have an idea, you might not know about it. And it's a term that I want to believe I coined for C#, even though it existed for years before that. And I want to have a bit of a thought experiment. Have you ever said one of the following? So the first one is, wow. And by the way, this is when you're looking at code, right? Or we're looking at C# code. Wow, this is amazing. I love it. How many of us have said that? I guess everyone, right? Yeah. It's amazing code when you write some great code. So that is good C#. Then you have, wow, this is terrible. I hate it. We've all said that, right? Of course. I go back to my original code back in 2015 when I started with C#, and I'm like, what was wrong with this guy? Well, that is bad C#. And then you have the following two situations. Wow, this is amazing. I hate it. Has anyone of you said that? And wow, this is terrible. I love it. That is Care C#. So this talk is all about that. Now, I want to ask you a question. What is this? Just anyone shout. A cab. It's a black cab. So this is a taxi or a black cab in London. Now, there's something very interesting about black cabs in London. Black cabs in London can look at this. In fact, they don't even need to look at this. You can be in Wimbledon in southwest London, and you might wake up in the morning and you might say, I want to be in this very specific street at East Ham or West Ham or anywhere east. Okay, nobody wakes up in West London and says, I'm going to go to East London, but this is hypothetical. Let's say I want to be there, and you go in a black cab, you just say, that's the point of interest, that's the street exactly, and the black cab will know the most efficient route to take you there without looking at an app. They've just memorized everything in their brain, and that's part of getting a license in London. Otherwise, you just can't have a black cab in London. And you know how they call that thing? The fact that they know everything? The knowledge. So ultimately what I'm going to be here is I'm going to be transferring some knowledge. But I do want to mention a few cautionary tales because this is basically a great disclaimer for what you're about to see. Many of you might be familiar with the story of the Titan Prometheus. Now, Prometheus, back in ancient Greece, which is where I'm from modern Greece. This is the ancient time, I mean. Prometheus did something terrible, according to Zeus. He stole fire. He was, to be honest, the god of fire and the Titan, and he gave it to humans. The idea of fire is what made us be who we are today, because we harnessed fire, we used that knowledge, and we became better for it. But for doing that, Prometheus was punished. He was punished to be chained on a rock and have his liver be eaten every day by an eagle. And then every night it would regrow, and then eventually he would have to do this over and over again. Eternal suffering. The happy ending is that Hercules eventually saved him, but that is not the worst thing that happened to him. The worst thing that happened to him was that he turned out to be a metric stool, which is great. And that's just one cautionary tale. Then we have the Tower of Babel, this idea that humans were building too close to God. They would just all speak the same language, and they could share their knowledge, and they used the knowledge to build close and close and close to God. And God was like, I don't want to have to deal with that. He just said, you all speak different languages now, and the Tower of Babel started crumbling down, which again is not the worst thing that happened to the Tower of Babel. It also became the JavaScript compiler. I see a pattern here. The last cautionary tale about knowledge has to do with Icarus. So the story of Icarus and Daedalus back to ancient Greece. They managed to know how to harness wax and feathers, and they made wings, and they got that gift of flight. They used their knowledge of, I guess, advanced aerodynamics in 500 BC to fly close to God, but sun melted that wax, and they plummeted down to earth. Well, Icarus did, and Icarus tragically died. And the reason why I bring this up is because there is no open source project called Icarus. So if you want to make something, you can go ahead and do that. Use the name. I don't need credit. But I want to point out that this talk is not about evil C#. Now, what is evil C#? Well, I'll show you what is evil C#. And this talk from now on is mostly coding, but I have a very interesting thing for you as well. So I have a console application in C#. And what I'm going to say is, let's just have a string, right? I'm going to say string s equals Nick Chapsas, because I am an egomaniac. And I'm going to say console.writeLine s. Now, every normal human being who sees this code would know that if I do this, all that's going to happen is I'm going to get Nick Chapses on the console, right? Right? Wrong. I'm going to get a reversed string Nick Chapses. That is evil C#. Do you know why it is evil C#? Because someone, a terrible human being, it's me by the way, went ahead and he made a string class on the same level, didn't put in a namespace, and now this string class has a reverse method, and nobody would know about it. So if you're using string, the class name, instead of string, we call those something, I can't remember what it is, you're going to have this very nasty reverse string experience. So that is evil C#. It's sort of the same thing as when back in the .NET Framework days, people were doing this, where you could go and allocate the string.empty field to any other value you wanted, because ultimately string dot, wow, my compiler is confused. String.empty is just a static read-only field, and you could use reflection to just allocate that to any value you wanted. Thankfully, you can no longer do that because that's a JIT intrinsic value, but you could. That was evil C#. And the stories don't stop. I can keep going forever. There's many nasty things you can do to the colleagues you hate. I'm sure you all love each other, by the way, if you're with your colleagues here. But another example of evil C# is, let's go in this program.cs, right? And let's say, again, I want to print something to the console. So I'm going to use console.out. The reason why I'm using console.out is because it also has write async and write line async capabilities, so you can write to the console asynchronously. Many people don't know that, but I'm going to use it. And I'm going to say console.out.writeLine, and then Nick Chapses, right? What do you expect to happen when I press run? If you were paying attention, it's going to reverse the thing. But it's not obvious how. And there is no string class here. There is still a secret.cs. It's very nasty. And what's happening here is I wrote a C#8 feature called an interceptor to intercept this very specific location. And you can see that with this icon over here. And my code will come in and say, whatever you put here, I'll put my code. So I could actually just make this say whatever I want. If I wanted to say, I don't know, hello, NDC, Oslo, Oslos, then I can do that. So that is not about this stuff. This is about cursed C#. And I'm going to show you the first very basic example of cursed C#. And it's a bit of an introduction also to another aspect of this talk, which is interactivity, because I do want to know how you feel about everything I'm going to show in this talk. So ignore the names of the projects. Let's say I want to write a loop, right? The most basic thing. You know, if you've been watching my videos, that I have a thing with loops. So if I say, wow, I haven't written a manual loop for a long time, why don't you just create this for me? Less than 5, I++, and then I can say console.writeLine, and then I can print the I, right? So I can do something like this, and then I'm going to print. But what I can also do is I can say 5 each console.writeLine, and I can pass down the I, and then if I run this, this will also do the exact same thing. Okay, it will also add 5. No, it won't add 5. I was wrong. It will do the exact same thing, but it's going to look smart. Do you guys think this is smart? This is a safe space, by the way. It's a kind of a safe space. I'll explain later. But let me show you. I don't want to have an opinion, because what I want you to do actually is I want you to take out your phones, and I want you to scan this QR code, and I want you to participate in this, because you're going to vote on how you feel based on the cursed C# scale. So if you just open that, and please do participate, because if you don't, this talk is going to suck. I'll give you a minute. Some people are still scanning. Okay. So each extension method on integers, how do we feel about that? Whoa, this is amazing, I love it. Whoa, this is terrible, I hate it. Whoa, this is terrible, I hate it. Oh, it moved. Whoa, this is amazing, I love it. Now, I do want to point out, I ran this talk for another conference around a month ago. Around 500 people, 400 people voted. And after you vote, we're going to see what they voted, which I think is fun. Wow, this is amazing, I hate it. So we agree it is pretty cursed, right? Wow, this is terrible, I hate it. Wow, this is terrible, I love it. So the audience is a bit more mixed than I would hope it would be. Let's see what that other conference voted. Whoa, this is terrible, I love it. Okay, it's a good start, but it was supposed to be easy. Now I wanna not trick you a bit, but I wanna go a bit further to something that could look pretty cool, maybe. Now, one of my favorite languages to write outside of C# is Kotlin. I just love Kotlin. It's a brilliant language. And if I could use it to make money, I probably would. But I don't want to make Android apps. But Kotlin has this really cool feature. So you don't have for loops in the same way we do in Kotlin. Instead, what you have is you can say that for I in 1 to 5, and then you can say print line I. And if you do that, those are inclusive. So you go. That's how you do for loops in Kotlin. 1, 2, 3, 4, 5. It's pretty neat. I really, really like it. And I always wondered, can I loop like that in C#? Would it be possible to have a for each loop in C#? Because clearly we can't, right? If I go to over here and I say for, maybe for each var I in 1 to 5, wait a second. What is this thing? I didn't use I. Let's try this again. Ah, how the hell is that possible? It does look pretty cool, though. You know what's also pretty cool? I can just do it on the integer itself. This compiles. And I can just go and say, God help us, run. And this time I was smart. I'm like, don't be inclusive. So start from 0 all the way to 4. This is valid C#. But how is this valid C#? Well, I'm going to delete this class, and I'm going to show you how it's valid C#. The moment this goes away, we can no longer do that. Now, C# and the compiler is written with this concept of DAG typing. Because Microsoft historically, in order to add features without breaking existing code or without touching the CLI, what they loved doing is they took their new high-level features and they compiled them to low-level C# features, and then that's what was compiled to the IL level, which is the intermediate language, which eventually the CLR will pick up and run. And that brought some interesting things into the mix, like the ability to do what you just saw. I'm able to go ahead and say custom int enumerator. And I can turn this into a ref struct because I really care about performance in a talk called Curse C#. And what I can do is I can turn this class into an enumerator without implementing or extending anything. All I have to do is I can say, hey, this has an integer property called current, and it has a public bool move next, which we're just going to say, like, return true for now. And the moment I do that, I'm able to take this class, add an enumerator on it, add an extension, and then this will work. Let me just show you, without having to implement everything manually, let me just quickly copy that, because that would be boring. So if I kept track of the current location and then the end, I'm able to say that I want an enumerator based on a range, and then if I want to iterate based on the loop, I can just pass, based on an integer, I can just pass down the integer. So I can just say that current is current, And then I can just say that move next is current, boop, boop, or plus, plus, and then return current less or equals to end. And I do have some checks around like looping from the in reverse or from the end. Maybe you want to implement that, that's up to you. But once we have that, we can go ahead and say public static class secret. We have many secrets in this talk. Public static custom int enumerator. Get enumerator, so that's the other duck typing part. If you add a get enumerator extension method on a type, and the enumerator, or it is an enumerator, and it returns an enumerator, you'll be able to do this enumeration. So what do I want to do? I want to say this integer number. So I'm adding an extension on the integer, which is, by the way, the exact same thing that we did for the normal loop. So .each, in case you're wondering, was just an extension on I, on integer, and then we have an action that is being computed every time we loop. So I'm doing the same thing here, but this time I'm just returning a new custom int enumerator of a new range, and because this is just an integer, it's from 0 and then number minus 1. And I can do the same with the range. So the range, which is a class added, I think, in C# 8, if I'm not wrong, I can do something very similar. I can say, take the range, which is what this dot thing was, by the way, and pass the range down. And the moment I do that, and the moment these methods exist, well, I kind of do have to import it, but once I do, God help us, I'll just delete the namespace, and that is going to be fine. Then I am able to have this looping mechanism. So if I want to have from 1 to 500, which I think arguably looks pretty sweet, but I am biased, then I can just have Kotlin loops in C#. I'm really curious to know, how do you feel about that? And I do want to say the response from the other conference was very similar to this. Guys, did you forget what this talk is called? So, when I first wrote this talk, I genuinely thought everyone would be like, oh, wow, this is terrible, I hate it. Oh, this is amazing, I hate it. Or, this is terrible, I love it. I did not expect that this would happen. But funny enough, everybody loved it. I had people come over and said, oh my God, I'm going to go to my company on Monday and every loop will look like this. I'm like, no, I don't have insurance. It's really cool, right? It's really cool. But this is not the end. This is just example 4 out of 15. So brace yourselves, because the next one is coming for you and it's coming fast. I just want to talk about loops a bit just as a palette cleanser, because this was a lot. I'm sure looping on a range, looping on a number, it's a bit weird. So what I'm going to do is I'm going to create a list of integers over here. And I'm genuinely not going to do anything silly because this is a live talk. So let's say I have like a list with some numbers. Now, it's very common that we want to loop lists, right? It's one of the most used collections in C#. But the problem lists have, for someone like me who's obsessing over performance that doesn't really matter, is that they're not as performant as looping around an array. Now, the funny thing about lists is that behind the scenes, every list is actually backed by an array. And then the logic of a list is a wrapper around resizing that array, allocating only as much as you need, and so on. So, would it be possible to use that array of the list to loop? Well, you might have noticed already that the array is an internal parameter. And you can say, yeah, but we can use reflection to get it. And I can be like, well, if you use reflection, you kind of defeat the purpose of performance. So what the hell? So is there a way to do that? Well, there kind of is. I can say var span equals collection Marshall, or collections Marshall, as span list. And this will give me a span. And it's going to give me a span because it turns out Microsoft wants to make .NET the fastest thing that they've ever made. And because not every team in Microsoft has access to the BCL and don't want to touch it, they made a public hack in this class, and they have many of those, by the way. It's amazing. Where they say, yeah, here's access to the backing array of this list. By the way, do not touch it when you iterate over it, because normally a list, when you iterate and the list changes, it's going to throw an exception. This won't. You're going to keep iterating. So, and you don't want that. But if you're wondering what's the fastest way to iterate a list that you definitely don't touch, that's the fastest way. Now, that is cool. But, that's, again, a palette cleanser. But I want to go back into some very interesting behavior. Let's go back to the program.cs over here. Now, everybody knows that, well, I hope everybody knows, that if you want to have some delay in your application, you can do that by saying, date time.now, and I can have two of these date time nows, and then I can say await task.delay, let's say for 5 seconds. Right? It's very. You've seen code like this before? Like, have we written await async before? Yeah, sure. So if I just run this, what you expect to see is this happens, and then 5 seconds later, I'm going to get the time of 6 plus 5, 11. That's pretty neat. But wouldn't it be cool if I could just say await for 5 seconds? Right? Isn't that nice? It's so nice. Await 5 can mean anything. 5 years, 5 milliseconds. But it does work. That's very weird, isn't it? So, but I don't like this because the readability is not great. But I can make it readable. I can say await time span from seconds 5. Right, that reads pretty good, doesn't it? 1, 2, 3, 4, 5. I'll do you one better. How about we await, what year is it? Wait, June is which month? 6th, 13, 10. I don't have that type of time, guys, but you get the point. You can do some really, really terrible things, and this will compile, by the way. So await until that time. I do want to point out the date time example didn't exist when I first made this talk, and I showed that in the other conference, and people said, that's a great idea, you should add it in the talk. So it was feedback from the audience. Now, how is all that possible? I'm just going to delete that, and it's just another situation of duck typing. So this now doesn't work. I'm going to go back to awaiting for 5 moons, and I'm going to go here and create the secret.cs. And what am I going to put in here? Well, I'm going to put a few extensions. It turns out await async and the state machine and all that is heavily using extension methods or duck typing behind the scenes. And you have access to that. Nobody will stop you. So what you can do is you can say public static. I'll tell you what the type should be in a second, but you can say get awaiter, and you can add an extension, and you can say int seconds. And then if you return a task awaiter, then you can make any type, anywhere, awaitable with your logic. So all you need to do is say task.delay. In this case, I'm using delay. You can use also normal things, like your own awaiter, but I don't know anyone who can write their own awaiter. So, and then if you just return the awaiter of task.delay, then this will just work. You can do this with anything. But some people will say this is not readable. So what you can do is you can say, OK, how about I do the following? How about I make this clean? Ooh. And how do I make this clean? Well, I can give it some meaning. So I can add this awaitable seconds class where I can pass down some seconds. So I'm giving it more structure. And I'll take this entire thing, and I'm going to put the extension method on the awaitable seconds. So I'll pass that down, and then say value. And that then leads to me be able to add an extension here called public static awaitable seconds. Seconds, this int seconds, not seconds, and then return new awaitable seconds and seconds. What does this lead to? It leads to me being able to do wait for 5 seconds. It's pretty good, huh? Amazing. Get help. Seriously. But if you really want to get help, why don't you do something like this? Wait for 5 seconds. My compiler said, no, I'm not going to do that for you, but I'll try again, and it's going to work. What the fuck? And you can do this with any type. I can say, wait for 1 second. Why not? I do want to point out the talk is called Curse C#. You did this to yourselves. So this will work. How will it work? Well, you might have guessed already. The string is just a type. So you can do something like this. Please don't. Please. I had someone come after the talk, the other one, and that's a brilliant idea. No. And he said, you know what it's missing? Like a code analyzer to detect if I'm using the wrong string. And I'm like, yeah, we call that an IDE, and you make a method. But I can totally understand how some of you might think this is really cool. So I'm going to give you a chance to rate it. Get a waiter extension, the whole thing, not just the string. Wow, this is terrible, I love it. This is so funny. To me. I do want to point out, this is anonymous, by the way, for your own good. So, pretty cursed. I can't remember what the other conference voted. I think it might be the first one where you don't agree. I guess we'll find out in 5,000 milliseconds. Let's see. Wow, this is terrible. I love it. Yeah, you guys agreed. Wow. Almost the same percentage as well. I do have to say, developers are not that special after all, are they? We are simple beings. I see, await strings, I click. Okay, let's go just a bit further. Let's take a look at more stuff related to dates, because I like it. We're going to a new folder here, new project name. Let's go ahead and say that I wanna write down my birthday as a date, right? So I have var birthday equals new date time 1993 4 8. You can mail me your gifts next year, by the way. That's a very standard way of doing it, right? But it does look a bit weird because I'm from Greece, I live in London. That's not how really we write dates. The way we do it in the civilized part of the world is we would say 8th of April, 1993. Well, that's pretty good, isn't it? Sweet, sweet. Now, why does this work? Well, it works because some insane person said it's a great idea to go and add an extension method on integer for every month. Bit much, but I do want to point out, I've seen this in real code. A lot. So it's not too out of reach, but what you're about to see is a bit out of reach. Because you can do this, but we also, any people from the US in the audience? 1, 2, 3, 4. Okay, you're enough to beat me, so I'm not going to joke about this. What I'm going to say is on that side of the world, Americans like to write dates like April the 8th, 1993. Wouldn't it be nice to say April? Oh, wait, wrong project. Wouldn't it be nice to say April the 8th, 1993? The American way. Pretty good. What the fuck? How is this possible? Well, it's possible because I'm insane. We can have an enum called months. Each month can have a name, of course, it's an enum and a number. And then you can go ahead and make one extension method on the month for every single goddamn day. And nothing stops you, by the way, from having 30 days in February. But nothing stops you from writing new date and then 2 and so on. So I don't see this as a problem. I think this is totally fine. Well, is it totally fine? We'll see how you feel about it. But I would say until now, everything is kind of okay. If I see it, I'd be like, ooh, what the hell? But I wouldn't be like, you need help. What you're about to see is on the you need help territory. Let's say that I want to write again my birthday, but I like to write it like I write dates on text. So I will have, again, American way, April the 8th, 1993. It's a date. It works. I can prove it. Oh, but you know what I really don't like? That this is the actual date, how you would write it, is not with the hyphens. You would use the backslash. I wish this was supported. Of course it is. Because this is scripted. So you can have a date like this. How can you have a date like this? Can anyone shout how you think this works? Operator overloading. So in C#, you can just do something like this. You can make, I make a record struct because I think structs are funny. And then you can go ahead and overload the operator, the minus operator, the subtraction operator, and then do, pass the values. And because the month is a struct, anything that follows it will sort of chain on the previous thing. And I can do the same with this operator. What I haven't tested, and I'm curious now, is can I have a mix? I have to add something new in the talk next time. Damn, this is mega cursed. But okay, let's see. Let's just see. I'm curious. I want to see how you feel about it. So, one thing I didn't ask you before, and I want to ask you now. And I forgot that this is not moderated, so don't write anything stupid. I want to know which type or which use case needs a get awaiter. This is from the previous example, the make anything awaitable. Anything you write will appear. If you write anything stupid, I'll have to move the slide, and you kill the fun for everyone. Someone wrote my girlfriend in the last conference. I left it on screen. Let's see what you guys have to say. Don't be shy. This is a safe space. What can you make awaitable? If you don't write anything, I'm just going to keep waiting and drinking until someone says my boyfriend. I'm wondering if I need to click the button again. I do. Async disposable, restaurant, audience participation, event trigger, my wife. Wow. Boom! I do want to say, by the way, that this isn't anonymous and I know exactly who you are. And I know where you live. Random.next, Nick's mom, Nick Chapsis. Guys, my mortgage. When I started my career as a public speaker a few years ago, I never thought that someone would make a your mom joke while I'm on stage, but here we are. Now, back to date. How do we feel about building dates with operators? Wow, this is terrible, I hate it. This is so funny, because I think that's exactly what the other conference also said. It's pretty bad. I'm not gonna lie, it's pretty bad. Let's give a chance to everybody to vote. Wow, 400 plus, that's many people. Okay, wow, this is terrible, I hate it. Let's see what the other conference said. We're human beings, we're all very simple. We like the same things, we hate the same things. But let's see how you feel about the next thing, because the next thing might surprise you. We talked about operator overloading, and this is not necessarily a use case that might make too much sense. But what if I go here? Let me just close everything. And I go in the program.cs, and what I have in this docs file is just a text file that says hello from text. So what if I want to write some code that gets the main directory that I want to load? So I'm going to just copy that, because anybody got time to type all this? So let's write some nasty code to get the main directory, and then get a path. So new file path is main directory to string. And then I want to get a path to that file, that text file. So this will take me 2 levels higher from the executing environment, and then I want to go deep into docs and text.txt. So I'm going to say var text equals file dot read all text, and then I'm going to build the path, which is path, and then am I on Mac or Windows? I can't remember exactly what the path thing is. Is it? I think it's like this, and then like this, and then like this, and I should be able to say write line text. And assuming I did this correctly, no, this is a Mac, so the path doesn't work that way. I have to do the other thing. So I have to say, shit. Let's fix it. I think this will work. Oh, this worked. But paths are hard, you guys. So why don't we instead do the following? Why don't we say, get the path docs and then text.txt. Now, this will work. Of course it will work. You can build a path like that. But you know what's really cool? This / will actually use an environment-aware directory delimiter. So even though you might be suspecting how this happened, how this is even possible, and if you've been paying attention, it is obvious that I'm overloading the operator. But I'm going to use path.combine behind the scenes, and this will always work in any environment with no problem. So even though it looks stupid, I don't necessarily think it is that stupid. And you know how I know? Because Nuke, the the tool to build C# projects, also thought it's a great idea to do it. So that's how you would do paths in Nuke. So, and by the way, I do want to point out, you can go even further with this. I don't know how many of you are aware of a library called CLI wrap. If you want to do anything with a CLI, it's an amazing library. They have the pipe operator to chain like it's Bash. Insane stuff of nightmares. I love it, by the way. So now I want to know, how do you feel about the file path operator overload? I kind of guessed that. God, I love this talk. So everybody loves it. Everybody will go on Monday and start using file path operator overloading. Please do. Please. And don't tell them I told you. This is so funny. Same thing. Literally same thing. Even around the same balance on the other things. This is great. Okay, let's add a few other stuff just to top it all off. Just two small things. The first one is over here. So let's say I want to time an operation in C#. Now, don't take two dates and subtract them if you want to get a delta in time in C#. That's a bad way to do this. What you want to do is the stopwatch class has a get timestamp, which will give you the current number of ticks. You want to get that, and you want to say start, and then you want to get the delta by saying stopwatch dot get elapsed time from the start. And this will give you an incredibly accurate measurement. It's going to go down to the OS to get the exact same number of ticks for this operation. And if I had an await task dot delay over here of like 2 seconds, I can say console.writeLine delta, and this will return a time span. So if I run it, what I'll get is around 2 seconds. It's always some overhead because a state machine has to be built and executed every time you do anything with await async. But it's almost exactly 2 seconds. Now, if you want to time an operation, what you can do is you have to start the stopwatch outside, or not start the watch, but get a timestamp outside of try, and then have a finally block, whereas the time you're going to calculate the elapsed time. And this is because even if something fails, you actually want to measure how long it took, including the failure. So if I do something like this, I'm going to get the exact same experience, but it's way, way better. The problem with this is that it looks really, really bad, because you have to have this stopwatch up here, then you have to have the try catch, so we add a level of nesting, which I guess it's fine, but then you have the finally block, and all your finally blocks, when you time something, will look exactly the same. Wouldn't it be cool if we could just say, using a new timed operation, I'm going to give it a name. I'm going to say demo. That's not demo. That's demo. And then await task dot delay for 2 seconds. Now, if I run this, it actually works. Why does it work? Well, it works, as you might have guessed, because a using statement in C# is just a syntactic sugar way of writing try finally. So if I go all the way here in my IL viewer on my ID, where the hell is my IL viewer? Here we go. And I say, show me the low-level C# of this code. OK, there's a bit of a mess now because we have await async. But what you're going to see, you're not going to see it. Basically, you're going to see a wrapper around try finally. So you have this try block over here. You have your delay. And eventually, you want to have, or you're going to have, the elapsed time. This is a mess. If I remove the await, and then build again, come on, fella, build again. Here we go. My ID is not playing nicely today, so I'm not going to challenge it anymore. Take my word for it. This is going to be a try finally block. And the way this is done is if I go into secret, you'll see that I have this timed operation. So to use something in a using context, you need it to be disposable. So you're going to have an iDisposable implementation called time operation. We're going to keep a name because I want to use it when I eventually run it. Then I'm going to pass down the name, get a started at when I initialize it, and then when it's disposed, which is what's going to be called in the finally block, I'm going to say operation whatever took this amount of time. And if this doesn't look new to you, if you've used something like this before, that's because Serilog's timing, Serilog is a logging library, the timings extension is using that exact operation to say operation.time, and you can pass down correlated values and track like this. How do we feel about that one? Has any of you been using that already? Yeah, nice. I'm happy we all agree. And I'm pretty sure that there's literally no difference between what you guys think and what Belgium thinks, which should say a lot about both countries, which is, wow, this is amazing. I love it. I just want to end it all with a very, very weird one. I think it's very weird. So in C#, if you want to lock an operation to make it thread safe, you're going to end up with something like this. You're going to have like a padlock, and you're going to have like a new object, and you're going to say lock that padlock, or using that padlock, the type, and then console.writeLine, and anything in here is thread safe, right? So if I run this, what you should expect to see, no behavior should change. You should just see thread safe in the console. And that's not how you write thread safe, but we're going with it. But wait a second. I just entered the lock. I just exited the lock, but misspelled. What is happening here? Well, it turns out, and I'm going to just delete this secret thing, and once I delete it, by the way, you can see this behavior goes away. We're not going to see anything. But I can go here and I can say class secret, and then if I change the namespace to system.threading, and I change the name of the class to monitor, and I pass down two methods, an enter method that accepts an object, and then a reference boolean called log taken, and an exit method, for some reason, C# thinks, oh yeah, I'll use them. Which means, hypothetically, you can go and drop a file like this in your code base right now, and it will be used like this on every single lock. That's all I'm going to say about that. The choice is yours. So the last thing I want to ask is, what is your favorite cursed C# thing from today? And if you agree even on this one, I'll...
Where's the code interceptor?
Sorry?
The code interceptor. So I don't see the interception of code.
That's evil C#. That's not cursed C#.
Okay.
You're being naughty.
Oh.
He's like, where's the worst thing you showed today? I want to vote for that. Slash for file path data extensions. Int on range or loops. Let's see. I actually don't think I saved what the other conference voted. But slash on file path is a pretty good one. Int on range and loop. Fed. Seek help. Thank you very much and keep coding.
Ready for us? All right, fantastic. Boy. I'm the luckiest guy in the world. I get to tell stories for a living. That's pretty much the job now. I don't do any real work anymore. The upside is I've been doing this for so long that 40 years of software development, for better or worse. I make a few podcasts. I think you folks know that, .NET Rocks listeners. Oh, wow. Okay, that's awesome. And I don't own the term geek out, but I did use it in a very useful way when Carl got me to do this thing. So we've been making these geek outs, which is just an excuse. I don't make as many as I used to now. This particular talk is derived from the worldwide power analysis. This show here, so the first version was in 2016, there. So this was a listener said, can you kind of explain energy? Like we've been doing all the alternative energies. I did solar and wind and thermal and so forth. And now this was like, how can we pull all this together and just talk about it as a whole? And then the same thing that happened to me with the space stuff was other conferences said, well, will you talk about this? And so I've done a few versions of it, but one of the things that's happened now is I've come to appreciate that folks like to hear about how energy works in their home, in their country. So how many Norwegians do we have in the room? It's all Norwegians, right? So I'm going to talk about the Norway power system in the context of what we're doing with power worldwide. And to me, it's hugely interesting. It makes the talk really fun for me because I get to study different power grids. I've done like 8 different countries now. And I'm from British Columbia, where we kind of got power like you do, which is to say a lot of mountains and a lot of water, so we make a lot of hydro. But what you guys are doing from there is super cool to me, and I'm happy to discuss that. But let's talk about the fundamentals and how we use electricity and how we actually go about making it with high tension lines and so forth. And for the most part, it comes down to the same thing. Right now, worldwide, we're at about 15 terawatts at peak consumption. That's a lot of energy all over the world. At 160,000 terawatt hours, or I guess we call it 160 petawatt hours. We would be the only room that understands what the heck a petawatt hour would be. And we do it by spinning motors, right? Or really alternators. Tesla is the guy who figured this out, the AC motor, and how if we turned it, it created, with 3 sets of coils, actually they use 6 sets of coils, this what we call 3-phase power. So the AC cycle was generated by spinning the turbine, and it's 60 hertz in North America because the Westinghouse turbine that was the most stable turned at 3,600 RPM. And it's 50 hertz in Europe because the Siemens turbines spin most stably at 3,000 RPM. No more magic than that, right? And that's how standards are made. Well, this one works, let's make more of that. And then you go to Japan, where the Germans sold the power system to the west side of the country, and the Americans sold the system to the east side of the country, so they have both, which is why they make switching power supplies, because they had the problem, and we have all benefited from that. The vast majority of those generators are turned by steam turbines. This is very refined 100-year-old technology now, where we take as much energy from steam as we can possibly get. We pressurize the steam. Water boils at 100 degrees centigrade, but we pressurize it so we can get it to about 300 degrees, which gives us a lot more energy. And then we pump it through this massive turbine. There's several stages in this. The high pressure stage is right here, so the hottest steam hits here. And then it'll go through an expander to the mid-band, which is this set of turbines, and then to the low-pressure turbine. And that's all about taking the energy that's in that steam and extracting as much as you can from it to spin that generator at either 3,000 or 3,600 RPM, depending on which generator you're using. The advantage of this is the amount of kinetic energy it has when it's spinning. So one of the things you can do when you're switching power sources, so you're boiling water somehow under pressure, then you're pumping the steam to this and spinning it. Now you need to do work on the boiler. So you light up another boiler, get it up to speed, and then you switch. And the way you switch is you simply turn the other one off, the steam stops, but this thing keeps turning. It's got a lot of momentum, and you have a couple of minutes now to get the other steam flowing into it, and you just continue generating power. That's what we've been able to do. This is 100-year-old technology, and it's reliable, it's very well known. It's why we just expect our PowerPoints to work, to the point where you forget all of the magic that goes into that. Now we got to talk about how we're changing it, because we're changing it for a lot of good reasons. But that mechanism is not going to be the mechanism for all of the power we generate these days. The usual way when we have to compare energy sources is we use a thing called LCOE. So this is the levelized cost of energy. So that's how much does it cost to build the power plant? How much does it cost to operate the power plant? How much does the fuel cost? How long does it last? How do you clean it up? Hopefully you include that in the math. That, and how much energy will it produce over the lifespan of that power plant, divided by the number of megawatts, is the levelized cost of energy. So that's a way for us to provide a measure between all these different power plant systems. Now, for better or worse, Norway's power grid is somewhat, tough terrain, but the people kind of live towards the coast for the most part, so that's where you've run your wires, and you're got mountains, got water, hydro. So we're gonna, spend more time on hydro, but I want to run through all the major power sources and roughly their costs, and then we'll talk a little bit about the role of it. So let's start at coal. You had one coal power plant. It's in Svalbard, which is also where the coal mine is. How useful. That power plant's now closed. You've replaced it with a diesel power plant. We'll talk about that. But you still got the coal mine running, at least for a little while. You're selling it to other people. Coal runs somewhere between, this is all US dollars, $65 to $150 per megawatt, levelized cost. Typical lifespan of a coal power plant is 40 to 50 years. These are largely falling out of favor because coal continues to get more expensive. It's also the most lethal way to generate electricity. More people die per megawatt by coal than any other way. That's miners being killed, that's operators being killed. Coal explosions are a business, they're very serious. That's the poisoning that happens shipping coal from the mines to the plant, as well as the effluent that comes from the plant, causing cancers and killing others. Generally falling out of style. When coal started in the 1750s in England, it was called the savior of the forests. It was the rock that burns, because up until then, if you needed heat to cook food or keep your house warm, you cut down a tree. But then they found the rock that burns, and it was going to save the forests. We know better now. Oil power, pretty much out of business. This is not there's better ways to use oil, but once upon a time we used to spray it into a burner to boil water to spin a turbine, same way we do with coal. There are no oil power plants in Norway. There are a few in less developed parts of the world. So not a great way to make energy. It's expensive. $75 per megawatt is pretty pricey. Obviously, oil and gas has a role to play in Norway. Is your largest export by a non-trivial amount. There's a bunch of oil gas people sitting in the front row here ready to heckle me. Join in. And you're now the largest gas supplier in Europe because somebody else went offline. Anyway. Yes. If you're going to burn a petrochemical to boil water to spin a turbine, the way to do it is the combined cycle natural gas plant. These are still pretty popular. They're cost effective. Running in about $45 to $75 per megawatt. So on the cheaper side, they're very inexpensive. The reason is, and this is the combined cycle part. So here's how this thing works, is they're quite small, relatively speaking. This is an air box. So the air comes through here and is filtered. This is the turbine. So there is a high pressure turbine like a jet engine that the natural gas is pumped into and burns at very high temperatures and speeds, and that turns a generator. And then there's an expansion box here to a steam turbine. So now they take the residual heat that comes out of that jet turbine, boil water at pressure, and spin another turbine with it. Combined cycle. So the amount of energy they get per ton of carbon dioxide is the highest. It's quite a powerful way to go. You have a handful of these that you don't appear to be using. So mostly they were built to burn gas that you couldn't sell at a reasonable price to operate oil fields. So Karstow, Mongstad, all similar. There's one higher up in the north. It looks like they built it and then never actually used it to generate electricity. It's fun to have money, isn't it? I'm not used to seeing this in different parts of the world when I look at it. It's like, you built this plant in 2015, you turned it on to make sure it worked, and then you turned it off. 150 megawatts. All right, good enough. There's only one combined cycle plant, and that's the one in Karsto, and it's actually being dismantled now. It was about 400 megawatts. Nuclear power. You've never made electricity with nuclear power commercially. In Norway, you do have a handful of nuclear power plants. Now, this is still the same essential mechanism as opposed to burning coal or oil or gas to boil water. You find really weird rocks, and you purify them and put them close together, and they boil water. And you keep them under pressure till you get about 300 degrees. You go through a heat exchanger so that you don't use the radioactive water in the turbines, and you spin turbines. That's how this works. That's the light water reactor. We could get into other models, but it's fairly far off the reservation. There are only 4 nuclear power plants in Norway. They are all decommissioned now. They were all research plants. They experiment with different technologies. The very last one to be shut down, which is the Halden boiling water reactor, did an experiment from 2012 to 2018 on using thorium as solid fuel. Thorium is the lowest of the actinides. It's the lightest radioactive element as opposed to uranium, which is somewhat heavier. It's 5 times more plentiful than uranium, so there's always been an idea that we could build reactors with this more plentiful material. And so they actually did a set of tests at Halden to run those as fuel rods. There's a bunch of problems with doing that, but it was an interesting experiment that has ended. And now they're in the process of cleaning those plants up, which will take decades. Radioactive materials are tough to work with. You try not to kill people while you do it. There's really no reason to use nuclear power in this part of the world, but we'll talk about the modern approaches to nuclear as we go further down the path. I'd be remiss not to talk about biomass as a power plant. So this is taking agro-waste and burning it, again, to spin a turbine, to boil water and spin a turbine. Why do this? Because you have it. So typically, these are small plants, a megawatt or two here and there. You make about 140 megawatts total in Norway across a couple of hundred different plants. So where you're growing things, you have agro-waste. And one of the things you can do with it is turn it into electricity to run the agricultural facilities. Power distribution is very localized. It's just a good way to use up the waste. There's a more efficient mechanisms here. They are somewhat polluting, but you were going to release that carbon anyway, right? You take the leftovers from making pulp. If you bury it in the ground, it's going to release carbon. If you burn it, you make energy and you release carbon. So it's kind of a trade. It's just a thing that we do. You don't do this at scale. Geothermal power. Now, this is a really cool thing if you think about it. I drill a hole into the ground to where the rocks are really hot. I send water down there. It comes back with a whole bunch of energy in it. I spin a turbine. I cool it back down. And I pump it back down again. Really no emissions from this whatsoever. The problem is the hole drilling part. The longer the hole is, the more expensive it gets. And so it's only where the hot rocks are close to the surface that it makes a lot of sense to build geothermal power plants. Go visit Iceland. Their rocks are a little too close to the surface these days. I don't know if you've noticed, but it's kind of hard on fishing villages. This technology is evolving a lot, actually. I did a whole hour on geothermal power if you go look for the Geek Outs on .NET Rocks. And I think I did a good enough job that the Geothermal Society asked me to come and present. It's like, I'm not actually a scientist. I'm just a storyteller. He's like, I really like the way you tell stories. The hard part here is that, yes, drilling holes in the ground is hard, and the oil and gas industry are the best at it. In fact, what's happening to geothermal power now is a bunch of the technology that was developed for fracking is now being applied to geothermal power so that they can drill horizontally. So they find a bed of hot rocks relatively close to the surface, 2-3 kilometers down. Then they'll drill beside it and come underneath it horizontally, and then they'll fracture that rock so they have more room to pump water in there that'll immediately heat up, and then they drill draw holes above that bed so the steam comes up through there. Now, why is this better? You get more yield, so you're going to collect more energy, but one of the things that happens when you keep slamming cold water into hot rocks is the rocks get grumpy. They shatter. They create little earthquakes and things. And sometimes the water doesn't come back anymore. And so the expensive part of your geothermal power plant just stopped working. But if you're doing horizontal drilling, you can still use the down line. So where you drilled in by the side, you can use that line and now drew new feeds across into the bed again and possibly relight it. So these are experiments being done in America right now. Google's actually driving a bunch of this. They want to use geothermal power to run their data centers. And so they have a 5 megawatt pilot plant now generating electricity based on this methodology. One other thing, which feels more science fiction, but I have seen it, it is real. Instead of drilling the traditional way, the oil and gas way, which is with diamond tip grinding bits that you have to replace because the rock is really hard, and then you keep pumping fluid in to keep them from overheating and have to pull the material up as you drill, which is expensive and time consuming. Is why drilling is so hard. There's a group of scientists that built a microwave-driven driller. So they use 9 gigahertz microwaves at the end of the head to vaporize the rock into plasma. Like this is Star Trek. So, and then which naturally lines the walls of the hole as they're going down with vitrified rock, and they can just keep on drilling. There's no pressure necessary, no pressure management needed for that, and the hull is self-sealing. It's a lot of energy, like to run a microwave like that, but it's another way to drill that opens some possibilities for what can happen in the future. More geothermal power would deal with a lot of issues. They tend to be smaller plants, which we're getting better at. They're localized to the ground around them. If they're maintainable, their emissions are tiny. Their explosion risk is 0. There's no pressurization here. Like, for the most part, they're very, very safe. So we could do with more geothermal power. We just got to get more reliable technology for it. Diesel electric. All right, you've just built one in Svalbard. These show up where I didn't even mention the cost of these. When they work, they run in the 50 to 90 megawatt range, so not as cheap as combined cycle gas, which is also stunningly reliable, even though it's got emissions. The geothermal is a bit more expensive than that, and it can be much more expensive than that. But it can, when you're planning on a 50-year lifespan for your power plant, and then one day it just stops working because the water doesn't come back, that's why people are afraid of building these. So diesel electric, you only do this where you have to. Islands, places with a limited population, limited number of resources, no natural way to generate electricity, see Svalbard, right? So what they're committing to give up coal is ships coming routinely to fuel basically a giant diesel motor. When you don't have to move the motor around, because we always think about trucks when we think about diesel motors, but if you don't have to move the truck around, there's a few things you do differently. A, the gas tank's really big and underground, but so is the oil reservoir. So they use a massive amount of oil so that they don't have to do oil changes per se. The oil just keeps cycling through, and occasionally they draw some off and replace it with new. They're designed to run 24 hours a day, very stably, but they're stunning. They're in a small, 10 to 20 megawatts, not the 400 or to a gigawatt that we get from modern power plants. $400 to $600 a megawatt, like just very expensive ways to make electricity. But there are few options in some of those places. And Svalbard is one of those challenges. And they're not the only ones. If you go down into the Canary Islands, mostly run by diesel. It's just what happens there. All right. Hydroelectric. Maybe you've heard of it. Inexpensive, $40 to $50 a megawatt, mostly because of extremely long lifespans. 100 years for a hydroelectric plant is normal, right? With maintenance. They last a long, long time. They count on a simple truth, which is that I have a high altitude place and I have a low altitude place and water in both. So as long as there's water coming from above, I can capture that energy as it falls, right? The potential energy is the altitude of the water. 1,769 hydroelectric power plants in Norway. It's 88% of your electricity. You got mountains and you got water. But that's the weakness of these. Sometimes you don't have water. So, you're capable, you've got the largest hydroelectric system in Europe, and you're capable of producing 156 terawatt hours per year. That's a huge amount of electricity if you have enough water. So you have already had years where you've had to dial back using hydroelectric because it didn't rain enough, and the reservoirs don't stay full. So we've always thought that when you just presume that nature was unmovable by us, the hydroelectric dam would run forever, but we're already finding the issues. And this is true in British Columbia, where we have mountains and lots of water most of the time. And so we're able to make most of our power in this zero-emission way by just using the gravity of water as long as it rains. And so now we have to start looking to alternates, but it turns out we can do more with hydroelectric power. We can also use it as a storage mechanism. You can pump the water back uphill. Largest hydro complex for you guys is Ullafjord. I love pronouncing Norwegian words. But what's cool, what I like about that, looking over the setup, is it's actually 3 different power plants using the same water, stepping down over distance. So, getting a lot of electricity that way. Okay, I've talked about mostly traditional power systems. Let's get into the newer stuff and we'll talk about wind. Why is wind so popular in a lot of parts of the world? Your neighbors to the south, the Danes, have a ton of it. Cheap. In 2023, you're talking $25 per megawatt LCOE. That is inexpensive. It's a race between who's cheaper, wind or solar. They're both getting stunningly inexpensive. As of 2020, because the numbers are hard to get newer numbers than that, you have some of the largest wind setups around, and you've got some of the biggest offshore. So there's really, we got to break these into multiple categories. Onshore being the big one. It's easy to build. You generally put it in places where folks aren't around, although you are running into issues with the Sami, as I understand. I got to do a lot of reading. Mostly doing translated Norwegian stuff, because it wasn't actually published in English. So listen, I'm from Canada, where we have mistreated our indigenous people for a long time, and we're trying to do stuff about that. I feel for you. It's hard. It's hard to try and do the right things. But it's 11% of your electricity, which is about 5 gigawatts of production capacity. So if you're doing the math, 88% hydro, 11% wind, and you have about 1% left, which is the biomass stuff and Svalbard's solutions, such as they are. But this is for the most part, what you're doing. And the on-land stuff is great. It can only get so big. There's always, folks talk about bird strikes on wind turbines. One of the complaints about it. Just to be clear, the current estimate as of 2020 was about 500,000 birds a year died of bird strikes on wind turbines, as compared to 2.5 million killed by domestic cats. If you want to protect birds, keep your cat inside. The University of Virginia put a camera on like 50 cats to watch what they did when they were outdoors. Not all cats kill birds, but the handful that do are psychotic. They kill everything they can find because it's fun for them. So yeah, if you kept cats inside, and by the way, you think cats are bad? Current estimate for bird deaths due to window strikes on buildings, $4 billion a year. Don't worry about the wind turbines. That's not the issue. We have much bigger issues around that. That being said, when you go offshore, there is thought when you place wind turbines offshore to try and position away from migratory paths. I mean, it's one thing to kill the birds, but it also damages the turbines, and that's a bigger issue. So they do try and position them. Now, we tend to call this near-shore placement. So these are wind turbines that are actually embedded into the seafloor. It's good to, you only do that up to about 50 meters. There's some concern about the damage it does. In order to do this, you build a casement, so basically a big steel tube gets put down to the seafloor, the water's pumped out, then in comes an auger, drills a big hole into the seafloor, then they pour a whole lot of concrete, put the mast in that wind turbine, right? Ask the Danish, they've done this a lot. They have lots of shallow water, just the stuff you don't have, right? 50-meter water almost doesn't exist in Norway. If you're in the water, it's deep, right? They call them fjords for a reason. And I relate, British Columbia is the same thing. We have no wind turbines in the near shore because once you're a kilometer off the shore, that's 200 meters of water and going down. So there is developments now into floating wind turbines. So this is straight out of the oil and gas industry. You know it better than ever. This is one of the Eleanor designs. It's way more complicated than you realize. They cable stay them, try and keep them in place. Each of those columns are actually ballasted. They shift the ballast to counter motion, including torque from the wind turbine itself. The upside to offshore is substantial. You can build them far bigger, the largest wind turbines in the world, that larger wingspans than 747s. One rotation would power a house for a year. That kind of scale, 10 gigawatt turbines, all offshore. They're far enough offshore when you can get into deep water like this that nobody sees them, lowers the complaints. The downside is the electricity is not needed there, so you do have to run cables back to shore and deal with all of those challenges, and that costs money. However, so this offshore stuff is more expensive. It's not as cheap as the nearshore, as the onshore stuff, but has huge advantages. The wind is stabler out there, blows more often, it's very consistent. We get decent lifespans out of these now. We are dealing with the challenges of replacing turbine blades and what to do with turbine blades, so they're becoming more recyclable. But that's all because we've been building far more of them and getting better at establishing that industry. So Norway leads the way on this. They've done a lot of the most interesting construction there. The Hywind Tampen offshore farm has been in operation since last year. It's not huge, it's only 11 turbines, which makes it very expensive, but the nice thing about the wind turbine system is that once you get the license, you can build the initial plan and make sure you've got everything working, and then you just keep adding to it. And then the cost per unit starts to go down more and more and more. That being said, none of this power is being consumed on shore at all. They mostly use these offshore turbines to run the oil platforms. So instead of burning fuel at the platforms to run generators to make their electricity, a portion of their power is now coming from these large turbines, about a third at this point. But if that's only 11 turbines right now, they scale it up to about 40, that could be all the power they need for those platforms. One other class of, I'm going to talk about solar, but I should talk about all of solar. Let's talk about heliocentric solar. So this is not, the solar cells you're thinking about. This is heliostats, mirrors, all aimed at a central point. This is actually a 2 gigawatt plant in Morocco where they got a lot of sunshine. And they focus all that light into that central pillar in the at the center where it gets white hot. And they pump fluorine salts. They get up to about 800 degrees centigrade. It's liquid between 400 and 1,000 degrees, and then they pump that to turbines to spin turbines. One of the upsides to using those high temperature salts is they get so hot, they last through the night. So it's actually a 24-hour-a-day power plant. The problem is you need a lot of sunshine, and they're really quite expensive, 120 to 150 per megawatt LCOE. Why? All those mirrors are continuously moving. They're tracking the sun to keep it on the mast. They all have 2-axis motors on them, and they're in the desert. And motors don't like desert. And so you have a team of people ranging over the kilometers that cover this, constantly repairing those motors. That's what drives up the price of operating this. It seems like the ideal power source. 24 hours a day, working with the fluorine salts, running turbines very reliably, except that it's expensive to maintain because it's just tough conditions for making electricity. Commercial electrical solar is the cheapest power right now. I think the current price is coming in about $23 per megawatt. It's back and forth between wind and solar these days. The reason is largely the Chinese started mass producing these 22% efficient cells a few years ago for their own use and sold them to everybody else. Just the scale of the manufacturing drove the price down. We could have done this years ago. They're the ones who actually did it, for better or worse. But this is a process of capturing electricity directly through the silicon. It's manufactured much the same way you make CPUs. It's one of the reasons it could scale so well. Typical lifespan for solar panels about 20 to 25 years of this particular species of panel. They lose about 2% efficiency per year. The temperature matters. The hotter they get, the worse they get. So solar panels in the desert are not good. They don't last. It's too hot. Temperate zones do better. You don't do a lot of solar in Norway, and the reason is land. You don't have these big flat spaces to waste. Where you got them, you grow food, and good on you, because eating's fun. I do it a lot. But you do cover your roofs in it. So commercial buildings covered in solar panels are pretty common. They're not as cost effective, so super cheap to do those huge panel arrays down on flat land. But as soon as you put them on roofs, every one of the installations is different, and the price difference is almost a tenfold, 150 to 200 per megawatt. But that's kind of a funny number because you never install a megawatt. You install less than that. Roofs are only so big, and for the most part, that power is consumed by that building. So you're localizing distribution. If you can take a commercial property off the grid effectively several hours a day, several months of a year, it makes a huge difference in the grid overall. Yes, there are buyback strategies. They have a limited amount of utility. Electricity does not flow like water. It's not fully bidirectional. It cannot be stored easily. So the buyback stuff is largely political to make these installations make sense. There is a little bit of sharing that happens, but that's not the reason to do it. The reason to do it is to take the pressure off the grid by being able to supply power at certain times of the day and year. We're 60 degrees north here. I live in a place that's 50 degrees north. It gets dark, except in the summertime when it doesn't get dark. And they don't need perfect sunshine. They work better than you think. In theory, the sun represents about a kilowatt per square meter of energy landing on the ground. And realistically, we capture maybe 200 watts of that per meter. And then when you deal with weather and things, it's about 100, 150. If you get to 200, it's a good day. We're getting better at the controls around this to get more yield from it. All concentration strategies we try, where let's put more solar by focusing it or using reflectors and so forth, tends to overheat the substrate, which reduces efficiency and lifespan. So the reason we do it this way is to keep that price down. Same for rooftops on your house. Yeah, we've done roof solar tiles like our friend Elon has, although largely that's been a failure for a couple of reasons. One is it's far less efficient. It's far more complicated to install. It has lifespan problems. And for most people, putting solar on your roof is virtue signaling anyway. Like, I'm going to go all that trouble and not make it apparent to people? No, give me the ugly ones. Let me see it. There's lots of efforts going on in solar to try and get better than the 22% that comes from silicate substrate, this particular approach to photo solar. And you've probably heard some of these in the news, like perovskite. So perovskite is an organic crystal approach, and it has yields in the 30% range, which is pretty exciting, except they have, as soon as they get hot, they start losing efficiency. And the lifespans are low, like less than a year. So great in the lab, bad in the field, not a product. Doesn't mean we're still not working on it. Like, there's lots of smart folks trying to build them better, and so make them more reliable to last for longer. Okay. LCOE is very unfair when we talk about solar and wind. Why? Because all the other power systems we've got that we talked about, we have complete control over. You decide how much gas to put in, how much coal to put in, how deeply you put your control rods on your uranium to make as much electricity as you need at the time. In fact, your grid was designed, and all those people that work really hard to operate the grid are about making exactly as much electricity as you need at the time. That's the way the grid has happened for 100 years, and only in the past 20 or so have we messed with that model, because these power strategies, both solar and wind, don't comply. They don't generate when you need, they generate when they can. And that actually destabilizes the grid. The grid's getting better at dealing with that. And so one of the approaches to dealing with that problem of I don't have power when I need, I have too much at certain times, is to try and store it. And once again, our friend Elon pops up with taking the designs of the batteries that he used for his cars, which have been very successful. I see a few of them around this town, oddly enough, and making them into stationary battery packs. So excess power available, stored in the battery. Not enough power available, discharged from the battery. They're expensive. And the lithium-ion battery design is wrong for this application. Lithium-ion are light relative to the amount of wattage they can store. That's why they're good for cars and phones and things like that. They also can charge rapidly and discharge rapidly. All features great for a car, not needed for the grid. The natural discharge cycle of a lithium-ion battery is about 6 hours. And so typically in a grid scenario, you need power for longer than that. But the upside to what Tesla's done by maturing this to the point where the Australians are running a bunch of it, they got some in California and a few other places, is that it's made a market for grid scale battery storage, but we're switching technologies to things that are better suited to the grid. One of them is Form Energy. So this is actually from Matteo Jamilo, who used to work for Tesla, and he left to make batteries for the grid. His preferred battery design is actually a NASA battery called the iron air battery, storing energy in rust, which is messed up, but it's cheap, 1/10 the price of what it costs for lithium-ion batteries. The downside is it takes up more room, it's heavy, and it's hot. None of which matters if you're building grid storage. And the natural discharge cycle of an iron air battery is 100 hours, not 6. So now you're talking days of power to discharge on a normal discharge rate. Charge is slower, discharge is slower, but fast enough for grid applications. So they're now actually broken ground on this. They've been talking about it for forever. There's the site the furthest along to being operational is in Minnesota. They also have projects in Virginia, Texas, and Georgia. So it's purely been a U.S. initiative so far for a U.S. company, but they're becoming real. But you guys already have batteries. The smart Senja packs up in Senja. So this is the big island up in the north. I did not know this. I learned about this week, okay? And these are battery packs from the German side of General Electric, which confuses me. They've actually replaced them twice now. They've been experimenting with different battery technologies, but it's the Senja, for better or worse, is sort of the end of the grid in Norway. That's the challenge of being on an island. So they have the most power problems, and they're using these batteries to bridge between it. And it's helping in their fishing industry and things like that. So you're there, you're using it in a very specific application. Because I think for the most part, we're coming to the conclusion that batteries are probably not the solve here. That the better way to store energy is pumped hydro. So basically running a hydroelectric dam backwards. Instead of letting the water fall down and spin the turbine and make energy, we power the turbine to pump the water back up into the reservoir. The Australians did a massive study a couple of years ago where they showed geographically all over the world that pumped hydro could do most of the power storage for you. The problem is that hydroelectric plants need water supply at altitude as well as a place to put it below. And there are fewer of those. There are places where you have water below and a high slope. Because if you're just going to make pumped hydro, you can build a reservoir at the top of the mountain. You don't have to have water flowing into it already, and then you just pump water up there. The advantages of pumped hydro is they're quick. As soon as you have excess electricity available, you can turn on the pumps, start running the water uphill. When you don't have enough power, you literally let the water fall back down, spin the turbine, and make the electricity. It's about an 85% conversion rate, which is decent. The more important part is hydroelectric technology is completely known. The power industry is very conservative. They want to do 50-year projections on stuff. Well, you can do that with this technology. So we've pretty much demonstrated that the combination of intermittent power sources like solar and wind with enough pumped hydro can do a lot. They're always going to want a certain amount of baseload. The question is, what are the emissions of that baseload? And none of the unemitting energy sources can work as baseload with the exception of geothermal power and arguably nuclear, but we'll talk about that more further on. But this technology, you already use it. There's a ton of pumped hydro, mostly modified existing hydroelectric plants, where when you have excess energy, you pump it back uphill. Norway doesn't do this much, but other places that have a lot of pumped hydro are starting to put solar panels on the reservoir to make even more electricity. The solar panels are cheap. They like being on the water because it keeps them cool. They slow the evaporation of the reservoir, which is useful. And they don't work when it's raining, but the reservoir is filling up anyway, so that's fine. And when it isn't raining, you can use that power to pump more water uphill if you want to store more. So it's a good combination, right? And I think you guys will get there. It's just a question of how far you go down this path. The Portuguese have done a ton of this. They got about 800 megawatt pumped hydro solution in the northern part of Portugal. And they've covered the whole thing in solar panels. It's almost a self-referential loop now. All right. I would be remiss if we don't talk a little bit about hydrogen, which is another way we're talking about what to do with excess power and various forms of what to do with the hydrocarbons that we have. This is a very popular topic in Europe, for better or worse. It's less popular in other parts of the world. So most hydrogen gas today is made by refractoring petrochemicals. They already have the hydrogen in them. You can do a bit of chemistry to break it apart. And that's the gray hydrogen approach, and it has carbon emissions. Then we have this idea called blue hydrogen, which means we're still going to do that, but we're going to try and capture all the carbon dioxide. And then there's the version of green hydrogen, the one everybody wants to talk about, which is I put electricity into water. You've done this in your high school or your science experiments. Separate that water into hydrogen and oxygen, no emissions, beautiful. Let's talk about the problems. So our known mechanism that is used the most is what we call methane steam reformation. So this is pumping a bunch of energy in to effectively burn that hydrocarbon, methane, yanking the carbon off and combining with oxygen to turn into carbon dioxide and getting the hydrogen away separately. It's efficient, it's fast, it's more than half of all hydrogen produced on the planet, for better or worse. Every ton of hydrogen you make this way produces 9 to 12 tons of carbon dioxide and consumes about 6 megawatt hours of electricity to do it, right? This is the baseline. It's a serious emitter of carbon dioxide. A more advanced form of this is the blue hydrogen approach. Is called methane pyrolysis. So now we up the energy consumption. So now we're consuming about 10 megawatt hours, so that we make a ton of hydrogen gas from that, and we get 3 tons of solid carbon. We're running at a high enough energy level the oxygen doesn't bind to it, and so you get graphite out the other end. Stuff you can bury if you want. It's just far more energy intensive, and it runs very, very hot. It's a challenging industrial plant to work from. And then there's the one you want, the green hydrogen approach, which we got about 4% currently being made in the world this way. 1 ton of hydrogen makes 8 tons of oxygen in electrolysis. You can do what you want with the oxygen for 40 megawatt hours. So 4 times the power of what it takes to do methane pyrolysis. It's just so energy intensive to make hydrogen this way that it's not cost effective. So that's why it's just not grown, because it's expensive. Where this gets interesting is when you start talking about excess electricity. Like the electricity that would have otherwise been wasted, maybe you could do electrolysis and just make hydrogen with your excess energy. The problem is that these systems don't actually start up that fast. So you need a larger window of excess power to make it make sense. Better to spin motors and pump the water uphill, which you can do in an instant, than it is to do this. In general, power storage falls into an array of bands. There's lots of different approaches to how do we store energy. In this graph, we're talking about more energy storage across the bottom and more storage time across the side. So capacitors can't store a lot of power, and they can't store it for very long. Batteries sort of in the middle there. Your pumped hydro, it seems to be the most advantageous, and throw on top of that the reliability of it. Hydrogen represents an excellent way of storage. It's very dense storage, but it's very energy intensive. So it's costly to do. Meantime, our cost of power has changed substantially. Coals continue to get more expensive. Geothermal's really not moved all that much. Nuclear is very expensive for a variety of reasons, and solar and wind have fallen off in the past 20 years to make a huge difference in our ability to produce power. That being said, using our world in data, you can still see that oil, coal, and natural gas represent the bulk of energy generation on this planet up until at least 2021. The IEA announced this year that a third of all energy production was now in non-carbon emitting. The argument is we're about a third of the way along to what we needed to get to by 2050, which means we're well behind. But when I'm talking to young people about this, they're mostly despairing that we're nowhere. And just to tell you, we have really made progress on decarbonizing energy generation around the planet. We have. Back in the Kyoto Accords in 1998, the estimate for what was going to happen if we did nothing by 2050 was 4.5 degree increase. That will not happen now. We've already moved the needle enough that if we stop doing anything right now, we'll get to 3 degrees, which is still a catastrophe, but less of a catastrophe. I'd only say that to say we're making progress. We just need to do more and keep moving along on these things. And we're not going to make a degree and a half unless something radical happens. It's going to be somewhere in the 2s, which is very bad. But it's not, and be clear, not bad for the planet. The planet couldn't care less, right? Bad for us. Now, admittedly, we live in the wealthy western part of the world, so we'll be the least impacted. It's the less developed parts of the world that suffer the most, and we have plenty of climate refugees, and that's a different talk. Let's talk about the newer technologies coming down the pipe, and I'm going to go back to nuclear because in certain parts of the world, this is a great solution. The problem with nuclear power in the existing form that we do it in is that each of these plants is bespoke. It's why it's so expensive. Every reactor is distinct. Every site does all of its own operations. So fuel rods come in from a factory elsewhere, typically made by General Electric or Siemens, brought in, they're then assembled on the site to build a fuel core, about 50 tons, and then the reactor is opened, the old core is removed, and a new core is put in. And over a course of a year, several times the reactor shut down, the cores are shuffled around and reassembled. All of that very dangerous, high radioactive handling is done at the site. If you're going to do that, you need very skilled people, you need an incredible amount of regulation and certification, and you need a huge space. You got to keep people away from this, because if you make mistakes in fuel handling, it's very serious. And it's why nuclear is not popular, because it's frightening. And we've had a handful of disasters. That being said, it's killed very few people compared to any other method of making power. But there are more modern approaches now that are being developed and are close to actually being implemented. So the idea is this. Where we use the power, we don't do fuel handling. We just make the electricity there. So we make the reactors modular. We make them smaller, 300 megawatts. The operation site is a series of tanks that you put the reactors into when you operate them from 2 years. They're assembled at a protected site for skilled people. And then the entire reactor is shipped by truck into the site and out again. Now, this is not that weird. We already ship fuel assemblies this way. Now what you're doing is shipping all of the radioactive parts, all of the dangerous stuff, already assembled, brought to the site, run for 2 years, then removed, shipped to a processing site. So now all your skilled people and careful regulators, so forth, lives in one place, away from everyone, supporting multiple power generation locations. Here's the more important part that I think this crowd gets better than anything else. You replace the reactor, the entire reactor, every 2 years, which means upgrades. The key part of what happened to Fukushima actually had 6 reactors. You didn't hear about reactor 5 and 6. You only heard from about 1 through 4. Right? 3 was off, 1, 2, and 4 all had the explosions. Why? Because they didn't have passive shutdown. Why didn't they have, and 5 and 6 did have passive shutdown. Why? They were built 3 years later. TEPCO, when the passive shutdown option came along, said, we don't want to shut down the reactors for 2 years to refit them with this when they've only got another 5 years to run. Not worth it. Then tsunami. Right? And we put our emergency backup generators in the basement where the water is. Anyway, the point is we have passive shutdown reactors. They can be very safe. And we just got to build them that way. And if we keep them smaller, when they're down to this size, they actually don't have enough thermal mass to melt their containment anyway. And more importantly, you keep making better reactors over time. So this technology is being built by GE Hitachi. There's in Ontario, Canada, which gets 80% of its electricity from nuclear because they don't have mountains, and they don't get enough wind, and they don't get enough sun. They're now replacing their old CANDU reactors with this technology. So they're in the process of doing the first installations. They're a couple of years from first light, from actually running it. But same thing. Now, the Darlington site where they're going to do this installation, no fuel handling there. All the dangerous stuff is done further away up in the shield. And then it can do the continuous upgrades. All right, a little bit of fun, the last few minutes we've got. Let's talk about fusion. This is a picture of ITER. Except this one's assembled. ITER is still not built. It's only been 20 years. What are you in a big hurry for? And ITER, even if it works perfectly, will not actually generate electricity. It should maybe be somewhat positive. Trying to recreate the sun is hard. We're trying to do it with magnets instead of gravity, because if we do it with gravity, it would hurt people, so we don't do that. But ITER is also using niobium-10 superconductors. This is the same stuff that they use at the Large Hadron Collider, and there are better superconductors. So over in America, Commonwealth Fusion is using REBCO superconductors. So you know, all those videos you've seen of the little cube floating over the liquid nitrogen, that's a REBCO, or a ceramic superconductor. And they're superconducting at liquid nitrogen temperatures. The problem is they're not a metal, so making them into wire has been extremely difficult. It took, those ceramic superconductors were found in the 1980s, and only in the past few years have they learned how to make a ceramic flexible tape to make coils from it. Commonwealth Fusion, partly funded by Bill Gates, but it's out of MIT, they've built 1 plate of the 8 plates for the reactor about a year or 2 ago and ran it at full potential. The magnetic field is about 5 times stronger than what's possible with niobium tin, which should be able to offer better containment. Smaller reactor, more efficient. So now you haven't heard from them, and let me tell you why. The only time you hear from scientists is when they need money. That's when they publish papers, and if you read the paper, it always ends with, further research required. I need money. Have you heard from Commonwealth Fusion? No, because they got money. They're busy building right now. Is this going to work? No idea. If I had a fixed amount of money to solve all the energy problems, would I spend it on this? No. Because we have known technologies we can do today that would make a difference by 2050. We do not know when this will deliver electricity. I hope it works. I want it to exist. This would make me happy. But if I was actually responsible for trying to reach the goals of the Paris Accord, this is not how you do it. This is still experimental. Now, we have enough money in this world to do all the things, right? We should be spending more on pumped hydro and low-emitting energy and moving faster on all of this. That doesn't mean we couldn't also still do this. But am I going to wait on this to solve the problems we need to solve in the next 20, 30 years? No. Just keep going, guys. I hope it works. It'll make a difference someday. By the way, machine learning comes into play. These are machine learning models for plasma management. They're going to start using a neural net to manipulate the field to better contain the plasma, because it's been part of the problem making fusion work. So some of the stuff that we're doing today is playing in new energy. Down to the last few bits. Let's talk a little bit about a modern grid. So the electrical grid was built to be a one-way thing. Relatively few large power plants generating very consistent electricity with serious emissions, being available at all your power points at all times. Enough redundancy that a plant could go down or be used for maintenance and you still had electricity. Flexibility enough that when the football game is on and everybody puts on the kettle the moment it ends, we can spike up the power generation to tolerate that. They really do that, by the way. They keep track of weather, they keep track of sporting events, they keep track of major concerts, things like that, where there's going to be spikes in power when stuff changes to be able to have the grid tolerate that. That was the old way. But now as the number of power sources hugely increases, every wind turbine a different power source that has to be synchronized and managed. Every solar array, part of that problem. So we now went from a handful of power plants that had names to power all over the bloody place. They've had to learn something we've known for a long time. They've had to learn peer-to-peer networking. Look, the rest of the world, we've lived in this because we're internet people. The rest of the world is confused by it, and the power industry doubly so. But they're catching on. They've hired the right people. They're starting to get better at building a smarter grid, a grid where we can vary power rates by the hour, and we can start to have equipment responding to that, where folks that want to play arbitrage, where I'll store power now to use it later, becomes possible. That's emerging now. A few years ago when I started doing this talk, like when I did it back in 2016, we couldn't talk about this. But this is happening now. The electric car has been a stimulus to that because it's a huge amount of power, right? That's more power than your house generally uses, just because 0 to 60 in 3 is fun. And so that's where the solar panels on the roof become so important, because we localize power generation, we use it locally, and if you're fortunate enough, you're also putting a few batteries in, so you can store your excess power and use it yourself, right? You're also seeing a big push to electrify everything, to use less gas. So I bet you're getting subsidies for heat pumps just like we are in BC. You know, they want us to use more heat pumps because they've become more efficient, better than they ever used to be, and they're electricity-centric. And they represent points of discharge, which will be a part of this grid problem overall, right? We'll be able to play games with adjusting all of that. Same for the induction stove. Listen, I love gas stoves. I prefer cooking on a gas stove until you get a really good induction stove, and then you're done. You've never boiled water faster in your life. It's actually too fast. I didn't have time to go to the bathroom, right? But they consume an epic amount of electricity. So you do need your house to be wired for it. You got to be able to tolerate all that. Same for the electric car. Being able to shape when to charge. We create the EV in popular parts, and you guys are one of these folks, had that problem where everybody came home from work, plugged in their car, and started cooking food. And the grid's like, oh, right? So we started getting smarter now, and I've worked with some folks in different parts of the world where they actually did the math to say, does the car have enough charge to get to the nearest hospital? Yes, then delay charging it until the rate's lower or we can distribute against the grid. Decrease the brownout stress. Charge overnight. I wonder if one of the things we're all going to get to do is to start modernizing appliances across the board. You think about an ESP32, right? They're less than $1 now. Size of your thumb, runs.net. Like, what more do you want? It actually doesn't make sense to use traditional electronics in our appliances anymore. We can do this more advanced stuff because they're actually the cheapest. So you can see a world where the power's coming into the house with a continuously variable rate, hourly or less, Your goal to get your dishes clean is not to wash them immediately, it's to be clean by morning, right? So you can basically tell it, be clean by 5 a.m. And now it negotiates for power for you. Well, when's the power going to be cheapest? After 2. Okay, that's great. And sometime around midnight, the local wind turbine kicks up and has excess power at half the price than that, and your dishwasher goes, oh, sure, I'll take some of that, and does its cycle then. You're already writing the code in your head. I can see it in your faces. This is not a hard problem for us, right? But we're not appliance makers. We're going to have to get involved in that. But when you think about a really smart grid, it's all the way to the endpoints, all of this. And I hope you feel the enthusiasm of this. We're making progress on this. The main problem with the grid right now is the variability in power. The more we can levelize that, the more dirty power plants can be turned off, and the cleaner ones can be lit up with their irregularities in it. And part of that will come with how we consume power. And I'm not asking us to be diligent. I'm asking us to write better software. So that anybody can do this. They don't need to think about it. The appliance simply does it, and you get a better rate, and your power bill is less, and we decrease the impacts we're having. I hope this was fun for you, because it was very much fun for me. It's so much fun to understand the Norwegian power grid. Thank you for your time. And the peanut gallery did nothing.
All right, good afternoon. Welcome. Thanks for coming and finding your seats in such an orderly manner. I love coming to the Scandinavian countries. Like, the folks are just so polite and organized. For those of you who don't know me, my name's Udi Dahan. I'm going to be spending the next hour talking to you about how to decouple your services. I'll be covering a fairly wide range of topics, and at the end I will come to this one weird trick. So if you're wondering what that is, you're going to have to stick around a little bit longer. If you want, you can follow me on all the socials. I'm at Udi Dahan. I'd be happy to connect with you afterwards. I work at a company called Particular Software. We have a booth over there. Come see me afterwards. We'll talk some more. So, why am I even talking about decoupling? Well, I mean, it's been sort of the biggest problem in software since, when I say practically forever in sort of software terms, I looked this up on Wikipedia. The earliest reference that they have documented for the concept of spaghetti code is 1977. So if you count that in internet years, that's like, several hundred years. If you count that in TikTok years, that's several thousand years at this point. So this idea of coupling, again, from the earliest days of software, it's really always been an issue. Now, we've never really had sort of a good definition for it. It's one of those things that, as developers, we know it when we see it. That challenge of things that sort of stick together too much. You pull on one and you end up getting a whole bunch of others. The spaghetti metaphor is actually quite apt for anybody who's ate spaghetti. It's really hard. It takes a great deal of effort to extract just sort of one single strand of spaghetti and do something with it. And code is kind of like that as well. Now, from the code side, well, as an industry, we didn't just stop there and say, well, we're just going to have spaghetti code. We ended up creating spaghetti databases as well, right? So databases, relational databases, and subsequently to that, document databases and graph databases and all those things. Same kind of idea went along. It's like, well, we've got this entity and it's got one-to-many relationships with these other entities, and those entities have many-to-many relationships with 5 other different entities, and just sort of those strands of coupling and mesh all of the data in the database. And again, you try to change just one thing and you end up breaking all sorts of unrelated things. Databases are particularly pernicious as places of coupling because, unlike code, for the most part, with code you can step your way through it, right? It might be a mess, but you can set a breakpoint and say, all right, let's just follow this thread of spaghetti and see where that takes me. Databases, on the other hand, well, they're used by lots of code, right? Who's got a batch job in their system? Yes, batch jobs? Can I get a show of hands? Okay. Problem with batch jobs, it's some other code somewhere else. And our code over here that we're working on has no awareness of that other code over there. Now, on the one hand, you might say, well, that's good. It's technically decoupled from the batch job, right? Operative word being technically decoupled, because we find out that we change our code and we get all the unit tests to pass and we get all the integration tests to pass and get all the acceptance tests to pass, and we're thinking, okay, this is good, I got this, right? And I'm going to deploy it. And then I'm checking production, I'm checking the logs, and miracle happened, and just first try, it worked. And you're thinking to yourself, can't be this easy. And you wait, you sort of count the hours, and you're like, no, nothing's blowing up. And then at the end of the week, you get a call. Something blew up. What was it? Batch job, right? So that problem of a shared database and coupling coming in through the database is often one of the most difficult forms of coupling that we've got. Unfortunately, we keep doing more of it, right? Now, at some point in time, we kind of tried to say, all right, what if we tried to decouple there as well? And as an industry, we went to this concept of microservices. Who's heard of microservices before? Yes, okay, everybody. Who's doing microservices? Hands up, okay, still most of you. Who's happy with the microservices that they've got? Ooh, not nearly as many hands going up. It's kind of like well, with some of them, right? Some of them more so than others. So, I mean, when microservices came along, we had, the Netflix story and the Twitter story and the AWS story and everybody with all of these hundreds of microservices. And as an industry, we got a little bit of microservices envy, right? I want to have lots of microservices too. That's what's called resume-driven development, right? So, oh, you only have 20 microservices? We have 50 microservices. And someone says, 50? That's nothing. We've got 78 microservices. It kind of becomes a pissing competition. Who has the most microservices? But the interesting part, again, with microservices is back to that element of data. Because if all of these microservices are talking to a shared common database, then once again we have that same problem of coupling, where we make a change to one microservice, and then we end up breaking who knows how many other microservices. So that's where, when we started doing microservices, the idea was, well, in order to actually have this work, we need to have these microservices own some of their own data. Now, that can help, but also it can cause problems, and we're going to talk about a bunch of those problems. But before we do, I want to come back to this whole microservices versus monolith thing, because, well, modular monoliths are now back in fashion, so we need to talk a little bit about that. All right, so let's start with sort of original monolith, before modular monolith came a thing, and we had two pieces of code, components, let's call them. Component 1, component 2. Component 1 calls a method foo on component 2, passing in a bunch of parameters. All right, simple. Now we decide to microservicize our monolith. Microservicize is an actual verb now. And we've done this, where we have taken component number 2, and we are now deploying that into its own process. And instead of doing a regular in-process call between component 1 and component 2, now we're doing an HTTP call, but not just any HTTP call. It's all going through some kind of service mesh, gRPC, secured with all sorts of wonderful tokens, serialized with protobuf because that's the fastest, until somebody says, it's not the fastest. I know there are others, right? And we go through all of this and say, great, now we've got a microservice. But if we look at the logical coupling, sort of the nature of the two pieces of code, what's the difference? Like, we've added a lot of technology around the code that was there before. But logically, we're still doing an invocation. We're still passing the same number of parameters between these two pieces of code. We haven't really changed the nature of the coupling. And now, by the same token, if we're saying, well, we're not going to do microservices anymore, we're going to go back and do a modular monolith. So we're going to take all of that technology that we added over the past 5 years. Docker, don't need that. Kubernetes, don't need that. Serialization, don't need that. Put everything back in the same monolith, and we're in the same coupling story that we were before. So that's what we're going to be talking about here, is the how to deal with the logical coupling first. If you can't deal with the logical coupling, technology is not going to help you. If you can, then you might start getting some benefits from it. Now, other things that people have tried. They say, well, okay, yeah, we're doing an invocation, we're passing a lot of parameters. Every time we need to make a change to one of those parameters, well, it ends up breaking the API, breaking our consumers. So how about, instead of passing a whole lot of parameters around, we'll take those parameters and we'll put them in a database somewhere, and then we'll get an identifier back, and then we'll do the invocation with an ID, and then on the other side, they'll pull the information out based on that ID. please don't do this, just in case you were wondering. No, I'm not recommending doing this, right? That's just what I said before about having too much coupling going through the database. Of saying, oh, I've got this logical coupling, what can I do with it? It's not a let's sweep it under the rug. Now, of course, developers say, well, I'm not doing it via database. I've got a REST API, right? I've got an entity service, and I'm going to put things into the entity service from one place, and I'm going to read things from the entity service in another place, and you've still done the same thing, right? Wrapping up a database with some sort of CRUD entity service, you're still not actually changing the logical coupling that you got. So coupling is kind of like that mass energy thing in physics. You can transform it and you can move it around, but it's really hard to destroy it. It'll just change shape and go somewhere else. So the attempts to hide it usually make things worse. So if you're doing this, please, it's just not worth it. Go back to simple calls between things. Don't sweep the coupling under the rug. But again, for as long as we've been doing software, we've essentially been playing this game. And sometimes it feels like we're stuck in the spiral. This is a picture of a thing called an ant mill. An ant mill is what happens when ants sort of lose direction, and then they default into following the ant that's in front of them. Now, the thing is, when enough ants lose direction, they start following the one in front of them, and they just sort of walking around in a circle. I'm sorry, I'm going to not have this up. It's, a little disorienting. But that's kind of what we've been doing as an industry. It's kind of like, coupling was bad, we're going to do microservices. Microservices is bad, we're going back to monolith. And when that doesn't work, what then? I don't know, we'll have another name for microservices. We'll call them actors this time. Actors have been a thing for a while. Let's do distributed actors. How will actors look? They'll probably look either something like this or something like that. So the idea is to stop repeating the same patterns over and over again and try to find how can we handle the coupling better rather than sort of shuffling it around and always feeling that pain. So there is a better way. You've come to the right place, and luckily there's almost always a better way for anything. However, it requires a number of changes to be done. All right, so it's not just a little tweak to your architecture. There's actually 3 different parts that we're going to be talking through. The first one is event-driven architecture. All right, so that's number 3 on the list. There's talks about it at the conference. Event-driven architecture is it's also been around for a long time. It's been popular. It's gotten more popular over time as event sourcing became a thing and event storming. So now you kind of have event anything, and it's like, oh yes, absolutely, give me some of that. We want to eventicize all of the pieces of software. So coincidentally, that's not what we're going to be recommending. It's a event-driven architecture has a piece to play in this change that we're going to be doing to coupling. Number 2 is this thing called vertical slice architecture. If you haven't heard about it, we're going to be talking about it. Essentially, it's a different style than layered architecture. So layering is probably one of the better known approaches, where you've got layers that are request responsing with lower layers beneath them. Vertical slice architecture says, well, instead of slicing things up this way into layers, we're going to slice them up top to bottom into these vertical slices. So, and that's going to have a piece to play together with the event-driven architecture. And then we've got this one weird trick that I promised you. And that's going to help us get some true data encapsulation where we were missing it before, both in the vertical slice architecture and the event-driven architecture. So that's our plan for today. That's what we're going to do, starting with event-driven architecture. So what is event-driven architecture? Well, like before, we have our components, component 1, component 2. Now, the idea with event-driven architecture is when I've got those components, instead of doing the classical request response between them, where I've got the calling component, component 1, invoking some kind of method, getting some kind of response value from that. Now again, request response can be sort of synchronous HTTP request response. It can be full duplex request response over some sort of message broker. But the idea with event-driven architecture is that we do a publish-subscribe type of semantic where it's not in the same order exactly as request response. So the first part of publish subscribe is actually the subscribe. So in that way, publish subscribe is actually incorrectly named. It should have been called subscribe publish. Because if there is no subscriber there, if nobody has expressed any interest to the events that are being published, nothing is actually going to happen. So at some later point after the subscribe, the first component will then be publishing events saying, oh, foo happened, all right? So that's the important thing to realize about publish subscribe versus request response. A, it's subscribe publish, not publish subscribe. B, the roles are reversed between request response and publish subscribe. In request response, usually you have a client requesting from a server. When you're talking about publish subscribe, it's usually the server that is publishing. So where the events are coming from is usually from the thing in the back rather than the thing in the front. Now this becomes interesting when we put it into all sorts of workflow contexts. We're going to get to there in just a minute, so bear with me. Now, one thing I want to call out, it's important, is notice the past tense. It's foo happened. Something already occurred. It's not a request. It's not a command. It's not a do something. So past tense for your events. Now, I know somebody's saying, Udi, we know this stuff. I know. I got to lay the groundwork for anybody who hasn't done event-driven architecture, not familiar with these terms. We're going to get through them quickly and move on. So past tense, something that already happened, not something that we're requesting to happen. Now, unfortunately, because event-driven architecture has become really popular, people are now using it for request response as well. So they'll publish a save customer requested event, and they're subscribing to a customer saved event. You are doing request response by another name at that point. It's not really pub sub what you're doing. So one of the indications is save customer requested. Is that truly a past tense thing? Is it a thing that already happened? If the answer is no, it's not an event. You're not doing event-driven architecture. That's fine. You don't get brownie points for more events in your system. But there's this belief, unfortunately, I'm seeing more of it. It's event-driven architecture is more decoupled than the other forms of architecture. And then we essentially just sort of, force all of the code to become event-driven, even if it doesn't really want to. And then it actually makes the code a lot worse rather than better. It makes it more tightly coupled rather than less tightly coupled. So I've heard this occasionally, and I'm harping on the point because I've seen this happen. Developers do this. And then where does this blow up? It blows up actually in production at scale. So when you're doing an event-driven request response style, it looks fine on your dev box because you only have a front-end process and a back-end process running, and you're doing the pub sub between them. In test, usually also you have a small version of your production environment. You don't have a scaled-out web tier or something like that. And then you go into production, and now you have a scaled-out web tier, and you have one server that publishes save customer requested. But when that event comes back, another web server, because they're all listening to the customer saved topic, steals that event from the first web server because it didn't know that it wasn't supposed to listen for that specific event. And then users don't get their feedback, and developers are like, wow, that's weird. How did that happen? Check it on their machine. Everything works great. Why? Single publisher, single subscriber. Once you scale things out, then there are problems. That's when people start to say, oh, okay, there's this great feature that many of the pub subsystems have. You can subscribe based on a filter. So I'll subscribe not just to all of the customer-saved events, I'll subscribe to the customer-saved events by some identifier. But then what would that identifier be, because the customer hasn't been saved yet? So am I going to use the name of the customer, the phone number of the customer, their social security number? It becomes a tricky thing to solve. But for the most part, people are kind of like, in for a penny, in for a pound. They keep sort of trying to make this square peg fit into that round hole without stopping and saying, yeah, it shouldn't be this hard. Wasn't this hard with request response? So event-driven architecture is for past tense things, not for command imperative, do a thing now. So there's the back end side. I do want to mention they've got, the front end side has some uses for event-driven architecture as well. So React and all of those types of tools that have adopted a more event-driven style to decompose the front end, it's absolutely great, but we're not going to be talking very much about that now. It's more on the back end side of things. All right. So on the back end, what makes event-driven architecture useful, helpful, etc., is when we've got complex workflows. Right? So if it's just a simple take a command, persist something to a database, and tell the user success or failure, if it's a CRUD type of scenario, well, you don't need event-driven architecture. You don't really need any fancy patterns. But when the logic becomes more complex, that's where event-driven architecture starts to help. It's one piece of the puzzle. So let's take a familiar type of scenario. My guess is that you've all bought something online, and you have some understanding of kind of like the workflow that might go into that. Some of you might be actually working at e-commerce companies. That involves things like, well, we need to look up the items from the database and get their up-to-date prices and calculate the total, and then we need to check the checkout service and the customer information and what kind of discounts they need to get, and then the inventory levels of the items, and there's this whole big, long, workflowy thing that we need to go through in order to be able to say, all right, this now purchase has been completed successfully. Where do events help? Well, we can start to invert some of these interactions and break them up into pieces. Something like this, where the consumer is interacting with the website saying, I'd like to place the order, and then instead of this sales service, for lack of a better term, request responsing and orchestrating all of the downstream pieces, it does a subset of the workflow. It does, steps 1, 2, and 3, and then publishes an event saying, I've decided to accept the order. Now, deciding to accept the order turns into an event that it publishes that other downstream services are subscribed to. Now, in this case, we've decided to say, well, the billing process can be done asynchronously with respect to the first sales process. Now, this is a part technical decision, part business decision. For example, what would need to happen if the customer's credit card couldn't go through? Now, under the traditional type of orchestration style, something fails, essentially the whole workflow rolls back to the beginning. When we apply event-driven architecture, again, it involves both a technical decomposition and a business decomposition. The story goes, well, if their credit card was declined, don't just revert the order, ask them if they have a different credit card. What we found is a lot of times they do, and the purchases can still be successful. So essentially, we break down what would be an otherwise monolithic workflow, and we turn that into smaller modular sub-workflows, where each piece of it can succeed and fail independently of the others. That's not, again, not just a technical decision, there are business decisions there. Now, as this happens, the same thing on the shipping side. What happens if we don't have the items in inventory, right? Now, under the traditional workflow style, we would say, items aren't in inventory, we'll Roll back the whole thing, say it's an invalid order, and tell the user, oh, that item's not in inventory anymore. Quick question, those of you who've bought something on Amazon, have you ever gotten a message saying, oops, we're out of stock on that product? Anybody got that? Yes, out of stock? Yeah, some of you? What happened? Did you say, well, I'm not going to buy that item then? My guess is that most of you accepted the message from Amazon that said, but we'll have it in stock in another 2 weeks and then we'll ship it to you. So the majority of the cases, when we don't have the items in inventory, it's not a failure scenario, it just succeeds differently a little bit later. So when choosing to introduce events and to modularize your complex workflows, find those places where it maps to business independent success and failure conditions. Don't just throw events at everything. Find those places and then it will help. Now, shipping here needs to also wait to see, well, did they actually pay for their product? So we don't just say, oh, the order was accepted, let's go ship the products. We actually want to wait until billing does its process, publishes the order build event, and then we get both of the events, say, oh, okay, great. Now I know that I actually should be shipping the products to the customer. All right? So these are the core bits of event-driven architecture. One thing that I want to mention on the infrastructure side, because most of this stuff, technically not that challenging. When you're processing a given command, like the place order command, and persisting something to a database, and publishing an event afterwards, there are all sorts of ways where that thing can go wrong. So if there was a failure, if there was a deadlock in the database, if the web server crapped out, if there was any kind of retry that's in there, that can cause a situation where you get the right data in the database, but the wrong data in the event. Or the right data in the database and the event doesn't get published. So there are techniques to handle this stuff. I'm not going to go into them right now. There's this link, particular.net/the transactional session. Read up on that. It'll tell you all of the ways in which this event-driven architecture style can fail technologically, and then the ways to go about resolving that. Again, this is an infrastructure piece. It doesn't actually change the event-driven architecture piece that you're putting over the top. All right, I see everybody got a picture of that URL. Moving on. So that was number 3, event-driven architecture. Number 2, vertical slice architecture. So vertical slice architecture, some people know it by a different name. The term micro front ends has started to become more popular. We've also got the back end for front end pattern. A lot of those things are sort of describing the same idea from different angles. Now, what is it? Vertical slice architecture. As I mentioned before, we've got traditional layered architecture, which categorizes things into layers like user interface, API, business logic, data access logic. The idea with vertical slices is, as the name states, not layers, vertical slices. What that means is, inside each vertical slice, you will have some UI pieces, some API pieces, some business logic pieces, some data access pieces, and yes, even some database pieces. We'll talk about how those things pan out. So what's the idea over here? Well, there are a couple of elements. One of them at the database level. We talked about that before. We said, if we share things, if we have too much coupling at the database level, too many pieces of code that are talking to the same tables, that ends up breaking things. We want to stop doing that. So we need to decompose at the database level. And also we see that at the UI level, things can get quite monolithic. So if we're looking at a given UI, and apologize for keeping using the same Amazon case, I'll give you another one a little bit later. So we've got product details that have images of the book, names of the book, the rating of the book, the pricing of the book, the inventory of the book. And we see this in a lot of systems. There's often some central entity to the system, and over time the business keeps telling us, I need another attribute on that thing. I need another attribute on that thing. And that goes all the way from the UI. It's like, I want to see this attribute over here, that attribute over there, and then we have to go and add that attribute to the API, and add that attribute to our business entities, and add that attribute to our data access logic, and add it to the tables. So over the years, a lot of us have kind of come to this conclusion, say, you know, having to change code in 5 different places every time the business wants to add an attribute, something there seems at the very least inefficient. We should be able to do better. So one part of this is to say, well, does all of this data really need to sit together? Now, to answer that question, that's actually more of a business question than a technical question, just like the event-driven architecture story that I was talking about before. We could try to partition the data into different vertical slices, but that is predicated on the assumption that there is no business relationship between them. All right? Let me give you an example. So the connection between the name of the product and the price of the product. All right? If we put both of those things in the same table in the database, anytime I run a transaction on a record in a database, it locks the whole record. Right? I can't just lock a field, just lock the name column of that product table, but not lock the price column. That's the way that databases work. So you put this stuff together in a table. That means every record is all locked together as part of one transaction. But why would we need that? We'd only need that if there were multiple transactions working on the same product at the same time, where potentially they were touching different attributes. Now imagine we had a situation where a user is saying, well, I want to change the image of the book. We've got a better image for the blue book. We want to use it. And another user is saying, I want to update the price. And both of those users issue their commands, go to the database at the same time. The way that technically it would be built underneath a layered architecture is one of those transactions would succeed, first one wins, the second one would fail, right? Because, again, the record in the database was changed and we'd have optimistic concurrency checking and that kind of stuff. But if you ask a business stakeholder to say, would you want that to fail? They'd say, no, why? Like, what possible relationship is there between the name of a product and the price of the product? Now, we can try to come up with some requirements, if we'll call them that the business might want in the future. Like, well, wouldn't you potentially want to have a rule that states that if the name of the product has more than 30 characters, that the price must be at least $30? And the business kind of looks at you and says, you don't understand anything about business, do you? But technically, that's how we've built the system. We've built the system in such a way to support that kind of requirement. By putting the name and the price in the same table, giving consistent locking around all of that, we're saying we can support that requirement. And the business says, well, good for you, I'm never going to want that. But then they come to us with the requirements that they do want, and then what do we say? Oh, no, that's a hard one. I have to rewrite the system from scratch for that one. Right? So part of both doing event-driven architecture and vertical slice architecture, aligning the boundaries with the business. And for a bunch of things, when you look at them at a field-by-field basis and you talk to your domain experts, they'll say, I don't need transactions between those things. The price and the name and the image, independently volatile. Put those things in different places. I don't care. Like, what about the inventory? Like, what about the inventory? Obviously, the inventory should not be affected by the name of the book and vice versa. Like, what about inventory and price? They're like, ooh, that's a good question. Here's the thing. For this type of B2C e-commerce where we can always get more inventory of the stuff that we're selling, the fact that inventory has dropped to a low level is not going to be a reason for us to increase the price. So good question, but no, we're not going to need transactions that span inventory and pricing. And then that leads us to the conclusion, say, we can put all those things in different vertical slices. I can take the name of the product, the image of the product ID, that kind of stuff, put that in the yellow vertical slice. And then I can take the rating of the book, and I can put that in the blue vertical slice. And then I can take the pricing of the book, and I can put that in the green vertical slice, and I can take the inventory levels and put that in the brown vertical slice. So long as they're all indexed by the same product ID, and I can sort of compose together a UI that has all of this stuff together, then my decoupling works. Again, this is not just at the level of the UI as a kind of micro front end, as it were. It's also at the back end, the microservice back end and the micro front end. And I'd have a micro database thing at the back as well. Because again, there's no reason for me to have a single big database that has all of the data inside it. Now, this is for showing a single type of item page. If you need to show a grid of information, so lists that have data that are coming from multiple different vertical slices, it can be more technically involved. Luckily, now again, that's a whole other presentation. That presentation is online. You can find that, and it goes through and shows how to actually build out all the technical bits in order to support single item composition and multi-item grid type of composition. So designing a UI for microservices, that's the link over there. Again, those are the ideas, the technique, the technology, whole presentation. It's all available online. Has everybody taken a picture? Yes? No? Come back to me later if you need the links. So, we're getting close. We're getting real close. Where we've got services, microservices, whatever you want to call them, modular, micro, macro services, where they've got some micro front-endy bits that might be running in the browser. We might also do that on the web server, so there are multiple styles we can do micro front ends using React, using Angular, Vue, etc., or we can do them server-side using regular ASP.NET on the back end as well. But the tricky part is at the database level. Services seem like we're so close that they could fully encapsulate their own data. The only problem is those pesky workflows that we were talking about before. So that's just that one problem that we've got left, and that's going to lead us to our one weird trick, okay? So we've got these services, vertical slices, top to bottom, micro front ends, micro back ends, micro databases. We're using an event-driven architecture for them to interact with each other. We've chopped up our big complex workflows into these subparts, each of them well encapsulated. But now the question is, how much data ends up being passed around between these events? Because that's where we started with the problem, right? When we were talking about coupling at the beginning of this presentation, that foo method that had all of those attributes, A, B, C, D, that was the logical coupling that we were concerned about. So we need to find some way to handle that. Now the question is, well, how much data is there? Well, let's look at this checkout workflow and get a sense of what that's like. So in Amazon, you have to select a shipping address. So shipping address data, we've got, name, address, phone number. The address itself is, a value object that has city, street, house number, and in different places, it's actually more complex than that. Then we've got billing information, right? The credit cards that the person might have on file, all sorts of other ways that they can pay for it. Then we've got things like, well, what's the estimated delivery date, and what delivery options do you want for that type of thing? And then ultimately we summarize all of that to the user and say, okay, great. That's your summary, that's how much it's going to cost. Got a fair bit of data here, right? Now, where and when does this data end up going via events? Well, when the user clicks place your order, essentially, we need to collect up all of that data, right? So the shipping address, the billing address, the credit card information, the delivery option. It's a big payload of data. And essentially, we need to put all of that into that order accepted event that we were talking about right over here, right? So when we say place order includes these 25 different parameters in it. And then when sales publishes the event, order accepted, that includes the same 25 parameters in it. Primarily because, well, billing needs the information about how much does this thing cost and what are the credit card details and all of that. So it extracts those pieces of information, does the billing, publishes its event. Shipping as well needs to know, what the shipping details were, what's the shipping address, what's the delivery options that were selected. So while we've gone some ways along in the fact that things are more asynchronous, slightly better encapsulated, we still have lots of data in the events, sometimes known as FAT events. Now, I'm not going to go fat shaming or anything, but it's that same problem of coupling that we mentioned before. The more data you're sharing, the more logical coupling you have. The more logical coupling you have, the more difficult it's going to be to handle changes when the business says, hey, we want to do a new thing now. It's called ebooks. You might have heard of them. So I want to sell ebooks on the website. You're like, okay, cool. What's the shipping address for an ebook? The answer is, good question. How exactly, technically, do we ship ebooks? But it's probably not to a person's physical address anymore, right? So when the business says, I want to sell and ship ebooks, then now we need to make a change to the sales code that is collecting up the data it needs to be aware. There are different types of products. Some of them are shipped physically, some of them are shipped digitally. The ones that are shipped physically need a shipping address that is a physical shipping address. The ones that are digital need a digital Kindle ID, whatever thing, for shipping the thing to the person's Kindle device, or it could be to their email address or what have you. So that's our problem, as we mentioned before. The business wants to do changes, and once again, we need to change things in multiple places, potentially breaking things that we didn't want to break. So that's our problem. Again, we've done event-driven architecture originally. We've added vertical slices. We've decomposed things. We've gotten them small, but we still have a bunch of data that is flowing between our services via events, and that coupling is what hurts us. So how do we solve that? Well, time for that one weird trick. It's so small and trivial. You're just going to be saying, is that it? I can't believe that nobody told me this thing before. It's so easy. And you guys are sitting there saying, just shut up and tell us, right? So one weird trick is generate the IDs up front at the beginning of the workflow, at step -1 of the workflow. So when the user is going to check out, they click a button that says, proceed to check out. Instead of waiting until the end, where the user has completed their checkout process, okay? So they've gone through everything, they've completed the checkout process. We're now in sales, we persist the order into the database with all of its data, and then the database gives us an identifier, say, yes, now I have an order ID. Persisting the identifier at the end of your workflow is what's causing the problem. If you were to generate the ID up front, you can do this by generating a GUID, universally unique ID. You can do that on the browser, you can do that on the web server, but the more important thing is that you do that right at the beginning of the workflow. Why? Here's how everything kind of twists once you've got an ID. So we mentioned before, vertical slices. We've got this type of composite workflow where each service could have its own micro front end. So shipping is responsible for the bit of what shipping addresses do we have on file? When the user says, I want to ship to this address, they click a button in there. It's not the sales service that holds on to that. The shipping service says, oh, that's the shipping address that you want for this order ID, the order ID that we have in session state from before. I can hold that inside my service indexed by that order ID. When we get to the next step of the workflow and we need to choose the payment information, again, instead of sales collecting that information up into sort of one big batch, the billing service with its micro front end says, I'm going to take that. It's my data. I'm the one that has to use it later on. I'm the one that's going to have to validate it. I'm going to be the one that needs to charge the credit card. So because I've got the order ID already there in session, I can hold on to my data indexed by that order ID already at that point in time. And the same thing with the shipping details bit, the delivery options later on. Essentially, all of the pieces, by having the micro front end and that micro back end and the ID, each of them can collect and store up their own data, such that when the order is placed, so the user clicks that button and says, I'd like to place my order, place order just needs to pass along that order ID. Order accepted as an event only needs to pass along that ID. Because when billing gets the order accepted event with the ID, it can look up all of the previous information that it stored indexed by that very same order ID. And same thing with shipping. When shipping gets its event, says, oh, I need to ship, I need to know what the shipping address is, I need to know what the delivery options are. Again, it has previously persisted that information based on that same order ID. It can look it up. And now the order accepted event, the order billed event, just need to have IDs. So we've done kind of that thing that I told you at the beginning that we shouldn't do, right? Where I said, instead of passing all of the data via the invocation, put it in a database. But what we did here is it wasn't a shared database, right? That's the thing that we changed. By having each service as its own vertical slice, each of them with their own database, by generating the ID up front, now each of them can collect that up, store their data, look it up afterwards, and when the business says, hey, I want to do ebooks, in order to do ebooks, saying, oh, I need to change the shipping code. The code that says I need to ask for a shipping address, it's the same code that says I know I don't need to ask for a shipping address because this is an ebook. I know I don't need to ask you for delivery options because this is an ebook. All of that behavior remains fully encapsulated inside the shipping service. So it changes its bits of micro front end and logic on the back end, but most importantly, sales didn't need to change anything. Sales remains totally ignorant of the fact we're selling ebooks, we're selling regular books. I don't care. An item is an item. It has a price. We do what we need to do. So, one more example. Similar but different. Booking a hotel room. My guess is you've all been through a process like this, whether it's on booking.com, Marriott, whatever website of type of thing of the hotel that you've got. The process usually goes something like this. A person searches for availability. They put in the dates of their stay, their trip, click search, or view rates in this case, and the system comes and shows them, oh, these are the types of rooms that are available for you during those dates. Here is their information. Here are their prices. Again, this is a type of grid, as it were, right? You've got a list of items and information that technically we'd say, well, the price of the product and the image of the product, the name of the product, those should probably come from different services. So how to generate this grid, already gave you the reference for that. But there's an extra interesting piece that we're going to get to. But as a part of your checkout/make a booking process, then you need to go to the next step. You need to fill in your guest information. You need to fill in your credit card information, where again, intuitively, we'd say guest information should probably be in its own service, separate from the credit card information, a lot of times because we've got business travelers, right? Business travelers, you know, they're staying at the hotel, but the company is paying for their stay. And also all of that information is logically decoupled from the information about the types of the room and their prices and their availability. So, again, if we were to do a traditional style of making a booking, a traditional style of workflow, where as a part of this process, the user is filling in information and nexting, and we're building up a big, gigantic booking object, which then we're going to be sending to a back end. Anytime there's going to be a change, well, that event will end up having to change as well, and we end up getting a lot of data in it. Big events also make the broker slow, so it hurts our performance. Now, once again, that trick, generate the ID up front. Now, when I say generate the ID up front, the reason that I use this example is sometimes people are like, it can't be that up front. Like, the person comes to the website, and the very first click was saying, these are my dates, search. As developers, we view that and say, but that's just a search. A search shouldn't really be a beginning of a workflow. Like maybe on the next screen when they're actually making the booking, but at the time that they're actually doing the search, why then? Well, I'm going to get back to that, but I want to plant that idea in your mind. Say, how upfront could upfront be? So the next bits of the make a booking, yeah, those are the easy parts. Say, all right, we're going to have a guest microservice where it has a guest micro front end that is collecting up its data, and then we'll have the payment vertical slice with the payment micro front end and the payment back end. Note that in this case we have a single book now button at the end. This is a kind of different composite. This is a composite form, all right? Essentially, it's two forms pretending to be one. So each bit of those microservices, each one of those micro front ends is a kind of micro form unto itself. When you click the Book Now button, essentially each one of them gets an independent callback. So the yellow vertical slice says, oh, you want to book now? Great. I'll go persist the guest information. The blue microservice says, oh, you want to book now? Okay, great. I'll go persist the payment information. So we can do that decomposition on form submission as well and have a nice clear separation over there. So each of them can collect their own data, which is good. That's what we were talking about before. But why did we need to generate the ID already at the time of the search? Well, there's this other business requirement that oftentimes you won't hear about until much later in a system. The prices. The prices that are shown when you do a search have to be respected when the person actually makes their booking and also checks in and checks out of the hotel weeks and months later. Now, clearly, the price of those rooms are going to change like 1,000 times from when you make the booking till when you actually show up, till when you actually check out. But you'd be pretty upset if at the time that you're making a booking, they're saying, oh, it's $100 a night. And you're like, oh, great, I'll book that. And then when it comes time to check in, they're like, just a friendly reminder, it now costs $400 a night. And you're like, wait, what? They're like, well, yeah, the price changed. You're like, I don't think you can do that. So, well, the price in our database has changed, right? Saying, well, no, there's actually legal requirements that state, when you're showing a price, it actually needs to be respected over the long term. So essentially what we need to do, we need to snapshot the prices as well. Once we show the price to the user, that is now what's known as advertising. Advertising means you can't do false advertising. You cannot present one price and then charge a different price later on. So when they're doing the view rates, that's the time when you're going to the database to get the prices. By having their booking ID already at the time that they clicked view rates, you can then snapshot the prices, connecting them to that booking ID, so that when they make their booking, when they check in, when they check out, you have the correct price that was shown to them at that time. Again, if you don't do this, your company may get sued for false advertising. That's not a nice thing to have happen to you, all right? Now, I know with all of these things, you're sitting there, you're like, yes, that makes sense, but I have questions. So many questions. It's like, yes, you have solved all of the problems that you have said that you've solved, but like, how do we search across all of this data? It's like, okay, you've put the prices over here and the room types over there and the guest information over here and that thing over there. It's all nicely decoupled. You're not sharing it via events. Neat, groovy, but users want to search, and they want to be able to search across this thing and that thing and that thing and that thing. We see that also in like Amazon. I want to search based on price. I want to search based on the color of the item. I want to search based on the brand of the item, right? I want to buy a new phone. Am I looking for an Apple iPhone? Or am I looking for a Samsung Galaxy? Am I looking for sub $1,000 or sub $2,000? Am I looking for gray? Am I looking for black? We need to support search across all of these services. Great question. I don't have the time to get into it right now. There's another one who's saying, what about calculations? Again, we might need to do calculations across all of these services. How do we do that? Again, I apologize for all of the moving graphics. There is a way of doing that, but it also is a slightly different, more advanced technique. I got you covered for that as well. There's this other talk that I've given a number of years ago at this very same NDC, talking about rules engines. So the engine pattern is actually a fairly old pattern in software. You might remember back in the day, those things were called search engines, right? We didn't call them search services or search AIs, right? They were called search engines. The reason that the term engine was used is because it was a software pattern. So engines are a way to compose multiple microservices, vertical slices, into a given search process to give those types of results cross services. Same things with things like pricing or discounts. Before we got all services crazy as an industry, we used to call those things, we have a pricing engine, right? So engines were used in a bunch of different ways. Fraud as well. We'd have a fraud engine for solving these things. So there's this engine pattern. I've given a talk about it. That link is available online. Hopefully you'll be able to find more information about that. Again, I know you got questions. There's lots of information. But if you can take one thing away from this course, it's that one weird trick. Generate those IDs up front. Once you generate the ID up front, it enables you to do that vertical slice architecture and event-driven architecture that extra little bit better. Your data ends up being that extra bit encapsulated. Your events end up being that much slimmer. The performance of your message broker, everything gets so much faster as a result of that. Now, if you have more questions, come see me at the booth. I'll be heading over there in just 2 minutes. Or for those of you that want sort of the full comprehensive A through Z with all of the questions and answers, I cover this stuff as a part of my 5-day course. That's at the link over there, particular.net/ADSD. The next one is in London in September. Hope to see some of you there. It isn't sold out yet. Thank you all for being such a wonderful audience. I hope you've enjoyed our time together. And I'll see you at the booth in just a few minutes. Thank you.
Hello, everybody. Hey there, good afternoon. Thank you for coming today. I know the screens outside, it might have got a little confusing. It's talking about all kinds of other people's talks, but if you're here to talk about extreme scale and Azure functions, you're in the right place. Trust the website, I guess we could say. So anyway, my name is Paul Yuknovich. I'm the head product person for Azure Functions and Serverless. My team designs and operates some services at Microsoft, Azure Functions being the main one. And we support the overall serverless efforts like container apps, Legion, and some of the other services that are underneath. What I want to do today, I want to do something a little bit different. And thank you for coming to hear about with me. I want to double click and really go under the hood of Azure Functions and talk about how we built it and talk about how we made it scale. And when I talk about scale, I'm talking about things like bursting of instances, let's say 1,000 plus instances in under a minute, or being able to handle over 1 million messages or requests per second. That's the kind of scale I'm talking about. So today, we're going to go through a number of things and hopefully give you a good idea of how it works. You'll hear some of my opinions. Why did we do it this way? Why are we thinking about this way? And after this session, I'd love to get your opinions too. And I also hope to share some tips and tricks that we've learned the hard way along the road, and maybe you can apply that to your own apps in your own services as well. Does that sound like a good plan? All right. So this is about the only overview slide I had. Azure Functions was designed from the ground up to be all about event-driven apps, event-driven architectures, event-driven scale. You can see a number of scenarios I have up on the slide. I think serverless and functions probably started as being a handler for when blobs are uploaded, run a little bit of code. If I think way back to when I first saw AWS Lambda, and I wasn't working on serverless at the time, I admired how now you can not only upload data into your buckets, but you could also run a bit of code and do some processing. I think that's where it started. What it's evolved into is what you see here. So you're doing real-time data processing. You're having event streams coming in, fire hosing you with information, and you have the chance to ingest that data, analyze it, transform it, do all the things you need to do. And a lot of times, something like a function is maybe a companion to the rest of your application. So I've seen it before. I don't see too many applications that are, let's say, 100% functions, but I see an awful lot of applications that have functions that help get data in, transform, and send data out. It's also really handy for simple APIs, like if you want to have some back-end processing, even some heavy lifting, some computation. Doing that with functions can be simpler than making full-blown API apps. And now, you've probably heard a little bit about AI from us at Microsoft and from the whole community. Maybe you're working on it too. But we're seeing functions are really interesting to handle the different workflows and orchestrations you do in AI pipelines. So like I said, functions has always had a superpower for taking data in. And when you work on an AI app, let's say with RAG, the very first step you do is you take a bunch of data in and you embed it. And so functions become really handy for that use case. And also, if you look on the top right, we have the ability to do actual proper workflows and orchestrations. If you kind of take a step back, most any enterprise process where first you do this, then you do that, maybe you do a few things after that, and you need it to be durable and reliable, those end up looking like a workflow. And for those of you who've tried to build one of those yourself, you can do it, but it's a bit tricky to keep it reliable, right? You have to do queuing and outbox patterns and journaling and event sourcing and all kinds of patterns to make that happen. And the cool thing is with something like durable functions or also Dapper workflow, we actually have the technology where you write the kind of code you want to write and you get that kind of orchestration and journaling built in. And you even get sagas and compensation logic just by doing try-catch style code and doing your compensation logic in the catch. So anyway, here's a bunch of scenarios that I think about for functions. And the bottom line is we've learned over the last several years from you, we had to scale a lot better. And I'm really excited. We've been working on Azure Functions Flex Consumption Plan. Folks heard about Flex Consumption? in the room? Well, I'm going to talk a lot about it, but that's a completely rebooted plan, completely rebooted architecture where we rewrote functions to hit the next 10 levels of scale above what we've been doing. So now you can get to that like bursts of thousands of instances in under a minute. So that's the overview. A few things. This is the structure of how I'm going to approach things today. I'm going to do kind of things a little bit in the opposite order. I'm going to show you some resources so that if you want to try the CLI commands, look at the code yourself while you're sitting here, that's cool. And you'll have it. And then I'm going to do a demo, and then I'm going to do a bunch of kind of going back and forth between architecture. Here's some architectural decisions we made, and then when I can, I'll try to illustrate it with a demo or something tangible. And then we'll do some tips and tricks. Okay, so getting right into it. Hopefully this is the only thing you'd have to screenshot, because I'll share things afterwards. If you go here, everything about what I'm going to show you, notes, CLI commands, it's all up there. And if I forget something, you tell me, and I pop it into the gist, and it just goes there. So hopefully that helps. All right, so let's talk about testing at scale. And the way I think about this is we need to be able to scale in all the way to 0, where you're in a serverless billing model. You're not paying anything if there's no executions. But we need to scale out. I exaggerate. I say to infinity. But you want that near infinity feeling where as much as you want to scale, as much as you're willing to pay, you're going to get that horsepower from the cloud. And then it needs to be elastic. So you need to be able to scale huge, scale back in, scale out, scale in, over and over and over again. And that gives you the good economics of using serverless. OK, so a little bit of setup for this. The way I've thought about scale, first, it's always I have this motto with the team, measure, measure, measure. And so the things I want to measure for scale, the number one thing I always measure is throughput. So it's like how many requests or how many messages per second can my app handle? And I think about that from the external clients. The clients are pumping messages in. The clients are pumping in HTTP calls. And how much can I process per unit time? That's the most critical. And I want to, at a very bare minimum, I want to be able to handle tens of thousands of requests per second. But with a lot of scale out, I'd actually like to be able to handle millions. And so that's the benchmark that we thought about. For latencies, cold start has been one of the things Azure Functions has had some challenges with, honestly. And we've worked a lot on that. So we want to measure those latencies also. And being a little bit scientific about it, we want to look at a median or a 50th percentile latency. We also want to look at the 99th percentile and just see how we're doing for our end users. We want to keep those error rates down. Obviously, that hurts resiliency, and it also affects your performance. I'm going to keep an eye on the CPU and memory. The reason why I do that is while I'm running at this throughput, I want to see if any part of my hardware stack is going hot. I want to see if my CPU is maxing out. I want to see if my memory is maxing out, because any one of these ceilings could be the reason why your app won't scale. And I'm going to go into it a lot, but kind of a rule of thumb is how do you get to about 70% utilization of your hardware? 70% CPU, 70% memory in a steady state, so that you've got a little bit of room left. Your users are getting a good experience, but you're also getting the value out of what you're paying for, right? So you want that high throughput with high utilization, and you're going to balance the two. Another thing that's super important, and whenever we partner with customers who are working through scale, it's important to look at the queue depth. So if your app is based on queues, if it's based on messages, I like to look at how many messages are piling up in the queue, going unprocessed. And that's also a very good observable metric to know if you're scaling properly, right? Because if you're not processing your work, that means your users are getting a bad experience, or maybe you've even just configured the functions in a non-desirable way. So even though you're giving lots of instances, lots of power, still you're not actually processing and getting the results. So it's kind of like almost an output metric is how low can you keep that queue depth while you're keeping the throughput extremely high. Make sense so far? So far, so good? Does this kind of resonate? Maybe those are things you look at? OK. All right, so now getting more tangible. Here are the exact goals that my team set. With the new plan, which by the way is public, it's in public beta right now. So the flex consumption plan, we set out to do 1,000 RPS as just table stakes, a absolute baseline, 1,000 requests per second. But we want to be able to do millions of requests per second through scale out, through heavy load. So that's the goal. And we literally, we actually run over 80,000 tests a day on all aspects and all SKUs, testing the heck out of functions and also watching its trends so that we know every day how close are we getting to these goals for you. So that we make a huge investment. It's a really big deal. The next thing is we want to look at bursting. If you look at Elastic Premium, which is kind of the most expensive plan, the best plan we've offered to date, it can take, I mean, if you want 100 instances, it can take many minutes. It can take a half hour. And we don't want that anymore. So we wanted to be able to scale to 1,000 instances in under a minute. That's the benchmark that we want to do. And we want to do even hundreds of instances in a few seconds. And then, you know, think about the message types. We have both HTTP and non-HTTP message types, and they have very different kinds of scale requirements. You know, like think about HTTP comes in through a load balancer, messages are in the background, so we need to be able to handle both kinds of cases. And we don't want to just do hello world, we want to do a real beefy kind of application. And we need to be able to do it on a private network. So this new plan, Flex Consumption, actually works on VNet with private endpoints. So it's got the complete access to the private network. You can do things securely if you're in an enterprise. And I'm going to talk about concurrency in a bit, but concurrency is one of the other magic dials we have to further optimize, are you getting the most right-sizing your instances. Okay, so that's the goals. Now let's talk about an actual test that we're going to do right now. So what I'm going to do, I've got an end-to-end, it's simple, but it's a real end-to-end application that's going to process telemetry. So I have a big application, let's say a big distributed web application. It's creating all kinds of telemetry as users interact with it. And it's going to send the telemetry as HTTP posts with JSON, having a payload of, you know, here's the user, anonymized, here is any you know, click metrics they have, here's any feedback they have, here's their experience, and we send it through the system. Now what the HTTP function is going to do, it's going to transform and convert those into Event Hub stream messages. And then I have a number of downstream analytics and persistence mechanisms that'll basically let me store and work with the telemetry after it's done. So it's kind of like data ingestion with analytics. That's what this function's doing. And for a load test, I'm going to use the new Azure load test, which is a kind of a reboot of what we used to have with Azure DevOps. But now there's a new Azure native one. And that one we're going to set up to do 1,000 plus RPS with 4 agents, 250 users each. We're going to do HTTP posts. I'm using Flex Consumption. Flex Consumption is inherently Linux. I'm going to use the default SKU, which is 2 gigabytes. I just happen to use .NET 8. We support all the languages that function supports, so don't stress that I did .NET 8, but I wanted to show you that one. And as I show, like mechanically, this is an HTTP trigger in, and it's Event Hub bindings out. So it's an example of using multiple of the triggers and bindings together, which is oftentimes what we see in functions. All right? And like I said, I'm going to use the metrics that I'm looking before. I want to look at that throughput. I want to look at the CPU. I'm going to look at the scale logs and all kinds of stuff at the same time. All right, so that's the approach. Enough PowerPoint. Let's go to a demo. So I've got this application. Let's make it a little bigger. So I have this end-to-end application that I described. It's up on GitHub now. So we call this one HTTP VNet Event Hub. So again, it's HTTPN, Event Hub's out, everything on a VNet. And the core function code here, if I go down to the source, I have this process customer feedback, and it's incredibly simple. But again, I'm seeing that I've got an HTTP trigger in. I'm going to process the data. I could do any more transforms I want. And then I'm going to use the tuple syntax in C# so that I'm both going to send a proper HTTP response code, like a 200, and I'm also going to send an event. So you can actually have multiple output bindings in functions. I'm going to send multiple outputs. And on the output, as you can see here, I'm simply sending to an Event Hub topic subscription. And so any subscribers, like databases, other analytic streams, can now listen to this telemetry stream spigot as it comes through. So it's a pretty simple function. And the payload, here's what it looks like. So for my load test, I'm going to have feedback that kind of looks like this. So we have both telemetry and feedback. Users can submit feedback. Telemetry is collected by the system. And this is a sampling of what that feedback will look like before we process it. All right, now I'm going to go over the portal. And I've got all kinds of resource groups today to try to pull things out of the oven for you. Let's focus on this one first. This is the deployed app. And all the things you can kind of expect are here. I've got my function itself. I've got my Event Hubs namespace. My Event Hub is in there. I've got all the monitoring, and I've got even private networking. So we're seeing where this is all behind a VNet. And I've got a load test. Let's go up to the load test. Bear with me at this resolution. It's a little tricky. OK, in this one, it looks like I don't have it, but that's no problem. So we made it easy in functions. If I click on this Better Together tab, forgive us for the name. We're working on it. But if you want to attach this I joke because the team was supposed to be like, yeah, like let's put some services together that are better together. That's the strategy. But then all of a sudden it showed up in the UI. Anyway, life's a journey. So let's create a load test, which is better together, and we are going to create the test. This is actually pretty cool. Like it already has the context of my function that I want to load test. So when I go to add a request, all I have to do is like give this thing a name. So let's call it process feedback. And I pick the actual function that's deployed, process customer feedback. And you can see it's already figured out the route. And it knows that it's a post. And then I can go to the body, and I can push the payload that I want to. Let's just use this sample that I already had. All right, so I have an array of JSON objects that'll get pushed in. And that's my load test. Let's do, I mentioned I wanted to get over 1,000 RPS. I know just by kind of reading the docs that if I have 4 instances with 250 users per, I'm going to get at least 1,000. I'll probably actually get more. And so that'll be a pretty sweet load test. And also, you can do these different, do you want linear? Do you want steps? Let's just do linear. So that's just going to mean over a function of seconds, over 5 minutes, it's going to do a ramp up. And actually, that's 20 minutes, which my boss might not love the cost that comes from that. So let's dial it to 5. He won't mind. All right, let's go and we'll do a create. So that's going to create the load test. And I'll probably have to find some other things to talk about while I do that, because this takes about 2 minutes. So let's look at our clock. 3:19. All right, while we're doing that, let's get set up on the other side. So let's look at how do we monitor this thing. I've got way too many resource groups. So this is the resource group we were looking at, right? This Flex Event Hubs Oslo. Flex Event Hubs Oslo. And let's go to App Insights. App Insights, just so you know, this is the monitoring product that I would say like is really built in and just super well integrated with functions. You know, if you ever want to look at telemetry, you either want to look at logs, distributed traces, they're all in here. And this is kind of a cool thing. You probably know this, but not only can I do things like see actual transactions that have happened in the last few minutes or the last few hours, I get visuals over the topology. I guess I need to send some traffic to it. And I get some live metrics. So as soon as I start producing traffic, I'm going to see them here. And that's part of my setup. So I don't see any yet, but that's expected. It's still provisioning my load test. The load test, actually, I could talk about this for a second. So I actually worked on starting the load test service too. And it's built on top of a Kubernetes cluster. And the Kubernetes cluster is actually serving up JMeter. You folks use or know JMeter? So we wanted this load test to be a lot more flexible. And it just looked like the community had bet pretty big on JMeter throughout the years. There's other really good ones too, like there's K6 and other up-and-comers. But we went with what most of the community understood, and that's JMeter. So when I run this load test, and I even set it up, remember it said, here's your function, here's the post, here's the payload. What that actually did is it outputted a JMX file. It created a JMeter script, and that's fully customizable. So if you have your own JMeter that's done more of a capture of live traffic, or if you know how to customize JMeter, you can plug it in here too. In this engine, what it's responsible for is like creating a fan out, a huge scale of that load with a bunch of regional instances pounding that endpoint. And then it does the monitoring, of course. So that's a little bit about the load test. Let's see how we're doing here. We're not quite there. All right, so well, I'll fill a little bit more time. I mentioned some of those metrics. So the request per second, the big one I'm going to be looking at here is the request rate. And we're also going to keep an eye on the servers. Now, this is a really fun one. Oh, here we go. Watch this. Looks like it's going. So we're ramping up right now. So pay attention here and also watch the servers. As it needs more servers, it's going to really quickly burst them. Look at that. It just went from 3 to 30 in just a few seconds. And now we're reaching a steady state of 2,000 requests per second. So this is pretty awesome. Like this is, we totally couldn't do this before. Like consumption functions couldn't give you this many servers, and it couldn't give you this fast. And again, even Elastic Premium really struggled. Like you'd be getting, maybe 10 instances per minute, but now we can do 1,000. So you're kind of seeing this live. Some other things I'm going to be looking at, if I scroll down here, I want to make sure that not only am I ingesting those messages, but also I'm making a good use of my hardware and things are healthy. So I see that my exception rate is 0, which is good. So I'm not getting user exceptions, I'm not getting functional exceptions, and I'm not getting scaling exceptions. Like I'm not seeing rate limiting. You want to watch that one and make sure you're not getting rate limited. All right, and then here I'm looking at my memory and my CPU percentage, and notice how it started with a lower number of servers, and the utilization was about 50%. Then as it added close to 89 servers, the CPU went down, let's call that, what do you think, 25? It's in the 25% median. I'd say that's okay. So like we accomplished one goal. Like we scaled incredibly well, no problem. But the thing I'm going to ding us on right now is we're not being very efficient. We're only using 25% of the hardware we're already paying for. And I want to be as efficient as possible. I want you guys to save money and only pay for what you need. And that's going to be the magic of this thing. So the way we're going to address this is through concurrency, and that's the very next topic. But I just kind of want to place a mental note. Like, we accomplished one goal, but we didn't accomplish every goal. But pretty cool. That's flex consumption. Like that? Okay, so definitely for I would say, in general, when you want to do event-driven on Azure, start with flex consumption functions. Like I said, it's in beta now. It's going to go GA before the end of this calendar year. And it's just built from the ground up for this scenario. All right, so let's go back to slides. And all right, so what we just did, that's not the right slides. I'm sorry. I've got even better, more special slides for you. There we go. All right, so we did the load test. What I'm going to show you here, this is a real example of a customer that we've been working with since the beginning of this calendar year. So like early, about January, February in 2024, we've been working with a little website you might have heard of called GitHub. And GitHub they did this exact scenario that I just showed you. They're doing telemetry ingestion for all the GitHub sub-apps that live on it, right? So let's say you're working with GitHub Actions. Let's say you're working with the source code control. You can think of all the different apps and stuff they have. That creates a whole bunch of telemetry. And what they found is that their message and queue ages got way too high. They just couldn't keep up with it. But they were hopeful to do this using something like functions that's serverless. And they didn't want to stand up Kubernetes clusters that they really had to do a lot of operations just for telemetry, right? Because what they want to do is they want to run GitHub. GitHub is their main business. They don't want to run telemetry. Telemetry is just a necessary evil to operate a service, right? So they kind of took a bet early as we were new software. As you can see here, they were able to achieve 1.6 million requests per second as a steady state. They're actually doing even a little bit higher now, so it's cool. They're a great design partner, because as we find issues, we're finding them early with GitHub, and we're able to get more scale and more efficiency. Another thing about this graph that's pretty fun is when you see that the scale kicks in, look at, the y-axis is basically showing you the message depth, how many messages you have. It's just boom. It's like plowing through that queue and keeping them at a low queue age, queue depth as a steady state. So that's, as you even measure your own performance, this is the kind of graph that you'll want to see. You want to see that you can quickly take care of any backlog and then go steady as messages are coming in, you're knocking them down. All right, so let's talk about the architecture. My team might get a little mad at me for this. I'm going to show a bunch of internal stuff to you, but I think it's important. Maybe it'll increase your confidence in the service, because I want you to know how this works. And you can kind of understand some of the things we went through, and maybe that'll help you as you build these apps as well. Okay, so let's go through the architecture. It's a bit of what we call an eye chart. There's a lot of stuff going on. But on the left-hand side, what we're seeing is our Antares infrastructure. Antares is our code name for anything that has to do with app services or anything that has to do with functions over the years. This is the compute infrastructure that runs app service and that runs functions. Literally gives you the instances, literally gives you the VMs and stuff like that. And also, each colored box represents a role or a microservice inside of the stamps that actually make this thing run. So it's interesting. We talk about microservices. Functions is an alternative to microservices that makes your life a little bit easy, but it's actually built on top of microservices. So we actually use that pattern ourselves, and that's how we achieve some of the horizontal scale internally as different parts of the system go hot. All right, so focusing on the left side, this is effectively the set of controllers, the set of bossy microservices that manage the rest of the fleet. And as I get to the right-hand side is where your workers, worker in my vocabulary, all that means is your application, your zip file that only you could write, those run as workers. Everything else is the host. So the function service is the host, your code runs in workers. So on the left side, we'll focus on the host. We have this microservice that we call the front end. In the front end, as you would expect, that's the front door for your end users. When they make HTTP requests, everything comes through that front door, right? When you saw that, even the web browser, let me come out of here for just a second, just to kind of visualize it a little bit. If I peek at my function itself, let's go down here. An HTTP function comes through a URL, right? In this domain, this azurewebsites.net, everything goes through azurewebsites.net. That's our front door. So it's all going through our load balancer. And the good thing about that, kind of like any proxy, since everything goes through that proxy, we have a lot more data about what your end users are doing. We can monitor it. We can understand how much scale needs to go through it. And we can do a lot of placement, right? As traffic comes in, we can route it. We can place it based on the load and based on a number of things. So I'll come back here. I'm going to keep doing this. Hopefully it doesn't irritate you, but I'm going to try to show you visuals as I talk through the architecture. And sorry, my hotkey didn't work. OK, so that's the front end. So the front end, it load balances the traffic, and it monitors the traffic. That's very important. And then it's got a subcomponent within it called a scale controller. And the scale controller basically is looking at the traffic and also looking at your function app itself, like, oh, it's an HTTP app or it's an Event Hub app, and here's the concurrency that it's expecting. So based on that, I'm going to make a decision. And it actually votes. The scale controller votes. Should you have more instances? Should you have less? And it's the thing kind of orchestrating the whole rest of the system. So it's making votes. Then we have the data role. That's the next green box on the left. The data role is responsible for placement. It places and schedules your work. And it's going to do a few things, like it's going to talk to the stamps on the right-hand side to see how much capacity you have, and it's going to make a decision if you need more, less, or need to stay the same. So it's in constant communication with the fleet, deciding how much compute is available to you. And that's how we keep you efficient. That's how we keep you elastically scaling. Now, being in the business that I'm in is a little bit rough, because to make that kind of experience happen for you, I'm managing a huge pool and fleet of VM servers on the right-hand side, a gigantic one. That's how we pull this all off. And that's why I wouldn't recommend that everyone here goes and builds a serverless PaaS, because it's tricky. These are the kinds of things you have to deal with. But it's worth it for us. We got there. The next microservice is the controller and the functions pod service, or FPS. You could kind of think of that as the data role as being bossy. It's saying, hey, give me some more servers. Take some servers away and drain them. It's being bossy, requesting what it wants. The controller is actually doing the work on the right-hand side to do those lifecycle events. It will create functions. It will start functions. It will stop them. It will drain them. It will destroy them. It can do all the actual actions. So it's actually kind of the technical implementation of how we pool your applications, where the data role is more saying, here's the desired state. So data role is saying, here's the state I want. The FPS is actually implementing it. And then at the bottom, we have some databases. Historically, when we started out, we did all state management using SQL Server. And SQL Server is a great backend. And when I say state management, there's things like the life cycle, like what state should your VMs and your functions be in? Is there any transaction that started? Well, we need to journal it to keep it reliable. So all that state management has been done in SQL. But we decided to kind of pull off this kind of scale. We added Cosmos DB because it actually has the best latency characteristics of all the databases in our fleet. It almost behaves like a cache. So when you're doing state management, working with something like a cache is really desirable. We could have used Redis as well. We evaluated it. But Cosmos gave us the experience we wanted, and it did it regionally, which is what we also wanted. So that's that side. And then on the right-hand side, I'm going to do another double click on this, but we have something called Legion. And Legion is our custom compute that we built for you guys just for event-driven and container scenarios. So if you kind of think of ordinary compute, you can create a VM or even a VM scale set, which gives you large units of virtual machines that are pretty static. They take a few minutes to create, and they're good for a set of workloads. But in our case, we want an event-driven function, an event to come in, boom, create the container, create the app, process the request, and then go away. So it's much more ephemeral. It's much faster. And so the way that we do that is we take a whole bunch of VM scale sets, and we subdivide them, and we chunk them into nested VMs. So we use Hyper-V nesting, where you have Hyper-V running inside of Hyper-V, and we chunk up this fleet of VMs. And that micro VM now becomes your pod. That's the place where your code can run. And we actually literally do use containers as well, just for our own DevOps efficiency and for our own speed. So we'll literally carve up micro VMs that can run pods of containers. And that, in the end, is where your function is going to run. And we're doing that kind of orchestration on your behalf of creating pods. And there's some complexities here, too. I'm going to get into it more. But like if you're running different runtimes, if you're running .NET 6, .NET 8, Python, Node 22, Java, all these things, like they all need different container images and they need different specializations. So we actually need to maintain pools of every permutation you can think of. And so, I'll get into this, we call these placeholders. But one of the big tricks we do to get past cold start headaches is we create these placeholder pools that are like extremely close, probably to what you're going to run. The only thing that's missing is your actual application, so we can specialize it and serve it to you. So a lot of the game with functions and serverless, it's not about making the VM start quickly. It's about having the VM already started and then specializing it super quickly with your app. That's actually the game that we're in. And as you can see too, there's a lot more going on than just optimizing a VM, because we have to optimize the load balancer. We have to optimize the concurrency. We have to optimize the number of instances you have. We have to do state management. So there's so much more to it, and that's really kind of the business that we're in. So a little bit more vocabulary. I'll spend just a little bit of time on this. So kind of explaining each thing. I talked about, the front end is responsible for all the HTTP requests. The scale controller is doing the monitoring, making the decisions. The data role manages the life cycle of the workers. The controllers can create stop and start. The FPS, or the function pod service, will actually manage those placeholder pools. And then we have state management that's done with Cosmos DB. And we have Legion, which is the actual container dispenser. So now that we have a few of those kind of primitives in our mind, let's see it come together in an end-to-end. I'm going to do two comparisons. I'm going to do a before and after. This is before, and after I'll show you after. So before we created flex consumption, these are like, if I use a consumption plan today, or if I use Elastic Premium today, or App Service today, this is what happens. So let's say that HTTP traffic is coming in. It's going to first, on the left side, it's going to hit that load balancer. It's going to hit that front end role. And then the front end role is going to basically ping the workers to see how many are there and to see if they're healthy. So it's basically trying to gauge the health of the cluster and if you have enough. And then based on that, it's going to make a scale decision using the pings. Now, what could possibly go wrong having a massive scale fleet where you're using pings as monitoring? A lot could go wrong. A lot has gone wrong. So it turns out that was not the greatest monitoring mechanism. And that's part of the reason why I think functions has had challenges scaling and delivering the kind of instances you wanted. It's because of this kind of a mechanism. It got us, when you build a SaaS service, you kind of think about an architecture that'll carry you a year or two. But we definitely hit the point where we had to rebuild it to give you the exact experience you want. All right, so let's look at the latest approach. This is flex consumption. So flex consumption, it's a similar workflow. Traffic is going to come in through the load balancer. It's going to hit the front ends. And then new logic, instead of pinging, what it's going to do is it's going to look at what's the concurrency configuration for each of your function apps. So basically, how many events should it be able to handle per instance? And it's going to make a calculation of, well, here's how many workers you should have based on the traffic I'm seeing and on what you've told me is the right size capacity of your workers. And there's no pings. Pings are toast. So it makes a much better assessment through the control plane. And then, based on that, it can work with the data role in the back-end fleet of placeholders to create more instances. And instead of doing things in serial, it actually can do things in batching as well. So we could do batch pub/sub style processing with the requests, and we can build things a lot faster. And as a result, we can create that burst effect of knowing reliably what you need, right? You stepped on the gas. I have a lot of requests coming in based on, oh, here's how many requests per instance you want. You need way more instances. Let me create a batch for you. Boom. And then it's constantly monitoring to decide, should I give you more? Should I give you less? And it's a much more efficient system, both for you and for us. So let's talk about concurrency. I've been making a big deal about this. And I'll be honest, when I first heard concurrency, I needed my team to explain it to me. I was like, can't we use the top 1,000 most common words in the language to describe what it is. And they're like, nope, it's called concurrency. Okay. So concurrency gives us control over the number of messages per instance. So in parallel, right? So let's look at a couple examples. Let's say that I've set the concurrency to 1. What that's saying is I want each instance of a function to handle one in only one message or request. So let's take an example. If I have 10 executions coming in with a concurrency of 1, it's going to create 10 instances because it's a 1-to-1 ratio. If I cut the number of requests in half, so I send 5 instances, well, the math's really easy, or 5 requests, I'm going to get 5 instances for those 5 requests. So this is incredibly powerful if you have a high computation type workload. Like it really needs dedicated resources to compute and work on that data coming in. It's really good for that. And actually, if you look at AWS's architecture, their entire architecture is based on concurrency of 1. They're always giving you a new instance, a new micro VM for every Lambda call. And that's okay, but we're kind of proud of this one because we give you a flexible and controllable concurrency, and the whole system knows about it. So let's say now I set a concurrency of 2. That means like every instance will handle 2 events in parallel before it goes on to make a new one. So let's rerun this whole scenario. So I'm going to send 10 requests, and you can see it's doubling up. Oh, I'm going to put 2 messages in parallel in each instance, and I won't ask for more instances until I see more. If I send 5, it's going to say, oh, okay, 1 and 2 got 1. Executions 3 and 4 got another instance. Execution 5, even though it's underutilized, it's going to get a whole instance. So you can kind of see how the concurrency lets you have control over what the right size is. And we've debated, and I'll watch your feedback after, should we do automatic concurrency for you? We've totally debated it. We're worried that that's too magical and that you know more about your workload than we do, so we haven't done that yet. Our first step in this direction is we give you controllable concurrency, and what that also means, you're going to have to do a bit of testing and probably load testing, just like I did before, to see what's the right amount of messages and requests per instance. Hey, when do I hit that happy spot of CPU and memory of 70%? That's kind of what you're looking for. And I would encourage you, rather than trying to do 1,000 instances at once, see if you can crank up that concurrency and do more work in parallel. If you do, you're going to save money. You're going to be more efficient. And it'll also speed up the workload for your customers. So a little bit more information about our host. Our host not only knows about your runtime and the version and all that kind of stuff, it knows about the kind of hardware you want. And this is a change, another change in flex consumption. In consumption v1, the one that's out before, it was kind of a black box. You didn't really know what kind of memory and CPU you were using, and it was just kind of magical. But in this case now, you can actually say what instance size you want, just like you can for VMs. So we'll default you to a 2 gigabyte instance, and it has the right allocation of like 1 CPU to go with that. You can go bigger to 4 gigabytes. You can go smaller, even to half a gigabyte. And by the way, we're going to add more and more instances. We just have the 3 in beta, but we're going to add a lot bigger ones. We're actually going to see if we need to add the smaller ones. For us, it's harder to do the smaller ones. The economics for us to subdivide the virtual machines into tiny sub-machines, it's a little tricky. But we'll certainly, based on your feedback, we'll do what you want. In terms of the default concurrency, we've already run load tests, and we've looked at real workloads that are already running in functions. And this is just our observation. This is how we fine-tuned it. For that run-of-the-mill function that's a 2 gigabyte instance size, we've set that to be a concurrency of 16. We've just seen most workloads run pretty well that way. And you can kind of see it's kind of like powers of 2. So as you double the memory, we could double the concurrency. But or it's like powers of 2, basically. And if you go down to 512, we saw a concurrency of 4 work pretty well. But this is completely settable. I think this is where workloads actually will vary. Is it CPU intensive? Is it IO intensive? You have to kind of decide, and you can set that concurrency. But at least it's like one knob. It's not a whole bunch of knobs anymore. Python has a concurrency of 1 by default. We did this because Python has, I won't use the word unfortunate, it has its own point of view about threading and how many threads can run per CPU. So in a serverless environment, that's pretty tricky. And just to keep you out of trouble, we've set you to a concurrency of 1. And that way you won't run into any of those tricky issues waiting for the CPU. So Python's a little bit different. But if you take some small instances with a huge scale out, you can still run Python workloads quite well. And we have some super huge AI customers that are already doing that right now. So far, so good? Makes sense? All right. So let's look at the concurrency control. We'll pop out a PowerPoint. I have a different kind of a demo for this one. So here in VS Code, I have a demo that's basically data ingestion, but the data ingestion is going to it's going to take prompts from the user, and the prompts will have actual files, like files that you want to analyze with AI, and it will ingest those big chunks of data, and then it'll do the processing on it, and it'll do RAG. To give you kind of a user example. So we have a front end, and the front end will take the files from the user. And if you've seen our AI demos, this is going to look similar to probably every AI demo you've seen. So in the RAG scenario, I'm going to take my own files. I have all this health data. Let's take 10. And I'm going to upload a batch of them. Oh, did I take down my function? Or am I looking the wrong one? One sec. I did a deployment a second ago. I'm definitely keeping it real because stuff fails in reality. One second. So I just created this one, and I should have a static web app. That's the front end. Is that the one I was? Witty Meadow? Witty Meadow. All right, let's take a quick look. We won't spend too much time debugging this. My functions are healthy. That does not make sense. Let's just try it again. It's the cloud. Sometimes you just have to try things a couple times. So take a file. We'll ingest it. No. Let's see if we can ask a question. Does my plan cover eye exams? Okay, complete. Paul is like crashing and burning. That's okay, hopefully. I've got a different kind of a demo. Forget you ever saw this. I apologize. I don't know why it's not working for you right now. But I have yet another example of concurrency that I could show you. Because I was anticipating something could go wrong. All right. Did I turn on hard refresh of the website itself? Well, that's a good idea. Let's do a full refresh. It's making me off again. Sir, I salute you. Thank you. You've used Azure, so you know you have to try and refresh again. Thank you. I'm in a very forgiving mood, so we'll take that one. OK, so let's actually try ingesting our data one more time. OK, so things seem to be working end to end. Now let's do that trick. So we're in AI Oslo, and let's watch our function through the lens of monitoring. So we're going to go into live metrics. On this tiny screen, it's going to be interesting. Let's see if I can pull this off. So we'll do this, and then I can do like tile to the right, and I can do like tile to the left. All right, so let's see if we can force some spikes with the concurrency. So let's upload one file and watch it. I think in this resolution it's going to look not so awesome. There we go. So you saw one request, one in, and this is it's a little bit of a bug, but right now if App Insights is monitoring your functions, there's like an inspection effect, and it's causing instances to scale out. So it's a bug. We got to work on that. But that's actually what's going on. Just notice that it's kind of a small number of servers. OK, so it cooled down. We're back at 3. It should be at 0, but I'm inspecting it with monitoring. It's not 0 right now. Sorry about that. All right, so let's do it again. And let's add 10 files. All right, watch here, watch here. Here we go. Okay. That was a little counterintuitive, but I was expecting to see kind of a 1-for-1 ratio, because what I've done is I've set I thought I set the concurrency to 1. Let's actually double check that. But remember, a concurrency of 1 means every one event gets its own server, it gets its own instance. So if I look at my function, you probably know this. If you go to the JSON view, you can see the actual like ARM control plane view of the resource. And I can see, oh, how the heck did that happen? A concurrency of 16. Am I in the wrong resource group? That's a good question. I am in the wrong resource group. I think I'm trying to do too much at once. Let's see. Let's go back here. I appreciate you bailing me out, though. So we'll look at the function. All right. Now, HTTP scale is going to be set here. So this has a HTTP per instance concurrency of 5. So we have it lower. It's not all the way down to 1-to-1, but that was lower. That's why we saw some instances, but not a huge amount. And then this is an important thing you need to know about how functions work. HTTP scaling is done different than message scaling. And it kind of makes sense if you think about it, because HTTP gets monitored by our front end in our load balancer. That's how we know how much traffic is coming in. There's really no other way to know. Messages are different, because we need a way to interact with the actual backend, like the message broker, the queue, et cetera, that you're working with. And what actually does that in functions is the Azure SDKs. Like if I'm working with a service bus, it's the Azure SDK for Service Bus that functions internally is using to keep a connection alive to that message queue. If it's event hubs, which is the case here, I'm using the Azure SDK for event hubs. And you probably also know this, but Azure triggers and bindings and functions are actually just wrappers over the same SDKs that you all have. They simplify and they give you context. And if you use our triggers and bindings, it knows things like concurrency. It knows things like the state of the function, which give you some extra advantages for scaling. But what that kind of means is we need to configure in a different way if we're going to work with messages. And so the way we do that, this came out with target-based scaling, if you followed that a year ago. But we have sections in the host.json. So this is a configuration that goes with your app at deployment time. Right now, that configuration lives here. And event hubs, you might know this too. Event hub is actually a specialized kind of service bus. So the configuration for event hubs and service bus is the same. It'll be in this block called service bus. And that's where I can set the max concurrent calls to 1. So just things to be aware of. You've got to think about concurrency for HTTP and think about it separately from your messages. And so that's how I set it here. Now, maybe we can do one more cool example. I'm going to let this one kind of brew because it takes 2 minutes and I'm going to run out of time. All right, so I'm going to switch gears. I made 2 more end-to-end demos. So remember the first demo I did where we had the event hubs and it was like 2,000 requests per second? So that has, by default, a concurrency of 16 if you take the defaults. So I have 2 experiments here. I have one with a concurrency of 8. So less messages per instance means more instances. So let's run the load test for this guy. So go to my load test. And I'm going to rerun it. You can see I actually ran it right before this demo, right before this session. All right. And I'm going to rinse and repeat. And I'm going to do that for the concurrency of 32. Here it is. We're going to go into the function. We're going to go into the load test. All right. And these have a little bit of time that they need. So let's do... Let's go here. Let's go into the live metrics. This is the live metrics for 8. And we don't see it running yet. Still provisioning. And I'm going to do another side-by-side. Can you imagine the amount of infrastructure you used to have to do this kind of a thing? All right, so let's do... Was this the 8? Yeah, that was the 8. So let's do the 32. I'm racing against the clock. But what I'm wanting to see from this experiment is, can I keep the request rate as high as I want? And if I force the concurrency down, I'm going to expect to see more instances, and I'm going to expect to see less strain and stress on my hardware. Whereas in this case, the 32 case, I'm going to try packing more concurrency or more events in, and I want to see if I can still right-size it without blowing up the machines. And this is going to let me do that kind of real-time cost analysis. I'll tell you what, let's flash away for a second, because I literally am going to run out of time. So we'll flash forward. I think I wanted to tell you a little bit about placeholder pools. So the way that we pull that off... Oh, shoot. Let's just keep it not zoomed in mode. So again, to keep this really fast, we keep pools or fleets of servers. And for every application you have, for every runtime you use, we actually manage different fleets. And that way we can have a ready warm pool available for that kind of permutation of compute that you need. And then we have a process called specialization. I'll leave you with the slides. But specialization is the process of slamming your application zip file on top of an already warm VM and container. And that's how we effectively give you the faster cold start times, more in the hundreds of milliseconds versus in minutes. There's a lot of trickery we have to do. Like I'm kind of trying to represent by the colors. We need to keep track of all your apps and versions. And if your app cold start time gets slow, one of the reasons could be that you're deploying an app that didn't expect. Let's say you configured a .NET 8 app and you deployed a Python app. It's like, oh, I can't find the placeholder pool for that one, and it's going to be slow. So that's one of the tips and tricks I'm going to leave with you. Okay, let's come back here. So here's our A/B test. Again, to remember, this is concurrency of 8. We're doing 40,000 requests per second, not too shabby. Look at the servers. We're up in the hundreds. And let's look at the CPU and memory. I'm not so happy about that. Look at that. I'm like 10 to 20% utilization. That's not good, right? We can do better than that. So now let's look at our A/B test over here. I've got a concurrency of 32. I have to think about why the request rate is different, but it should be the same. Depending on the point in time, it should ramp to the same number of users. But look, I'm using far less instances, and I'm getting closer to that 50% utilization. So what this actually tells me, for this particular workload, which is just light ETL, light telemetry ingestion, I'm going to want a higher concurrency, which will make my bursting faster, because I have less to burst to, and it's going to make my costs lower, because it's just less compute time in parallel that I'm running. So I think this is hopefully a good visualization of what you want to do. And with that said, I'm going to, in the last, I guess I'm over by 1 minute, apologize. So I'm going to leave you with some tips on how to scale. Like if you want to achieve maximum scale, you do want that 1-to-1 ratio of function apps and functions within in a function plan. That means that every single function can have horizontal scale. Think about it this way. If you have multiple functions in a function app, it's sharing. It can have noisy neighbors. So that's another element besides the concurrency. You're better off to choose small instance sizes and scale out versus big instance sizes and scale up. That's going to save you money. Chances are you're overutilizing your VMs. That's not always true, but that's a lot of the times. Watch out for your logging. I didn't get to go into it today. Your logging can actually be a reason why your scaling will fail. So make sure that your steady state logging is the minimal logging you need, and rely on trace level of information, verbose, or debug for the cases that you really need to troubleshoot something. And the rest of the time, keep it at a normal tracing level. And I have a cheeky joke, like you could order some coffee because you won't have time to pay attention to that. For cold start, some other tricks, I'll leave you with a whole article on it. But flex consumption does this best practice, but you can do it for all functions. Make sure you deploy with the run from package equals 1 or run from package equals URL. The biggest determiner of cold start time, since we make those placeholder pools, is actually how fast we could load your application zip. So by using this mechanism, you're simply loading a blob. And as long as your blob is small, your app is going to load faster. So I think this one can really, really help you with cold start. And that said, everything we went through here, the source code, the notes, the CLI commands, and more, is on this gist. And I'll make it better and better based on your feedback. With that said, thank you so much for spending an hour talking about scale. See ya.
Okay, welcome everyone. There's lots of seats in front of me here, so don't be shy. Come in from the edges. Thank you all for coming to visit me so late in the day. My name is Michelle Sandford, and I am a developer engagement lead for Microsoft in Australia. Lots of seats here at the front. What I should start with is the warnings. I am originally from the UK, and we are a very sarcastic people. Then I have moved to Australia, and in Australia, we are even worse. So I know that in Norway you are a very nice, very gentle people. So I want to say up front, if I say stuff that is offensive, try to just say, oh, well, she's only a stupid English girl, and, let it go. Also, I will just laugh at all my own jokes, so don't feel obliged to join in. The too long didn't read of this is, I'm going to teach you how to overcome your imposter syndrome using GitHub Copilot. So if you have come here for anything else apart from that, now is the time to flee. However, I would remind you it is late in the day. You may as well just sit here, and then you'll be able to see Scott Hunter after me, and that will also be glorious. Okay, I'm going to start with a story. Or maybe I should start with how many people do not know what imposter syndrome is? Is there anyone? I realize that actually that question doesn't work because it could be that you are all really introvert and people are afraid to put up their hands. I should maybe test that. How many people are extroverts in this room? How many people are introverts? See, there were 5 people that put up their hands for extroverts. Then there were about 25 for introverts. The real introverts, of course, did not put up their hands at all. You are in the right place. This is a good room for you. You are welcome. Okay, so this is the story about me. I often get that response. Believe it or not, I consider myself to be very introvert, and a lot of other speakers consider themselves to be introvert as well. The reason we are public speakers is a bit of a life hack. We have discovered that if you go to a conference filled with thousands of people and you're an attendee, then there's a lot of pressure on you to walk around the room, to introduce yourself to people, to say something memorable, and that's hard, that's scary, right? Whereas if you are a speaker, you can stand on the stage, talk about the thing that you know all about, and then afterwards lots of people will come and talk to you and ask you questions about the thing that you already know about. So it's a, it's a way that we have come up with to get away from approaching strangers and trying to think of clever things to say. This is me at a conference about, I don't know, actually, so many years ago. And I was super scared because there was going to be 400 or 500 people there, smaller than this one. And I knew that I needed to walk around the room and shake hands and meet people. And I didn't want to do it. I was really scared. So I thought what I would do is I would go early. I would stand on the edge of the room. And I would watch people come in and sort of, psych myself up for it. When I was there, I discovered another little trick that maybe I could do. And I thought, what I will do is I will look for someone that I know, talking to someone that I do not know, and then I will approach the person I know, and they will introduce me to the other one, and that will be easy. So with this plan in my mind, that's what I did, and walked up to a guy, and I said, hey, Pat. And he said, oh, Michelle. Let me introduce you to blah, blah. He is the CEO of the Department of the Big Government Things. I realized I had inadvertently walked up to the most important person in the room. And I didn't have a thought in my head. I was immediately panicking, thinking, what should I do? Can I run? Can I faint? My hands are starting to sweat, and I'm going to need to put it out, and he's going to touch that. And just as all of these thoughts were coming in my head, and I was genuinely considering just fleeing or fainting or something, he leaned forward, and he took my hand and shook it, and he said, "You're Michelle Sandford. I follow you on LinkedIn. I love your articles." I was so relieved. This guy already knew who I was. He already knew what I thought. I didn't need to prove anything to him in those few seconds. He already liked me, and we could just skip to the part where we're drinking a beer and having a joke. LinkedIn, a free tool available on the internet, had worked in advance of me meeting him in person, and it had done a lot of work as my virtual envoy. Now, I'm not going to talk about LinkedIn today, although it is a marvelous tool, and I do have another talk where I talk about that you can find on my YouTube channel. But I am going to talk about, that's the talk, so you can find that one on my YouTube channel. It actually remains one of the most popular conference talks I do today, so I do recommend it. It does teach you to establish credibility from a distance, influence by volume, and access all areas from the factory floor to the boardroom. But we are going to talk instead about my new technological friend, my AI bestie, that is GitHub Copilot. And I'm going to talk about how that stopped me being afraid in so many other ways. Okay, how many of you here have suffered from imposter syndrome? So this many plus all the ones that are still too afraid to put up their hands. Good. I find that even if you don't think that you do suffer from it, there is nevertheless a voice in the back of your head that holds you back from opportunities. And sometimes you don't even notice it, but that voice, that is your imposter syndrome. So perhaps a colleague has said, do you want to go and in this meeting, do you want to be the one presenting? And you say, oh no, I shouldn't do it. I think that Steiner should do it instead of me. And, you know, there's no reason why Steiner should do it instead of you, apart from he's a lot more confident and he's always the one that jumps up. But if you always automatically say, no, it shouldn't be me, it should be him, then he's getting all of the glory and you are the one that ends up going to get the coffee or taking the minutes or doing something that you can very easily do without fear. Fear is in fact the thing that is the indicator that will make you aware of the fact that there is an opportunity in front of you. There is an opportunity for growth. There is something that you can do that will help you level up. So if you feel the fear, you should say yes. If you do not feel the fear, if you automatically think, yes, I can do that thing easily, then you should not do it. You should say no, give that thing away. Give away the boring things. Take the things that scare you. Take the things that challenge you. So, I don't know whether you know this, but there are 5 types of imposter syndrome, and I'm going to go through each of them and then show you some code and how I would use imposter syndrome to overcome that particular, how I would use GitHub Copilot to overcome that particular type of imposter syndrome. So, let's look at them. So this first one, the expert, this type involves feeling like a fraud because you don't know everything there is to know about a subject or topic. Is there anyone that feels that one? Feel like you should know everything before you before you stand up at an event or before you speak up about something, which is like, it's a crazy thought that because especially when we work in technology, everything changes every night. Probably while we slept, Azure must have brought out about 50 extra features. So it's really impossible to know everything there is to know in a given field, but nevertheless, we tell ourselves that we should be able to do it. I have a friend, Lars Klint. Some of you might have seen him at this conference in previous years. The marvelous thing about Lars is, well, Lars has taught me a lot of things. I saw him speaking at Techorama, and he was talking about some Azure Vision cognitive services, and they were new services. And he encouraged the audience to shout out their questions, and he would answer them as they went along. Now, what happened was, as they shouted out their questions and as they asked him things, he did not know a single answer to any of those questions. And what he would do is he would write down the question that they had asked, put it on a piece of paper, and he would say, I don't know the answer to that right now, but I will come back to you on that. Now, it was a brand new topic, and it was new technology, so it was legitimate that he might not know all those answers. But as it went on, every question that people shouted out, he didn't know. But Lars was unbothered by this. He just continued to do his presentation, to show off what he could show, and encourage the questions. And I was in awe of how relaxed and calm he seemed when he was talking about it. And at the end, I went up to him and said, Lars, were you not horrified by the fact that you didn't know the answer to any of those questions? And he said, no, Michelle, what I have here on this piece of paper is the content for my next conference presentation. Everything they have asked me is what people want to know on this topic, and it will make a marvelous future presentation. What we did today was show off what I did know, and that was interesting in and of itself. And I just thought, this is a marvelous lesson for us all. What we are doing in our daily lives is a continuous learning experience. We shouldn't be afraid of that. We should lean into the fact that we can grow more, we can learn more. The things we do not know are opportunities. They aren't failures. So, that is the soft skills lesson, develop a growth mindset and embrace learning opportunities. Now let us look at GitHub Copilot and how I use that. So what we've got here is a piece of code for a simple game of rock, paper, scissors. And I've embraced the fact that I don't know everything, so I have asked GitHub Copilot Chat to show me 10 different ways that I could write the function. So you can write that game in many different ways, and I said to it, show me 10 different ways. And you'll notice that it explains each of those functions, why it's done it this way, why it's done it that way, what it means. While I'm reading those things, I can understand and learn more about it. When GitHub Copilot first came out, it didn't have that chat feature. It just had you could ask for certain things. And what I would do is I would ask for the 10 different ways to write the code, and then I would pick the code that was most like the code I would have written. So in fact, what I was getting was a way for me to code faster, but nevertheless in the same way as I had always coded. What we have from the moment that I have Copilot Chat is I can ask it about the code. So I can, from those 10 different samples, I can look for a piece of code that is cleaner, that is better, that is faster, that is more efficient than the code I would have written. And then I can ask it to explain that to me. And then, because I know that future me will not remember the explanation that I got from that code, I will ask it to verbosely comment the code so that future me will be able to remember why the code is like that. And in this way, it is teaching me to become more of an expert, to be a better coder today than I was yesterday, and to improve the way that I do my coding and not stick in the same restricted, do what you know kind of methodology. Now, in this sample, I've asked it like a bunch of things. I asked it, could it make the code any cleaner? Could it make the code any faster? Could it make the code any better? And each time it will give you different things that it can do. But there is no perfect way to code. The game of rock, paper, scissors can be coded in a million different ways, in a million different languages, and you can learn things from each of that. But there is no perfect way to do it. And the same with your imposter mindset. You cannot reach a point where you know you are perfect in your knowledge, when you know you are expert and you are unfailing. And if you do reach that point where you think that you are those things, you should go to your best friend and ask them to slap you, because that is a terrible mindset to have. There is no such place as I know it all. Okay, so the next one that we have is the perfectionist. My MVP baby. So I have a friend here speaking in another room. I think she spoke this morning. Her name is Layla. She is what I would describe as the perfectionist. And also, actually, Daniel told me he associates with this kind as well. And what it is there is no point in their work, in their presentations, in anything they do where they think, yes, this is good, this is fine, this is perfect. They're constantly asking for more feedback, trying to improve, trying to get better, and it's never good enough. That voice in their head is always saying, you could make this better. So she preps, she over-preps, she practices to her colleagues, to her family, her little children, to everyone around her, and constantly trying to make it more perfect. And that is like a really good way to get your reassurance and to feel that you are better. But in fact, she is perfect, but she will never feel it, I think. So what she does, seek feedback and support from others, is a really good way to overcome that form of imposter syndrome. Okay, then this one. What I've done here with this piece of code is I ask it, is there a better way to do this code? Could it be better? And GitHub Copilot is very kind in that it says things like, well, the code is already very good. The code is already very functional. It's very clean. But if you wanted to make it better, you could do these things. And then it explains each of the things you could do to make it better, and what each of those things mean for the code. So you can put those in. You can discuss with it ways in which you could improve your code, and it will help you surface ideas that you might not have otherwise done. So, for example, I'm writing in Python there, and when I am doing it, if I implemented a bunch of things to write my code in an object-orientated way, it might not be the way that other people within the organization are doing their code. They might prefer a more functional format. They might prefer it to be more procedural. They might have other ideas. But none of those things are necessarily wrong. It doesn't make it more perfect for it to be one way than another. GitHub Copilot is teaching me about each of those ways, and it's giving me the opportunity to put those in. But it's not, there is no perfect way, I guess. So I really like that I can get that reassurance of a pair programmer by discussing it with him, but it isn't right. It isn't more right than what I did originally. And you can absolutely do this with a human pair programmer. But there are scenarios where you might not have the confidence to do so. So, for example, if you're a junior developer and you go to your senior dev with all of your questions. When they are stressed, when they are busy, when they have a big project on, they are likely to snap at you and be very impatient and send you on your way. This isn't what you want for your junior developers. Then what tends to happen is they will go to Google or Stack Overflow, they will research different ways to do the code. They might spend several weeks researching something that in fact a senior dev could have answered for them in a few minutes, because they are then afraid to go back to the senior dev with stupid questions. GitHub Copilot, of course, acts like a pair programmer to you. So your junior devs can ask all of those questions, can sort out all of those things in their mind, can clarify it all. And if they still don't know what is the right thing to do, they still don't understand what would make it approvable for the, what would let people approve that merge request, that pull request, they can go to the senior dev at that point and say, hey, I've thought about this, I've done this, I've thought about that, I've done that, but it's still not getting accepted. Can you explain it to me? Can you help me? And no senior dev is going to be annoyed by that at that point, because they have really done all of their research and they've really validated it all with the help of this lovely AI. I should say, it is giving me some Norwegian subtitles. Are they correct? Are you reading those? Yes, it's all good. That is PowerPoint that does that, and it's available within PowerPoint for free. You just turn that on, and you can say what your input language is and what your output language is, and it will just do it. So it's always a good option, especially if you are speaking to a room of people and you're going to get excited and start speaking quickly. Okay, the next one is the super person. Super person, how many of you have families? And children, young children? Right. And when you are at work, you have a lot of stuff on your plate. When you go home, you are tired and your children want you to tell them a story, or they want you to play, or your wife or husband or partner is like, can you just do the washing up? Can you just put the children to bed? And you're tired after work, but they're also tired because they've been at work. And it feels like you have all of these things that you want to do, that you should be doing, that are your responsibility, and you're unable to juggle them all, and you feel like some sort of failure because you're not doing everything. And at work, we are developers. Well, are we developers? How many of you are developers? Oh, quite a lot. How many of you are infrastructure? Not many infrastructure people. And how many, I don't know, project managers? You are mostly developers, huh? Is there anyone else that's anything else you want to shout out? Obviously, an extrovert person needs to. Managers, do we have some managers? Mostly developers, though. Okay, cool. But do you remember in the olden days where we just coded? And we coded, and we would probably put our secrets and our keys in our code and commit them all. And that was all fine because somebody else would sort out the security and somebody else would test that. Do you remember that? Is it just me? But now, of course, we are encouraged to shift left. And that's right, I should step this way when I say shift left. Shift left. Do your testing earlier in the cycle. Do your security earlier in the cycle. But they never taught us that. We learned to code. And coding is what we got into it for. And now all of a sudden, we are expected to do all of these other things as well. Do the testing, do the security, do the, well, even the infrastructure. You need to do a lot of that in order to just like stand up your stuff before you can even start coding. And they expect you to know all of that, and it's just like a hugely increased workload compared to what it used to be. The good news is in GitHub, these things can also be done for you. But before we get to GitHub, just on the soft skills side, I shouldn't say that, I should say core skills. These are the things that you should think about. Think about recognizing and challenging your negative thoughts, seeking feedback and support from others, celebrating your achievements and acknowledging your strengths, and seeking professional help if needed. When I say professional help, this can be not just a therapist or a counselor. I think that the Americans have been doing this for a long time, and the rest of the world, we have been dismissive of that a lot. But it is something. Having someone to talk to, having someone you can share your concerns with that isn't your family, that isn't your friends, is a really positive thing to do for your mental health and well-being. But for this super person's mentality, that's not the only person you can ask for help. Maybe you want to employ a cleaner to help clean around your house. Maybe you want to employ a tutor for your children. There are other people that you can get in to help you. Maybe it's just your parents. Maybe you're asking the grandparents to do some extra help for you. But don't be afraid to reach out to people around you and get extra help. But what can our little AI do for us? Oops, here we go. So actually here I am not even in GitHub Copilot. I'm just in GitHub itself. And if you haven't had a look at it, there are a bunch in the settings. There are a bunch of security things that you can just turn on now. So it shouldn't be that you are committing your secrets and your keys in your code. If you have all of these things turned on, then it will automatically warn you about that. And when you go to do your pull request to commit your code, it will say, did you realize you've got your keys in your code? Now, you've got your keys in your code and you're not used to thinking about what to do for that. That is fine. You can then ask GitHub Copilot to tell you how to do that. So I asked it the other day. I said, I've got some environment variables here. I just used a code sample and the environment variables were in the code. And I said to it, I want to change that so that they are not in the code. I want to put this on GitHub. Where do I put the environment variables? How do I do it? And how do I refactor the code so that it runs and it's not referencing the environment variables in the code as it originally was? And it just told me exactly how to do that. What I've also done there is I've said, can you write the tests for me? I don't know how to write a test file. I have never done that. I ask it to write the tests for me. It writes the test file for me, and then I just save that and run it. The tests did not run successfully. 2 out of the 3 tests ran, and the third one failed. And I asked it, why has the third one failed? Can you explain to me what I need to do in order to fix my code so that this test will pass? The temptation is then to then go even further and say, could there be more tests? Could there be more code coverage with these tests? And it will do that for you as well, but it would also warn you and say, it would be a bit excessive to have a higher code coverage with your tests for a game of rock, paper, scissors. You do not want it that running tests is actually more of a thing than running your code, So you want to balance these things out. But I like that I can discuss it with it. I like that it can explain it. I like that it will show me what we're doing. And actually within the GitHub part where I was turning on all of the secrets, there was a part where you needed to configure a YAML file in order to set one part of it up. I could just ask it to tell me how to set that up for this thing. And instead of spending all of that time switching out of GitHub and going to Google or Stack Overflow or something, I can stay in the code, I can stay in the moment, stay in the flow, and just ask it my questions and get my stuff done, which is cool. Then the next one, the natural genius. This is the type that involves feeling like a fraud because you don't believe that you are naturally intelligent or competent. Is there any of you that have tried to do something and you couldn't like pick it up straight away, and you just thought, I'm no good at this, I'm not going to do it. Remember when you were a kid as well? Like, or maybe you have kids and you take them to karate or something like that. Take them to some class, to football, to running or whatever. They try the thing and they come in last, or someone pushes them over or whatever, and they start crying and they say, I can't do this. I can't do this. I don't want to do it. I'm no good at it. This is, it's such, like it's a natural response in us as children. I think it's an odd response in us as adults, but nevertheless, we have it. It's so natural that we want to say, I've tried it, I can't do it, I'm going to give up. But in fact, one thing that I like to remind people is that none of us ever walked out of the birth canal. It took 2 years to learn how to walk when you were little. It took 2 years to learn how to eat on your own. Walking and eating are really simple things that today anyone can do it. But if we had given up from the moment we were born, then we wouldn't be able to be functioning adults as we are today. And we should just give ourselves a little bit of a break, not be so hard on ourselves, not expect to be brilliant at things when we haven't even had any training. If there's something that you're trying to learn that is hard, like maybe you are learning a new language, or maybe you are moving from on-premises to cloud, and it's a whole new world, don't get upset because you don't get it right away. Try a little bit today until it hurts your brain, and then stop, and then try a little bit more tomorrow, and then keep doing that every day until you understand it really well, and you won't even remember a time where you found it hard. I think it's really, it's actually really insulting where you find someone and you say, oh, that guy, he's the best coder I know in Rust, he's so talented. I think that's actually a really big insult, because it's as if to say he just started coding and like magic he was good at it. It disregards the fact that that guy worked really, really hard to learn that language, that it was practice, that it was doing stuff, that it was building projects, that it was committing code. So you never see that. In this world, you just see our Instagram filtered lives, and it's easy to think it was nothing. So again, these are, you see a sort of pattern coming in for all of the ways that you can beat your imposter syndrome. Recognize and challenge your negative thoughts, celebrate your achievements and acknowledge your strengths, develop your growth mindset, and embrace your learning opportunities and seek help if needed. I do say, there's a little thing on GitHub that you could create every day called a brag doc. Now, I realize it is not in the Norwegian mentality to brag. No, none of you like to do that, right? You are modest and humble people. But brag doc on GitHub is you create a document, and each day you write down all of the things that you have achieved. You finished that project, you delivered that thing on time, you committed a piece of code that everyone was really impressed by. The things that you do, you write those into your brag doc and you commit those each day. At the end of the year, you have all of these memories, all of this documentation, which will remind you of how much you've gotten done. I say look at it on New Year's Eve, which is the saddest day of the year, where everyone thinks they didn't achieve anything this year and they think they have to join the gym. But instead, you could look at your brag docs and see all of the things that you did actually get done this year, and it will remind you that, in fact, you are doing really well and you're getting a lot of stuff done. If you'd prefer a more physical reminder, you can buy like a glass jar or a glass bottle, and you can write on the good things. You could write your achievements on colored Post-it notes and put them in this jar, and then on New Year's Eve, you take them all out and look at all the marvelous things you've done. That's a fun thing to do with your kids, I think. I don't have any kids. That's just me and my dogs doing that. Okay. So to beat this one, here I just asked my GitHub Copilot to explain it to me as if I'm a new programmer. Do I need to install Python? Do I need to, if I'm doing it in code spaces as opposed to Visual Studio or Visual Studio Code, do I need to install something, or can I just do it up there? All of the questions that normally would delay me, I can just ask them in there and it will answer them for me. I don't need to be a natural genius. I don't need to know all the answers to the questions. Whatever it is that I do not know, I can ask it. In particular, you know, like when you, I don't know whether people still do it, but when you go to interviews for jobs, people do those coding interviews, and you can't access the internet, and you need to remember the algorithms, you need to remember the code snippets, you need to remember the way that you would solve problems. To me, that seems crazy, because we shouldn't be testing people for memory. We should be testing people for problem-solving ability. We should be looking at what do they do when they don't know what to do. So I think it's a it's a really good thing to help us, and I don't think it's cheating if we ask it to remind us how we do things. Okay, so this is our final one, the soloist. And this is the thing that I suffer from the most, I think. This type involves feeling like a fraud if you had to ask for help to reach a certain level or status. I always felt too embarrassed to ask for help. I always felt like my questions were stupid, and I felt that people around me would be well, both annoyed and disappointed by my questions, and so I tried to solve all of my problems on my own. I have a best friend, George, who is a security guy, and he always says, come to me, ask me for help. And a lot of the time, I will mostly solve as much as I can by myself before I go to him. And then he's super upset because he says, why didn't you come to me? Why did you solve this on your own? Don't you need me? Don't you like working with me? And it wasn't about him. For me, it's not about that. It's about me. I just don't want to feel like an idiot. And GitHub Copilot really helps me to validate all of those things and to do it in a really quick way. But what really brought that home for me was my grad hire, Gia. Gia is, so she was a grad hire a few years ago, and when she goes into meetings, she is the first one to put up her hand. She always puts up her hand, she's always asking questions, and rather than making it look like she's stupid, it seems to me that she looks even smarter for all of these questions. And it makes me think, God, I wish I could think of all of those questions to ask, because I would be further along if I had thought of those questions and if I had learnt from them. I did have a I do have a story about Gia and Graham. And I'm going to show you a funny picture for that in a minute. But I'll come to that. So first of all, again, recognizing and challenging our negative thoughts, seeking feedback and support from others, and seeking professional help if needed. Okay, this one I really love in terms of a demo. So I simply said to it, create a REST API for me using something.js, Express.js, and MongoDB. I've never used MongoDB, I don't use Express.js, and it just creates the entire API for me, just like in seconds, which just seems like magic to me. And, you know, on the one hand, I am not advocating that you let GitHub Copilot write all your code for you. You will absolutely not get the best code by getting that done. But there is plenty of boilerplate code that it can write for you, and it is a waste of time you learning how to do that because it's so standard it can just do that for you. But when you don't understand what's going on, you can then ask it to explain that to you. What does this mean? What do I need to change? What do I need to connect? What do I need to make different? And it will explain all of those things to you. Now, I do want to tell this story. This is a picture that I had the AI generate of Gia, my junior, and Graham, who's the senior. The odd thing about AI is it only wants to generate images of beautiful people. Because obviously, Graham is not quite this startlingly beautiful. The other problem is Gia, of course. In this picture, she looks like a child. And when AI is trying to generate images of Asian women, it really can only do very, very young or very, very old. And so I kept trying to make them older and older. But Graham didn't get any less startlingly beautiful, and Gia remained a child until she was suddenly an old woman. So it's an interesting thing. But my story about Gia and Graham is one day I had been trying to build a demo, and it's a demo I've built 1,000,000 times before, and it kept going wrong on this day, and I just couldn't figure it out. And I said to Gia, can you see what is the problem with my code? This is before I had the Copilot to validate my stupid problems. And Gia said, Michelle, why would you come to me? Why wouldn't you go to Graham? He's the senior dev. He would, know what the problem is. And I said, well, actually, I went to Graham yesterday. The problem is, Graham is exactly the same age as I am. Graham went to university in the same era that I did. He learned to code using the same books that I learned to code from. He learned to troubleshoot in exactly the same way. And when I showed my code to Graham, he went through the exact same set of troubleshooting steps that I have gone through 10 times today, and he couldn't see the problem. Please, Gia, look at my code and see what you can see. Gia's, I don't know, maybe 30 years younger than me. Is that right? Can I be that old? Yeah, I am that old. She looked at my code and she said, Michelle, there is a capital letter in your file path. It's a really simple, small problem, but neither Graham or I could see that problem, and we had looked at it over and over. And so what I want to say is having someone to validate your code, whether it's an AI, whether it's another person, it needs to be someone bringing a different perspective than what you have, and there is value in that diversity. There is value in that difference. So what you're looking for when you are building your teams of developers is try and add people to your team that are different than you, not ones that are the same as you. Because it's not, like, what's the point in having another one, another clone? It's better if, I don't know, you have someone young, you have someone old, you have people from different cultures, you have people from different genders. People who see the world differently will help you build better products because they will be more creative, they will be more imaginative, they will see more things than you can see. I kept trying to make Graham look more like an actual developer, so I was trying to get him to be older, him to be less fit. Not that he's unfit, but, he's not this. But, but this was really the extreme edge of the AI giving me Graham. So, yeah, he's using that for his profile pic now. So yeah, those are my key points. Diversity of thought comes from seeing things that others do not see. It wasn't because I was a bad coder that I couldn't fix my code. It was just that sometimes you can't see it, and other people who think like you can't see it. So it's good to have other sources, like GitHub Copilot or like Gia. I'm not going to do that one. Not that one. So I have been talking about imposter syndrome, and I have been trying to say that GitHub Copilot will solve all your problems. I hope I have also made clear that you cannot solve all your problems by going into a room by yourself and talking to your technology, that you do need to surround yourself by people, and ideally people that can help you, that will support you, that will give you good feedback, and that will be there for you. GitHub Copilot is going to be able to do many things for you, but also you need those people at your back. 2023 and 2024 have been very hard for all of us in tech. Even though we have the AI to do all of our work for us, our higher ups have nevertheless been throwing more and more work at us, and the expectations continue to rise, and the work continues to get harder. Support each other, love each other, be a good community, be a good teammate, because I think it will get worse before it gets better. Do take advantage of the tools that you can to help you, but also turn to the people around you for that support. That is the summary of all of the soft skills that you need, but we've seen those a few times. I have here for you some resources, so if you would like to follow a learning path about GitHub Copilot, you can do that there. When you go to the Microsoft Learn page, at the moment it will also have a banner across the top offering you the opportunity to join a challenge linked to Microsoft Build. There is an entire learning path in that Build challenge linked to GitHub Copilot as well, which is next level. So it's not just the fundamentals, it's got all of the compliance, the privacy, the security, the enterprise level stuff in there. It's all about deploying to open source. It's all about inner source, if you have that within your organization as well. So it's really got a lot of interesting stuff there. The Imposter's Handbook is a really cool one if you haven't read it. I think it's on a 2nd edition now. And wait, I think I might not, I have not got the, hang on. I do have another thing to give you. Give me 2 seconds and I will find where that is. That's the correct one. Oh. But this is if you want to connect to me. I would love it if you would connect to me on LinkedIn. Let's be best friends. Don't just follow. Click on the 3 dots and be my proper friend. I also have a YouTube channel with a bunch of things on there. But this is the thing that I want to give you. It's not related to GitHub Copilot, but there is a lot of generative AI being the hot topic at the moment. You might not have the opportunity to use Azure OpenAI yourselves because maybe your company hasn't got it and you're not able to get it in some other way. This is a playground that we've set up, so you don't need an Azure OpenAI subscription yourself. You don't need to use your own subscription to follow these workshops. You can follow there's 2 workshops in there, one on prompt engineering and one on RAG. So it will give you an opportunity to learn about OpenAI, Azure OpenAI, to learn about prompt engineering, to learn about RAG, and without having your own subscription. And I'll leave it open until end of July. And so I hope you enjoy it. The smaller link is just me in a video showing you how to connect to that playground in case it's not super obvious. My colleague tells me it is super obvious, but I made the video anyway. And the voice that you hear in that video is not me speaking. It is a custom neural voice that I made of my voice, so it is an AI speaking in my voice, explaining how to do the thing. So that's pretty cool as well. Anyway, thank you all for sticking with me, and I hope you have enjoyed this as much as I have enjoyed being with you.
Good. Stuff works. Okay, folks. How's everybody doing today? Yeah, you guys are here late. I was worried that this was one of the last ones, and so you'll be ready to party or something. I guess that's why you're still here for the party. I'm Scott Hunter. I've been at Microsoft for about 17 years. You might know me from the .NET days. I was involved heavily. I joined the company working on ASP.NET, and I was part of the migration of .NET Framework to .NET Core, which we started in 2014. We shipped in 2016. And now I work on a combination of the .NET stuff and some of the stuff in Azure. I've got a friend and colleague in front here. This is Paul Yuknovich. He's going to do a cool demo showing how you use functions and AI together. This talk might be a little weird. You might see, I hope you're going to see stuff you've never seen before. That's kind of the intent, is stuff that you just haven't seen. I'm not much of a slide person, so this is actually a demo that we did at Build. And what we wanted to do is take an older application. Does anybody here work on an old app? Okay, good. You know, if you follow Microsoft, all we do is talk about all of our newest stuff all the time. We talk about .NET Core or .NET 8. We talk about Aspire. I'm going to talk about Aspire tomorrow morning, so please wake up early enough and get here. An hour of demos of Aspire will be a lot of fun tomorrow morning. But we do know we have a lot of customers that are on old stuff. And how do we help customers that are on old stuff move forward? And so what we did is we're going to take an application that we built when I worked on MVC. The app is actually 10 years old today, I believe. It's the MVC Music Store. And we're going to move it to the cloud. And then after we move it to the cloud, we're going to show how you would actually use some of the AI tech to find some of the services you might want to use to make the app better in the cloud. And then it gets really cool. This is an old app, but we want to scale it. And so we're going to take Paul in the front row here. He works on Azure Functions, and we just released a new version of Azure Functions that scales at this incredible rate. So we're going to go yank a piece of the app out, put it into Azure Functions. We're going to scale it to, we're going to throw a lot of load at it, over, I think, 1,000 users hitting it at the same time. And then, you know, I'm sure while you've been here this week already, who has been to a talk about AI? In many cases, when you do these talks on AI, you've probably seen all these deep coding stuff and hallucinations and all this kind of stuff. We're going to take this old app that I don't want to touch the code for anymore, and I'm going to hook some AI to it without writing any code. And then I'm going to actually do something crazier. I'm going to actually ask the AI to help me increase the sales of my product. And we're going to show two sides of this. After that, I'm going to show an optimization feature that exists today that I promise nobody in the room has ever seen or used. That's a problem that we have. Literally, the AI in Azure can look at your app and tell you why your app is slow. It can actually show you the code fixes to make it better. Who has used code optimizations? Not a single hand. Perfect. You don't count. And then I'm going to have Paul come back up, and after I show the low-code, no-code, or the no-code version of using AI, we've also built, and we shipped at the Build conference in May, we shipped these amazing extensions to functions that make building an AI app in what, like 10 lines of code, Paul? Yeah, so about 10 lines of code. So you probably saw lots of code this week on doing Gen AI, and we're going to show how to do that in a lot less code. So that's kind of the pitch that we have today. And we'll try to be demo heavy, because that's what I like. Skip all that. Marketing wrote that. So who in the room has ever used or even knows we have a tool? If you have an older .NET application, does anybody know that we have a tool that will help you move that to the cloud? Not a single person. Not surprising as well. So we built a tool called the AppCat tools. We built a Java version, and we built a .NET version. We shipped those technically at Ignite last year. That would be November timeframe is when we would have shipped those. And I'm going to actually use that for this. This is the marketing slide that kind of talks about that. And this is the actual real slide that talks about it. It lets you move an app to a variety of different places, and it's available today. You just don't know it's there, and I'll show that. We'll start with that. So let's find a Visual Studio. This is the right one. And let's get rid of that. So this is MVC Music Store, and if I go back to my browser, I've got this repo. We actually wrote this actually in MVC3, so that's how far back this thing goes. And then we ported it to MVC4 and MVC5, and then I asked John Galloway, who's not here this cycle, could he help me move that thing to make it work today? And so we brought it back alive. But what I've got here, if I go to my Visual Studio and I go to my extensions, I'm in the right Visual Studio, and I manage extensions, I look and see what's installed here. Notice I have a couple things. The .NET Upgrade Assistant, that will move you from a version of .NET to the next version of .NET. That's also a tool you probably don't know exists. If you're on .NET 7 and you want to move to .NET 8, this tool will move you from those two .NETs probably in 3 seconds. It'll go from 6 to 7, 7 to 8. It'll try to go from framework to core as well. I'm not going to show that, but if you've never heard of it or seen it, find it. The one I'm going to show today, also you probably have, this is the one that nobody raised their hands on. This is the Azure Migrate Application and Code Assessment Tool. It's installed in my Visual Studio, and so I can go take this old app, and I can right-click on it, and notice that there is this replatform to Azure. And so what this tool is built by us because we have plenty of customers that call us and say, can you help us move our applications to the cloud? In many cases, we go out and help a customer. We'll do a proof of concept with them on one of their applications. And this tool is literally all the stuff we learned from those proof of concepts. So what I can do, and we put Copilot in here as well. So I can say I want a new report. I can choose what part of Azure I want to move this thing to. And notice you've got things like container apps, you've got app service, all the good stuff, Azure Kubernetes Service. So we can move you to a variety of different sources. In this case, I'm going to choose Windows, App Service Windows. And then I can choose which projects I want to actually have the tool run on. And I can choose whether I want to look at my source code and settings, or do I actually want to look at binaries? Do I want to look at the DLLs that you might have sitting in folders that could matter that we can help you on? And I just click the Analyze button. And what you get is a pile of information. And I'm going to sort these aggregately. And this is going to show me, there's a couple of mandatory things here I must fix. And so one of these, if you're building on-prem applications today, this is saying, hey, you're using Windows authentication so your application can talk to your SQL server. That's not going to work in the cloud. You're going to have to do something different. I have another one here that I can open up. This one is telling me that in App Service, this app is actually targeting an older version of framework, 4.7.1, and App Service runs on 4.8.1. And so it's saying, you don't have to do this, but you might want to do this just to check and make sure it works perfectly before you go up in the cloud. And I'll show one more of these right here. This is an interesting one right here. This is saying that, once again, this is an old application. It's going to have its connection strings just sitting in a web config file. Bad. You don't want to check those in. And so what it's going to do is it's going to recommend moving to a connection builder. That's tech that we built in later versions of .NET, where you can actually swap in something different there. And so for fun, you'll notice that every one of these that I've shown you so far has an Ask Copilot button. So I can, not only will it tell me what it thinks I should do, I can go ask it to explain to me what this really means. And we'll see how long it takes the Copilot to burn the GPUs in the cloud somewhere. But I said we have this Copilot button on every single thing that's here. And we had a customer that told us that they were able to save 80 hours using this tech. So basically it's telling me, hey, I should probably use this configuration builder where I can put my stuff in a better place. And I could say, would this help me use Azure Key Vault? So Key Vault is the tech in Azure where you should store things like connection strings because it's going to actually, it's encrypted and they're not in plain text. And it's going to say, yeah, that's exactly what you would do. And it's going to tell me how to actually configure this to use Key Vault if I want to have the most secure connection strings in the cloud. So I'm going to cheat now. And I'm going to, you don't want to watch me fix all those things. So I'll just go to the, no. Boom, I've just changed the code. And so since I've changed the code, I can go back into that, let's go back over here. Yeah, I know there's security vulnerabilities. I can right-click over here, go back to my replatform to Azure tool, make a new report. It got mad because I really changed the branch. And so it reset me here. But if I run this again, and the right things have happened, look at that. I fixed almost everything for this. And so if I go look at the aggregates, I have nothing except some optional stuff now. And even some of these make sense. It's like telling me right here, I would be better off maybe putting my images and stuff in a CDN versus in my app. But now the app is ready to go, and it's in the cloud. So let's go to the portal. And I'm not going to publish this while we're sitting here. Ooh, service issue. And here's the app in the cloud. I've got a copy of it running up here. You can see the Azure URL here at the end. Come on, Zoom. Zoom what I want. Or don't. But it's got an Azure URL, and you can see this is a really fancy-looking application. But it works. And so now we're in the cloud. Now I'm in the cloud. Once again, I can use Copilot for other things. It's like I can come up here and say, this is a new feature. This is Azure Copilot. And so you can start asking Azure lots of questions like, what other services do apps like mine use? And Paul and I are going to show you a different flavor of this as well. Where this is, first there's the Copilot. The problem with the Copilot is you have to actually click the button, you have to ask a question. You might not know what to ask. But it should come back and tell me that SQL databases, Redis caches, App Insights are the types of things that I would want to use. I can scroll up, take a look at that. There's my SQL. There's my App Insights. These are the things that I should probably be using. Defender for app services. This will make sure that you're not using old NuGet packages and stuff like that in your app. So these are things I might want to use. I could also do things like go up here and say, that's not what I wanted to do. I will tell people this thing's a little buggy, so I just start a new chat. What service would I use to add distributed caching? Now this isn't fair because I'm actually asking questions. You might not care about these questions, but I'm going to show you a different side of this in just a second. So it should come back and hopefully what this actually does is it looks at all the app services out there, and it looks at what types of caches they're primarily using, and it's going to recommend to me hopefully the Azure Redis cache. There we go, Azure Cache for Redis. But as I said, the problem with this is you have to have those questions in your mind. We made a mistake, and we actually used a code name that we put in the portal called Better Together. That's actually something we build internally. Paul's laughing because we both saw this a couple days ago, and we're like, we're not supposed to put code names in the portal. This should actually show what other services should you use, is what it should say. But it's going to recommend similar stuff. It's like a front door in front of my application, a Redis cache in my application. And it's even better than that, because if I click the Create button here, notice it only asks me two questions, the name and the SKU. If I actually wanted to create a Redis cache, it's going to ask me a lot of stuff. Here's what a real Redis cache wants to ask me, do you want all this stuff? Networking, I'm not going to go click through all these things, but there's a whole bunch of things here. There's basics, networking, advanced, and what's going on here is the better together, which will disappear, is basically telling me it knows already what resource group I'm in, it knows the location I'm in, so it can reduce all those questions down and get you hooked up super, super fast. The next thing we're going to do here is we're going to have a co-pilot here as well, that not only will we actually build the service for you, but the co-pilot will then help you put the actual tech into your application. And we call that better together. Code word that should not be seen by the public. And I even put a slide here, cloud service recommendations, best practices, all in the portal. That's better together. The next thing we're going to do is we're going to do some scale stuff. And this is Paul's tech that he wrote, or his team wrote. One of the things that we've had functions in Azure for a long, long time, but one of the things that's super important to our customers is I want these things to be able to scale at incredible rates, because if you're building a music store and suddenly a lot of requests come into your application, before it would take functions, what, a couple minutes, Paul, to scale up? What happens during those couple minutes? Imagine you have a huge, it's a shopping weekend around a holiday, all this rush comes in, and what you're going to do is you're probably going to say, I'm not going to trust the scale up, I'm just going to go set the number to a higher number before, because I don't trust the scale. Now this thing will let you actually scale from 0 all the way to some crazy number, and then when the load goes away, it goes back to 0. And we're going to show that live. Another thing is security is something we really care about at Microsoft. You might have heard in the news that we talk about it a lot internally right now. And so another feature that people have asked for is in the functions world is they want VNets. And if you don't know what a VNet is, I might not want my function to actually be on the public internet. If all I have is my web front end calling that function, I want that function to be hidden away in what we call a private virtual network. And so flex consumption functions support that. And while Paul's here, I'm going to, Paul, the naming, man, flex consumption functions. Oh my gosh, too long. And then finally, we like to think of most of our services, things like Azure Functions, Azure Container Apps. We consider these to be serverless platforms, which means I said before, you can scale them to 0 and scale them right back up. And so, if you want to not get the lowest Azure bill and have us make no money, just use this tech. And so with that, let's go back to Visual Studio. And what I'm going to do here is I wanted to highlight this is basically the MVC Music Store. And so it's going to have its, I'm in the wrong one. Showing the wrong VS. Let's go back to this version of Visual Studio. And I'll close out my report. Don't need that anymore because we're already migrated to the cloud. And close that out. And I've got a store controller here. And my store controller is going to do all of my purchasing and stuff like that. And it's going to do order processing. And what we've done is Paul went and took that method out and put it into a new project. So we're not going to change the whole application. We're just going to take one piece out and move it to another application. And I will switch to the other VS. And we'll show that. And so there's a couple things here. If you've ever tried functions in Azure in the past, they weren't super friendly to ASP.NET developers. You're probably used to, I was part of the ASP.NET team. We built Web API. It does model binding, where basically we take all the parameters to your method. We automatically serialize them. You don't do the manual stuff. Functions before required you to actually do that serialization yourself. Basically, you just got a request object, and you had to go suck that stuff out of it. And then also, all the features that you have in the ASP.NET Core pipeline, you kind of lost as part of that. And so I already saw over here that I've got my logger. So I'm back doing regular ASP.NET Core style stuff here. I've got my method here. And you can see it's basically mapping to the same URL that I had. I didn't really show the code in the other one. It maps to the same URL here. And this is where the new stuff comes in that we have now. There's the from body attribute. And that lets me just put an order there. As I said before, you would have taken a request and you would have parsed this stuff out yourself. We want to make it very easy to basically copy and paste something out of a controller into a function and make it work. It's got the shopping cart ID, it's got the URL, it's doing the model binding, it's got all the logging stuff here, it's good to go. I do want to show as well that not only do I have all of this, but I can also run this stuff locally. So if you've never tried Azure Functions, the runtime for it works everywhere. We have basically we're running the runtime on my local machine here. You can see it boot up. There it goes. It's got the same URL. And then I can go back to over here, and I'm pretty sure I have a test HTTP. This is a feature we added recently where you can put a file in to simulate request. I can send that request, and my function should work locally. There you go. It came back with my test data. Now that's great. Let's move this to Azure, and while it's in Azure, let's show that we can scale this thing at crazy, crazy levels. Okay. So I'm going to go back to my portal, and we'll close out this. Let's move over here. Here is my function running up in Azure. And I can show up here that I'm in the wrong place. Let's go to Overview. And you can see it's got that fancy name that Paul gave it, Flex Consumption. So it's got this new scalability feature in it. And if I scroll down, you can see here's my function right here. I'm going to jump ahead for a second. I'm going to go and show you the metrics on this right now. And so notice we have no traffic, 0 instances of one server online, 0 to 1 server online, but there's no traffic really coming in right now. But we have another thing. I'll laugh and say we were showing that better together. Notice if I come over here and click better together, one of the things it's going to recommend is, I hope it's going to recommend, Paul. There it is. It knows that because I'm running a function, I might want to actually run a load test to make sure my shopping cart's not going to die when we throw a lot of traffic at it. And so if I click that, it'll actually go through a wave of letting me build that test easier than normal. But I'm not going to focus on that right now. I'm going to go back over here. Run what? Can you run the load test? I don't have access to it. I have another one. Security. Oh my gosh. So one of the things that's changed, just a funny side note, security is so important to us that when we do demos and stuff like this, we're not allowed to keep the stuff very long. They don't want us to have just random stuff running in the cloud. And so Paul is saying that they deleted our old instance, and I have not given him access to the new one that I have here. I want to show a couple things here. So load test service, this is a great service we have that basically creates an AKS, a Kubernetes system behind the scenes, and can boot up a bunch of agents to beat the heck out of your app. And so I can go to configure here and test. And you're going to see basically, here it is. I got my process order one here. I can open this up in the portal. It's got that same request that you saw before, that same URL. So I put the URL of my running application into this. I can go over here and click on the body. And pretty much what you saw me testing in the when I ran it locally, it's the same fake data. We're going to take this and we're going to send this to the app 1 million times. And so if you've never tried this service, it's really, really cool. Scroll back up here and cancel out. And maybe I'll show load. This is interesting as well. I have 5 engine instances that I've got configured here, and each engine has 50 users running inside of it. And that means that I've got over 1,000 users. So we're going to basically take 1,000 users and boot them up and blast them at the function and see what Paul's tech can actually do. So let's go out of here. And I have to do a new one, right, Paul? Yeah. Run? It takes 2 minutes. And this is NDC. So I just started that test. And so, as I said, what actually is going to happen behind the scenes is our AKS is going to boot up. It's going to create 5 VMs. And when those VMs boot up, it's going to start sending traffic to my function. And so now we're going to really get to see the total ramp, Paul, since normally what happens is Paul sits in the front row, and about a minute and a half ago, he presses that run button, which means the load will already come and hit us. So we're going to have to wait a second.
I have another one if you want to see.
What does the other one do?
It's the same thing, just a copy. acca.demo.
Okay, so
It's the cloud. You need backups.
what is it?
Scott demo.
So what happens faster, the portal loading? There we go. So while we were talking, Paul spun one of these up on his own machine, I think. Where is that, Paul? There we go. I bet you the other one's actually going by now. Let's go see. Nope, that one's still slow. Yours is slow too, Paul. That was so much faster.
There it is.
Ah. There you go. So if you're watching, it was at 0 when I first moved over here. We got perfect timing. We have 9 servers that we went from 0, and 1 second later, 9 servers existed. We have never in Azure had the capability of being able to boot something up that fast. Because literally behind the scenes, imagine we're booting up a virtual machine, we're putting the function stuff in it, and we're running this. You can see I've got a ton of requests coming in now, 3,000 requests per second. We're now at 18 servers, so we went from 0 to 9 to 18 while you're sitting here in the room. See if it'll go any further. You can look as well and see things like, I love this one. Paul was telling me that notice that our CPU is only running at about 50%. If I'm paying for it, I would actually want to run my CPU probably at 75 or 80% and leave myself 20% of leeway. And I think we have a feature called concurrency where you can dial how much load will actually let each instance of your functions actually have. But now, look, we're at 26 servers, and so just me talking on the stage, we went from 0 to 9 to 18 to 26. I think you should give Paul's team some applause, because I think it's pretty cool. Yeah, that thing is rocking. Let's see if this one is, now mine's going too. So my bosses, they just paid us, what, $600? That was $600? So the fun thing about load test is if you go throw a lot of traffic at it, we just booted a whole bunch of hardware in Azure up to make that happen. And so we laugh. I'll tell you, load testing is amazing, but yet be careful with it because it is expensive, because we boot up a lot of hardware to throw that kind of traffic at your...
Maybe 5 minutes.
Yeah. We run it for 5 minutes. I jokingly, before we came out here, one day I ran it for 20 minutes. Oops. My bosses do notice, by the way. So, the final thing to show is we mentioned before virtual networks. And if I go down to the networking, you're going to see that I do have a VNet attached to this as well. Here's my virtual network right here, which means we're doing all the best practices in Azure. Our function's not publicly on the internet. You folks in the room couldn't call it. It's impossible to call it because it's netted away somewhere. And so that is that. Okay. Let's go back to these slides. Now this slide is really useful. There is no way in heck you can read that stuff on the left. Thank you, team. for producing this. Who in the room has ever used a Logic app? Oh my gosh, that's way more than I expected. I want to come talk to you afterwards and hear how you found out about Logic apps. Logic apps is part of a technology we call integration. Basically, it's a way a lot of folks have used expensive software packages that they buy to do integration. We had something called BizTalk that was very similar. We still have BizTalk, but we had something. BizTalk was our on-premise kind of integration tech. What integration really is a kind of a low-code solution where we have a whole pile of connectors, and you can say when some data is dropped into a storage account, I want to go copy it to AWS storage. I'm making up random stuff. Or when somebody puts a ticket into Salesforce, I want an email to happen. There's a variety of things you can do with that. And one of the things that's really cool is, and if you're in the room, you're going, I don't do low-code stuff or no-code stuff. We have an enhancement to functions coming out, to Logic apps coming out later this year that's going to add some programmability to that. Paul's grinding his teeth. But we've actually added support for Azure OpenAI and for Azure AI Search to Logic apps. And so I can take this old MVC music store and I can add some AI stuff to it. So let's see what that looks like. So currently I'm in trouble from my team because I'm supposed to be in a meeting. This is true. And what I'm going to do is go over here and jump into this. And this is a Teams channel. And so what I'm using is I'm using a Logic app that can actually integrate with Microsoft Teams. And notice down here it says, provide insights and recommendations using sales data on how to improve album sales. And so I'm going to send that message to Teams. And when I do that, Logic Apps is going to kick off. It's going to run an AI query against my MVC music store, and it's going to come back and tell me some intelligence. I think. And I will, once it does that, I will explain. There you go. So it just came back. And I do all of this without actually changing any code in my application, which I think is a cool thing for dealing with an old application. How can I AI-ify it? And so notice what it said here. It's like, it said, analyzing sales data based on genres can provide insights into most popular genres. It's going to talk about identify the artists with the highest album sales. It's basically giving me a bunch of ideas based on my SQL data on how I might actually improve my sales. I'm going to try something funny here. I'm going to copy that. Who's heard about hallucinations this week? Let's do it one more time for fun and see if we get the same result. And then I'll show you how it works. And then after I show you how it works, we'll have Paul come up and show you how you can do something very similar with functions. Let's give it a second here. There's another fun thing is that this Logic app does, now it gave me even more stuff. So this is your hallucinations in action. Notice now it's saying that jazz albums, blah, 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 are top selling albums, therefore investing more in jazz albums can help boost sales. Rock albums such as Queen, AC/DC are also popular. Expanding rock would be a way. And so literally you can get some pretty cool insights from AI, but you might ask, well, Scott, how did you do this? And let's go back to my browser. And first off, this is the actual way that we actually trained this data. So what we did here is we made a Logic app. The Logic app is going to be hit when you hit a URL. It's going to run this code, and it uses the SQL connector to go and just write a SQL query on my database from my old legacy application that goes and pulls all the sales information out. Once it does that, it's then going to call into another logic app that I have called ingest data, and we'll show that in a second. And once that's done, it'll come back and return, yes, I succeeded, I'm good. So let's go look at what ingest data does. And there's just a couple things to highlight here. Let me go back up here. In fact, let me jump back over here. And while I was in the SQL one here, just want to show you some of the craziness that goes here. If I click plus and add an action, you are going to see this huge list. There's over 1,400 connectors for logic apps to a variety of data sources. No. And what I'm going to do is come over here. That logic app is then going to do a couple of things for me. It's going to first take all that data, and we know that you just can't take a pile of data and send it to any of the AI tech. So we're going to first chunk and tokenize that. And if I click over here, you can see that I'm actually using just an HPT connector to do that. I'm calling a REST endpoint. Where it gets kind of cool is down here. I'm going to go, and then this is using my OpenAI connector. I'm going to go and get the embeddings for that. And then once again, I'm going to then go take those embeddings, and using the Azure AI Search connector, I'm going to go put those in a vector database. So I'm sure you've heard all this stuff in talks this week, but notice I did this without writing any C# or any C++ or anything at all to do that. And when I'm done, I've actually put all of that stuff in my vector database, and now I'm ready to make a query. And so if I jump over here, and I'm going to now show the Teams connector. And so what happens here is this is the Teams connector, the Teams icon here. This will be my Teams connector. And basically, it's set to basically look at a channel. In our case, it was the build demo chat assistant. And it will look for a word, prompt. If I see the word prompt in a Teams channel, I'm going to go run a logic app. And then what it's going to do is it's going to basically invoke the workflow for every prompt to go and make an AI query. So let's show that. So this is the AI query. The cool thing about everything I'm showing you right now, I mentioned before, I'm doing this from a SQL database. You can take this logic app as it is, remove that one step, and add a step to go grab that from a Cosmos database, to go grab that from a storage account, to go grab that from the file system. There's a ton of different ways you can actually, so the same logic works. It's transparent across all these things. You don't have to write the code. And so once again, you're going to see that I'm going to go over here, and I am going to go, once again, using my Azure OpenAI connector, I'm going to go search. I'm going to get the embedding back. I'm then going to go do a vector search using my OpenAI AI search. That's my vector database. And then from that, I'm going to get the chat completions from OpenAI, and I'm going to return those. And that literally is how we do AI with logic apps. And so if you've never tried logic apps before, and you want to go take some data you've got somewhere and do RAG with that data, this is a great way to get started. Now, before I show optimizations, Paul, maybe are you ready to come up and show the AI bindings? So, you know, I know people in the room are coders, and so we're going to show a code way of doing this that is way less code than anything you've seen so far. I don't know how we grab you a mic. Are there people in the room that can actually, do we have a hand mic we can use? Perfect. And as I said before, the logic app stuff, if you're anti-no code, we'll have a way for you. Here you go. Test.
Awesome. Thanks, Scott. Everybody? Testing? All right, there we go. All right, so Scott showed logic apps have a lot of superpowers, like the connectors are just amazing. Whether you saw Teams, there's things like SAP, the list goes on. So logic apps is really good for that. I think functions is more when you're at home with 100% code. And we've got a programming model, and we've got the scale that Scott showed. So you can keep going. You know, in the continuum, functions give you a place to keep going. The two work together pretty good, too. So what I'm showing here, this is actually one of our super popular samples for using AI and doing RAG, retrieval augmented generation. And you make fun of Flex.
I didn't make RAG up. That RAG's not a Microsoft term.
RAG's a pretty pitiful name. Anyway, so so you can see this is super popular. Look at all the forks and the stars. But even the README kind of scrolls on forever. And if you look at the code, it does make use of functions, but it does show you there's about several hundred lines of code in the front end, which does the embedding, and also in the back end. So let's say here's the piece that does RAG, and it uses nice SDKs like semantic kernel. But you're looking at 700 lines of code, and you're learning concepts like data points and
So if you take a picture
tokens.
of that, if you take a picture of that URL, that is actually the C# OpenAI search demo we built a couple months ago.
Yep.
And it shows how to do exactly what I just showed you in raw C#. But as Paul said, there's 700 lines of code in just one component of this.
There's really a lot.
There's a lot.
A lot of boilerplate just to get going. So we thought there's a better way. And let me just show you. This is a very similar app to what Scott showed. So I can ask a question. And I guess my typing speed is hindered here. So does my plan cover
Does my plan cover
eyes?
eyes? This is the OpenAI search one, right? This is the big one, or is this?
We might have to do a refresh.
You don't have a live one, Paul. I don't think that one's going to go, Paul.
Yeah, I don't think so either.
700 lines of code is too much code, and so this one's not going to be happy. Why don't we show them the shorter
We'll
version?
keep going, yeah. So we'll show you the shorter version. So here's the... now we're down to just actually 3 key files. And actually there's a great feature called Zen mode. I learned this from another colleague. Ooh, Zen mode. It's all code. So the first function is just uploading a file. So this is business as usual. I can take a stream of files. There's nothing new about this. But now what you'll see is when I queue up that work, I simply can have things like these new embeddings trigger. And the embeddings trigger and binding can basically do all that work for the vector embeddings just by adding this one attribute. And a couple kind of style points here. You can choose your model for embedding, so it can be any of the deployments. You can choose your vector database. Right here I'm using OpenAI, but there's other great vector databases out there like Cosmos DB and Redis, and the list keeps growing. The industry has some. So the nice thing, functions as you'd expect in code, you have a lot of flexibility, and whatever you can write, you can use. So to do embeddings, that's all the code you have to do. It's very concise. Let's keep going. So the ask function, if I want to do a semantic search, I use the semantic search trigger, and I can take the prompt from the user and have my own kind of system prompt. So here's the prompt from the user. Here's the system prompt. And again, I can wire in my choice of models. And that's all I had to do. I just use this attribute, and I'm going to return, as a POCO object, or POJO, I'm going to return the set of search results. So you can see just how easy that gets. And then functions will let you take it even further. We have some more triggers and bindings for AI. So here's one called assistant skill trigger. And if you've heard of function calling in OpenAI, this lets you just translate natural language into an actual function call. So this is super handy if your model doesn't understand the answers to some questions, but you can call an API. Very classic example is I want to look up employees in my Active Directory or my Entra directory. When someone asks about employees in a prompt, I can kind of say, hey, whenever you see that prompt, just call this function, and off you go. So in this case, we extended this RAG to be able to make to-do and calendar appointments just by calling this function, and that happens just by using this natural language. So you can see, hundreds of lines of code reduced down to about, 4 or 5, and then you can just spend time coding custom.
Code your app, not
Yep.
not code the AI.
And I guess let's just see if it's going to cooperate one more time. Oh, it actually did.
Well, can you query it?
So what I was just showing there, Scott showed you the burst scale example of flex consumption, and I'm showing that that kind of new superpower of burst consumption works well with AI too, because a lot of when you're working with AI is massive data ingestion. So we're showing here, just one file turned into one request, which turned into one function instance or server that went online. If I went and did more, so let's do a whole bunch. It looks like about 15 or so, would we guess? No problem. And
4 servers?
Yep, we're going to start bursting up here. Kind of depends on what I set the concurrency to, but just to finish the point on that, with concurrency, all that really means is you can set how many events correspond to how many instances of a function will you make. So if I have a concurrency of one instance and only one instance will handle each parallel request. If I have a concurrency of 10, I'm going to push 10 messages or requests in parallel to a function. So it gives you a lot of flexibility, and this is kind of showing in a visceral way. If I really crank down, if I crank down the concurrency, I'm going to give more CPU power, but I could go the opposite and get more efficiency and save money. So.
Are you going to query it again?
Oh yeah, sure. I think that was.
Or is that
I think we did it. It was quick.
We did uploads. We didn't actually do a query.
Query. I see what you mean. All right.
I want to see it work. Bingo. Yeah.
Awesome.
So basically, he took the same. If you ran that huge .NET application, he did the same thing in 30, 40 lines of code.
Yep. And that was asynchronous, and I used messaging, and even with all that, it was still.
And it scales up and down really fast, and so as you pump data into it, you're getting all that cool scale.
All right, thanks, Scott.
So let's show the next feature you've never seen before. This is code optimization. I had not seen this by myself. Being honest, I had not seen this myself until just recently. There we go. Okay, so let's go back to Visual Studio and make sure I'm in the right one. Not that one. We'll go to this one. And I showed you before, I've got this app in the cloud. So let's open the browser, and we will go to the app in the cloud. And what I'm going to do is let's go back up here. And we'll go to Overview. And if you turn App Insights on for your app service, does anybody knows what App Insights is? Has anybody turned the App Insight profiler on for your code? Not many. Okay, Azure, do your thing. So if I look at this application, I can scroll down and notice that my server response time is all over the place. That means that sometimes I respond quickly, sometimes I don't. That indicates I probably want a kind of flat kind of line there. I don't want a line this way or a line that way. I want more of a flat line there than what I have. And if I go look, I can see that I have no fails. So I'm doing well with no fails. But I'm having this server response time problem. And how might I solve that? Oops. So a couple things to show here while I'm goofing around is, I think I go down here. And here is the profiler. And notice you can see a couple of those bursts that are in there. I can do cool stuff here. I can highlight. If I want to drill down on a section, I can just focus on it. It'll show me more details. Over here, each of these triangles is a time that we took a snapshot of your perf. And each of those is kind of a trace of what's going on. I can come over here and, once again, look at that big one. But this new thing that's down here is, notice I have these top 3 code optimizations. So this is a new feature. This is code optimization. So if you just turn the profiler on in your app, running in Azure, you're going to have access to the performance tab. You're going to be able to come over here, and you're going to see these new code optimizations show up. So let's go click one of these. It's like memory is excessive. And so this is using AI behind the scenes to make this work, by the way. So if I come over here and look, I've got a couple things here. I can click on each of these to see what it is. But this first one, it says queryable.single is causing unusually high memory allocations. Why is that? If you're, before it tells you what to do, let me see if it already told you what to do. Yeah, so it's saying that we thought that it should be less than 1%, but we're seeing 29% memory allocation when this happens. And if you don't know why, anytime you call that method, we have to go look at the entire collection before we pull the first one out. And people in the room probably know the right solution here is going to likely be calling first or default. That's what I should actually be doing here to make this work. And so notice this code fix suggestions available via GitHub Copilot. So I'm going to go back. So I've got a couple things it told me I could do to make this app faster. Just by changing that single to a first or default, I'll use 29% less memory. Memory is CPU. Memory makes your app slow. And so let's go back to Visual Studio. And once again, I'll show in Visual Studio the magic that makes this work. So I'm going to go over here and open the GitHub Copilot in my Visual Studio. I'll open a new window. And I should be on the right branch. And there is a way to actually ask Copilot to go do these code optimizations. I'm going to cheat because I have way too many things in the cloud. I get conflicts doing this stuff. And so I'm going to copy this and paste it over here, and I'll explain what this is. So this is saying code optimizations / connect. And if I only had one MVC music store in the cloud, I could just say MVC music store. For all of you in the room, you probably don't have like 30 of the same thing in the cloud. But in my case, because I have a lot of them, I actually gave it the GUID of the app service that's running. And so it can go out and talk to the correct one. So we'll run that. You are connected to this. Let's see what issues there are. Boom. So basically, when we were in the portal, you would have seen it found a couple of issues. Here's the 4 issues. And then down here, it actually found those same portal issues. And now it's giving me full recommendations of how to change every single one of those. If I want to make a change, notice it's giving me these links. These links are basically the fixes. It'll write the code for us to make the fix. So all I've got to do is click. If I want to go fix that single to not be using single, I click the button. And it's now giving me a preview inside of here what to do. But I click the preview button. It loads it right in Visual Studio. And it's going to show you, there's the single, and it's going to recommend that I change that to first or default. I think that's a cool feature. What do you folks think? Come on, some applause for that. That's a good feature. So if you want to try that, you can actually just go and take a picture of my screen, and you can grab this code optimization. Search for that in the marketplace. You'll find that. That's brand new. It'll tell you how to go turn the right things on in App Insights on your application. Let your application run for a couple of hours. Go to the Performance tab, see what it found, and then right from the portal, look at those things and figure out what you want. go and connect it to Copilot over in Visual Studio or VS Code. This works in VS Code as well. That's not tied to Visual Studio. Something else I should have said when I was over here. Notice that I can also do this. I could decide, instead of doing the fix like I just did, I could just say create a work item and tell one of my engineers to go work on that and make that change for me. And so I think that's about all my time. I hope you all saw something you've never seen before. That was my goal, was to show stuff that you don't see, not this common, file new, whatever. Most of you probably haven't seen logic apps. You have not seen the code optimizations. You've not seen some of the function tech that we have. Or the way that you could ask the portal to help you do stuff, or even migrating to Azure. As I said, I'm here back here tomorrow at 9 o'clock in the morning, if you're not hungover, and we're going to do a whole hour of .NET Aspire, which I'm super excited about. So thank you so much, and I will see you tomorrow, hopefully.